So the world of cloud computing is growing exponentially. More and more enterprise companies across the globe are adopting and moving towards the enterprise cloud. The AWS Certified Solutions Architect's role is primarily to design efficient, effective architecture for robust applications for these enterprise global organizations. Welcome to this course on AWS Solutions Certified Associate Masterclass. My name is Syed and I'll be the instructor for this course along with my team ClayDesk, instructors Kasim Shah, Mara Gol. We're super excited to bring you this masterclass which will help you get your certification as an AWS Certified Solutions Architect Associate, bringing you the latest tools and services, efficient architecture, where you as a solutions architect can not only pass the examination, but also gain solid understanding of different AWS architectural infrastructures. Team ClayDesk teaches a combined 1 million plus students online, and we're super excited to bring you this course so that you can grow your career and level up your career, get that certifications. There's a huge demand, a shortage of AWS certified professionals within the industry. And by the way, you'll be happy to know that most organizations do not even require a college degree. We've had several students get onto the AWS jobs where they don't have a degree yet, they're in progress, right? They're going through college, but at the same time, they're earning six-figure salaries. Let me walk you through the course agenda. The examination itself is divided into 4 different domains. So domain 1 is designing resilient architectures. And here you'll be tested with designing a multi-tier architecture solution, highly available and fault-tolerant architectures, designing decoupling mechanisms using AWS services, and then choosing the appropriate resilient storage. And of course, throughout this course, we'll be working not only hands-on pretty much with all of these different scenarios. Domain 2 is designing high-performing architectures. Here, you'll be able to identify elastic and scalable compute solutions, selecting high-performing and scalable storage solutions, understanding really the performance of all of these, and then working with network solutions for a workload, and then selecting or choosing high-performing database solutions for a workload. So domain 2 covers the high-performing architectures. Domain 3, moving forward, we'll be taking a look at how to design secure applications and architectures. And here, we'll take a look at designing secure access to AWS services, the IAM roles, the policies, designing secure application tiers, and then appropriate data security options. Domain 4, which is the final domain, we'll take a look at designing cost-optimized architectures, how to identify effective storage solutions, how to identify cost-effective compute and database services, and then finally designing cost-optimized network architectures. So each of these domains are divided into various percentage. In other words, the questions will be part or will make up that percentage. For example, domain 1 will have 30% of the examination, domain 2 will cover 28%, domain 3 will have 24%, and domain 4 will have only 18% of the examination. So who's this course for? Well, we've designed this course for individuals who have an understanding of the AWS platform or who have already passed, let's say, the AWS Cloud Practitioner examination. But not to worry, if you're a beginner, since this is a masterclass, we've provided the entire AWS Cloud Practitioner course as well. So you're not going to miss anything out. This is a comprehensive course by far, preparing you for the AWS Cloud Practitioner examination if you're new, or just directly the Solutions Architect. We use a flipped classroom method, so of course we're going to start with the Solutions Architect course first. And then if you're new, you can always jump down to that section that talks about the Cloud Practitioner as well. Why should you take this course? Well, this is the latest course that we've designed that covers all of the AWS services, the newer services. And we know that AWS is changing every single day, changing the services, bringing on new tools. So we are covering all of those tools within these architectures, And by the way, the Solutions Architect examination, the beta examination is here, and then moving forward into the next year, they're going to come up with the newer Solutions Architect examination, and we cover all of those areas within this course. So if you're ready to become an AWS Certified Solutions Architect Associate, this is the right course for you. What are you waiting for? Click on the Enroll button now, and we will see you in class. Welcome back. So let's review some of the test-taking strategy that is effective. So when you're actually taking the exam, the goal is to take the exam in about 3 passes, right? So in the first pass, what I would recommend is to choose what you really know and what you know. So go with the answer that you feel confident about. And if you cannot feel confident and say maybe 5 seconds or 7 seconds or so, and you find yourself sort of going, well, I'm not sure, it could be option A or B, mark that question and move forward, okay? Do not spend a lot of time on the first question. So the first pass is moving with confidence, choosing the ones that you know. And then of course, you do get the ability to review towards the end of the exam and always go back and review all of the questions right from the beginning. Next is the second pass. That's when you use the process of elimination. You start by looking at the available answers and taking a look at and selecting or choosing the ones that you know are impossible or just not right. Right? They're just out of the blue. They could be worded in a way that tells you, well, you know what, Amazon S3 doesn't work that way. Or VPC is just not possible with VPC. Right? So that's the process of elimination. So by using this technique, that narrows your answers right down to maybe a couple of choices, the ones that one of them could be correct. And the third pass, just review. Go through the entire exam and make sure that any questions that you mark and you'd like to spend more time on, now is the time, and you've gone through a couple of times anyways, right? So now you have more time to really think hard on one of those questions that you think, you know, the best possible answer. And try to avoid spending a lot of time up front. Okay, remember the first pass, do not spend a lot of time on one questions. Okay, so just continue on. So you have the first pass, you have the second pass, and then of course the third pass. And you like to get through the exam answering the questions as many as possible. And now that you're done, you're pretty confident on going back and reviewing the questions again and again, if you have time left. So you want to make sure that you feel good about these answers, right? Even though if you're not too sure, maybe 1 or 2 questions, and you're still not sure exactly what the answer is, maybe it's 100% correct, you should feel good that you've done your absolute best, right? There's always room for improvement. And you can always take the course or the exam itself again. And then again, if you've gone through all of those 3 passes and you get to the place where it says, well, yeah, I'm done, I'm finished, I feel pretty good about what I know, right? You've expended all of your knowledge. So it's okay. Take your time. Do not be in a hurry. We typically get anxious when we take exams, right? So if you have the knowledge, skills, and abilities ingrained in yourself, just do your best. And that's all exactly what you need to do. If you panic, guess what? Even if you know the answers, you may answer them incorrectly. So to the best of your ability, you should answer all of these exams. So this strategy has kind of worked, and has worked with other students as well that have obtained feedback. So go ahead, when you take the exam, remember these 3 passes, and of course, going back to your questions and making sure you do the best you can. With this, let's move to the next lesson. Welcome back. Super excited. Moving forward, in this just brief lesson, I'm going to talk about the actual AWS training and certification, more specifically the AWS Certified Solutions Architect Associate Exam guidelines, the syllabus, and details, different domain areas that we'll be focusing on throughout this entire course. So basically, the AWS Certified Solutions Architect Associate is for individuals who are performing or wishing to form a solutions architect role.
It basically, the exam validates all of your skills, knowledge, and abilities so that you can create robust applications on AWS technologies. You can manage, you can create a fault-tolerant, reliable, resilient architecture on the AWS ecosystem. Basically, the objective as per AWS is define a solution using architectural design principles based on customer requirements. So this is the person who actually goes out to the customer maybe and gathers all the requirements from the customer, sits down on the drawing board, creates the architecture, right? Knows which tool, which task, what is the most efficient methodology, the structure, the design, the guidelines, best practices, and then of course takes it back to the customer and process begins. It also provides the implementation guidance based on the best practices to the customer. The recommended knowledge is you got to have at least 1 year of hands-on experience on designing available, cost-efficient, fault-tolerant, and scalable solutions on AWS. So you'll notice that if you have the AWS Cloud Practitioner certification, wonderful. Then you'll have a great stepping stone moving forward. If not, then of course you need to go through all of those lectures first, get yourself acclimatized, practice, do a lot of hands-on, and then become ready for taking this particular exam. Now I'd like to jump down to the domain areas that we'll be covering. I'm going to provide this, by the way, as a downloadable resource so you, on your own behalf as well. The passing score is 720 out of 1,000, so you need to just be aware of that. Here's the content outline spend time on. So domain 1 is design resilient architectures, and that's exactly how the sections are going to be covered. So I'm going to provide sections on design resilient architectures with several sub-lectures within this particular domain so that you're comfortable with all of these areas. This covers about 34% of the exam. The next topic that we'll be focusing on in depth in this course is defining performant architectures, which is about 24%. Domain 3 is specify secure applications and architecture, 26%. So there you go. The very first 3 domains pretty much cover, a fair amount of exam content, right? Almost 80% or so. Domain 4 is designing cost optimized architectures. And then domain 5 is define operationally excellent architectures. Do you realize that the common term in all of these domains is architectures, right? So not so much focusing on technical tools and what they do and how do you go about doing something. It's actually your understanding and in-depth knowledge of how to apply these tools in different architectures, how to create and design fault-tolerant, reliable, resilient AWS solutions for your customers. And that's the real neat part of this exam. And we'll cover all of these areas, domain areas 1 through 5, in depth within this course, along with additional areas which are helpful for the base level certifications such as Cloud Practitioner and other knowledgeable areas such as building a DevOps pipeline and so on. So I'm going to provide this document, so go through it. If you have any questions, feel free to reach out, let me know. We can cover more areas. If there's certain other topics that you wish us to create lectures on, feel free to let us know. We regularly update our courses and bring you the latest and greatest knowledge so that you can level up your career. So hope this helps. Let's dive right in with this. Let's move to the next lecture. Now let's take a look at the actual exam itself, the syllabi for the AWS Certified Solutions Architect Associate, which is SAACO2, right? That's the exam guide. I'm also going to talk about the actual differences from the previous version of the exam as well as the new. Not many differences, but you will see shortly that there are some key differences. Diving right in, let's take a look at the actual exam itself. Pretty straightforward. The recommended knowledge, that's what I'm going to start from, is you need to have about a year worth of experience in designing available, cost-effective, fault-tolerant, and scalable distributed systems on AWS, along with, of course, hands-on experience in compute, networking, storage, databases such as DynamoDB, RDS, and so forth. I'm going to cover all of these concepts from scratch in this entire mega course. So not only you understand basics if you're a beginner, but if you are an experienced AWS user or power user, then you can jump directly to the solutions architect sections. You also need, of course, some understanding of basic architectural principles, global infrastructure, the ability to identify and define technical requirements for an AWS-based application, along with which AWS services meet a given technical requirement. So this is recommended general knowledge that you need to have before you can dive into this particular exam itself. The exam preparation, give you a couple of areas such as training and white papers. I'm going to cover extensively in this course because these are very, very important. These are technical papers, technical solutions, technical architectures, and gives you a solid understanding. So we're going to be covering a lot of these throughout this course in our hands-on labs. The exam content is basically straightforward, multiple choice, and multiple response. We'll be covering several sample questions, sample exams. I'm going to give you several resources that can help you prepare and pass this exam. Let's scroll down. I'm going to get down to the basic domain or the different areas or the percentage of examination. Now, before I do this, just quickly one sentence on the minimum passing score, which is 720 out of 1,000. All right, great. So let's take a look at the course out. 4 domains. In the previous version, there were 5 domains. So I'm going to briefly show you that as well, just so that you can have comparison between the newer version of the exam versus the older version. So the newer version here, you have domain 1, which is about 30% that covers the design resilient architect. Domain 2 is design high performing architectures, 28% the examination. Secure applications and architectures covers about 24% of the exam itself. And then designing the cost-optimized architectures covers 18%. In the previous exam, let me switch to that. Great. So you'll notice behind I have the newer version of the exam, and then on this window right here, I have the older version of the exam. So just to compare the two versions, you'll notice that in the newer version, there are only 4 domains versus the 5 domains being covered in the old version of the examination. The domain 5 is no longer being tested in the newer version, which is define operationally excellent architectures, which cover about 6% of the exam in the older version. Whereas in the newer version, this seemed to have merged into the design cost optimized architectures, or more focus rather has been placed on the cost optimization architecture as far as the pricing and then of course the cost analysis. That's the little difference. And of course, there's some examination percent is also different. For example, in the older version, resilient architecture covered about 34% of the examination, whereas in the newer exam, only 30% been covered. Whereas the performant architectures is also being increased in the newer version. So this gives you a nice idea as a sort of like comparison between the two versions of the exam. We are going to be focusing, of course, on the newer version. So I'm going to minimize the old one. There we go. And we'll be covering all of these core domains so that you're able to pass the examination. And like I said, this is a mega course, so you'll have several basic lectures also on other AWS services, like I said, VPCs, DynamoDB, some basic knowledge. So you have a solid understanding of not only all of the AWS services, DevOps, I'm going to touch base on pipelines, touch base on machine learning aspects and how to develop architectures and run hands-on labs and almost all of the areas of AWS services. So if you go through this mega course, passing your first exam, which is the cloud practitioner, should be a breeze. And then, of course, our goal here, the objective is for you to pass the solutions architect associate exam. So the rest of the PDF kind of talks about in detail 4 domain areas and what's going to be covered within those areas. I'm going to provide you this PDF so you can download and take a look at it, so you can actually go step by step, domain by domain, ensure that you have learning experience, not only just the concepts, but also hands-on as well. So this is just the basic domain or knowledge for the new examination. Just wanted to cover this and also give you a nice comparison between the old examination. If you have any questions, post in the discussion area. I'll be glad to help. And with this, let's move to the next lesson.
Now let's talk about the hands-on experience aspect. You probably, I'm going to say this several times moving forward. Nothing beats hands-on experience, right? This is the greatest way you can actually learn effectively and then ask questions as you do your own hands-on workings within the AWS ecosystem, tools and services. So you got to roll your sleeves up, right? Get into the AWS ecosystem, create VPCs, work with S3, or any other tools and services, create subnets, work with, Route 53, for example, right? Create load balancers. And that's the best way you can actually dive in and gain the experience. Of course, I'm going to provide all of this course as a hands-on experience as well, so you can see several things in action and how things work. But more importantly, for a solution architect, it's the design effective architectures, right? So, of course, the course is focused primarily and strictly on the exam itself and the agenda for the exam. But with this, I'm going to give you all of the hands-on tools and services within this course. So there's several other tools that I'm going to provide, like the labs, for example, that you can go online and practice. I'm going to provide you those links. And AWS provides those as well. So there's several resources that we can gather and learn from, not only from my own experience, for example, or experiences from other instructors or students, but additional resources, white papers, quick labs, right? So, I'm going to talk about, like, for example, the Amazon Black Store, right? You can take those as labs as well. I'm going to provide you all of the links and resources. So, for example, introduction to Amazon Elastic Block Store, load balancing, these are all labs that you can practice on. But once again, the best thing is create a free tier account on AWS, jump right in, follow through all of these, exercises and labs that I'll demonstrate hands-on. Just go through the process. For instance, let me give an example. Let's say I'm going to provide you a complete developer tool DevOps pipeline, right, from scratch. So you can just follow along the entire processes and see how the pipeline is created, right? How it's managed, how it's monitored, what are some of the efficient areas, and then of course stepping back as a solution architect and really understanding the requirement of a DevOps pipeline, application development, right, from scratch to all the way to the client end. So these are the areas that you need to focus on and really need to work hands-on on these activities. And of course, as you do these hands-on labs and work within the AWS ecosystem, I'm always here to help. Reach out. So with this, practice, and let's move to the next lesson.
Welcome back. Super excited. In this lesson, I'm going to talk about the new AWS Management Console and some of the areas that you may find some additional services, some additional tools. So as soon as you log into your Management Console, you will notice several set of services. So under all services, there are several new ones because what Amazon does, it keeps adding additional services, additional tools. For example, let's scroll down to the basic ones, such as the security, identity, and compliance. Now, in the previous AWS Management Console version, you may not be able to find several of these services. Here, you'll notice services such as Amazon Macy, for example, or Cloud HSM, or all of these are newly added, or AWS Signer is one of the newest, right, services that you can actually use. Similarly, under management and governance, you'll see a whole set of new services. For example, the personal health dashboard, Amazon or AWS Proton, Amazon Grafana, Prometheus, and so on. As you move within the AWS ecosystem, you will notice that in the next coming months or so, you will see even more. And tools for IT admins, security administrators. So in this lesson, just quickly scroll through all of these. And again, there are so many of them. Amazon continuously keeps adding all of these services. Machine learning, you'll have Amazon Code Guru, which is excellent because it helps you identify code and reduce cost. So if you have redundant code, you're going to go ahead and take a look at that. And there are several other services as well. So let's not be overwhelmed by all of these tools and services as you work through the ecosystem, and based on your specific niche or skill set, you will only work with certain services. So one of the other things in the management dashboard, if I were to scroll up, you'll notice on the top here, there's a search bar, which is available for you to search for services, features, and marketplace products. For example, if you need to deploy a VM or some pre-configured Amazon images, you could simply navigate to Marketplace. Let me give an example, more specific example. Let's say if you were to deploy a WordPress website, right? Fully configured, you don't have to do any configuration. You could simply navigate to the Marketplace and type WordPress. And it's going to give you install WordPress best practices, plugins, and this is really what the images I'm talking about is fully configured WordPress website. All you need to do is just pick up one of the marketplace. There are certain charges, there's certain times they're free, but sometimes you may incur certain charges as well. So just navigate through and take a look at these. And lastly, there's an icon called the Cloud Shell. And this is fairly helpful, something new within the AWS Management Console. So if I were to click on the Cloud Shell, it opens up a new tab, and what it does, it allows the Cloud Shell in the cloud. And this enables, which is simply a browser-based shell, which gives me command line access to AWS resources. So if I need to, let's say, create a new bucket, I could do so right from the Cloud Shell. So this is really helpful if you need to do something fairly quickly. If I were to close this, and here's the Cloud Shell. So for example, if I were to execute a command such as AWS, it's going to give me the version, okay? Similarly, I can execute other commands such as AWS configure and be able to provide access keys to a profile user. In this way, it's really helpful whether you're in the US East region, Virginia, you can change the region, and you can use other commands as well. Under actions, you'll be able to open up a new tab, rows, columns, and so on. We'll restart the AWS Cloud Shell. So let's switch back to our Management Console. So once again, just quickly going through some of the newer areas within the Management Console. So go ahead, explore all of these services and tools. These are helpful for if you're pursuing a certification or otherwise if you're working within, let's say, the DevOps pipelines, machine learning, or whichever area you're focusing on. So I hope this helps. If you have any questions, post in the discussion area. And with this, let's move to the next lesson.
Welcome back. Let's review some of these services for study purposes. So I've organized the list according to the 5 pillars, right? That we talked about, the well-architected framework, and according to the remaining modules within as we move forward within the course. So these services do repeat as we go and move forward within this course on various disciplines within our use of AWS. So we have the Amazon Virtual Private Cloud, or the VPC, giving us the ability to create isolated networks. And of course, those networks allow us to use multiple availability zones, right? Giving rise to resilience or loss of a data center, for example. We have the AWS Direct Connect, for example, that gives us high-speed private fiber connection. We have the Amazon Elastic Compute Cloud, EC2, giving us on-demand virtual machines or instances, right? You have Amazon Route 53, which is Amazon globally distributed, very reliable DNS service, allowing us to perform a number of types of DNS routing, including failover. So we can failover from an endpoint that is failing to an endpoint that is actually working. We also have elastic load balancers, right? So Amazon CloudWatch, which monitors the systems, right? and reports, creates logs, right? Any issues that might affect the reliability itself. We also have the Amazon SQL storage, right? Or S3, for example, which plays an integral role in storage data or different types of data, objects, images, you name it, you name it. It just stores everything. So these services, when used together in the right ways, help the solution architect build a reliable infrastructure, right? That I'm going to talk about, of course, in depth as subsequent lectures. And then we have Amazon Glacier. You can archive data for long-term storage in case you ever need to reach out and use the data again. So again, this group of services are used, if correctly, right, you will have a reliable system. And I'm going to talk more about each of these in depth as we move forward. For performance-related areas, we have autoscaling. You can match the supply of resources with the current demand. So you have Amazon Elastic Block Storage, allowing you to create a highly performant storage volumes. You also have Amazon Elastic File System, for example, EFS, or VPC also, networks, which basically run, and make your application, or provide your applications the correct infrastructure. Then you have the ECS, providing you more effective utilization of resources of virtual machines. We also have CloudWatch, right, that provides you monitoring, so you're aware of the performance of your entire infrastructure. Another one, we have the RDS, Relational Database Service, allows you to offload databases to AWS, right? And then we also have the high-performance NoSQL with Amazon DynamoDB. And these services, when you use them together, can help you create a performant application. And of course, I'm going to talk about performant applications in subsequent lectures. For security, right, we have the IAM services that allow you to create and manage users' credentials. You also have the AWS Security Token Service, which creates temporary credentials. You also have IAM instance profiles, roles. You can, create policies, delegate permissions to EC2 instances. You also have AWS, organizations that allow you to, create and manage multiple accounts. So you can isolate the resources, right, according to different business units, maybe HR, marketing, regions, and so forth. You have AWS Config, which maintains a constant, and constantly evaluating the environment, checking all of your resources, the state of your environment against rules that you can specify. So you can be informed of any unauthorized, maybe unexpected changes or access, and so forth. We also have CloudWatch logs that, applications can send, and you can take a look at those, right? It stores them in a central place. So you can collect those logs, and from there, you can do a number of activities, right? And maybe create automated processes, monitor and create a secure environment. You also have the Amazon Elasticsearch service, which works hand in hand with CloudWatch logs. That gives you the powerful way, a visualized, so to speak, and you can analyze those logs by taking a look at them. And of course, lastly, we have the VPC security group, along with network access control lists and other mechanisms that you can actually use to create a secure network for the applications, the entire organization as well. Also, the key management service, right, or KMS, which allows you to encrypt your data, right, at rest, for example. So these, some of these services I'm going to talk about, of course, in later lectures as well. For cost optimization, let's talk about that. We have the Amazon CloudWatch, allows you to monitor your infrastructure, as well as your current, estimate charges. So you have the Cost Explorer, you have the dashboard, you can optimize your billing. You also have the AWS Trusted Advisor, which performs regular checks of your environment and suggests ways that you can actually improve a number of things, like reliability, performance, security, and cost optimization. You also have, let's say, reserve instances, spot instances, and other types of instances as other ways of saving money and other billing models. You also have AWS Cloud Formation. You can create temporary environments, right? design your own temporary environment, that you only pay for using that resources within that group. You also have the Cost Explorer, like I mentioned earlier, right? You can take a look at a visual graphical way of your costs and really understand where you're actually spending money on which resources. We also have billing alerts, which are pretty important. So even with an AWS free tier account, for example, make sure you set the billing alert. So that gives you the ability to get an email notification, right? So all of these collection of services, tools, and features, when used in the right way, will help you design the most effective solution. And that's the solutions architect job, right? And of course, I'm going to break all of these down into smaller pieces, gives you hands-on on all of these services and tools. Finally, we have the operational excellence. So we have the Cloud Formation tool, right? That helps you automate and create and manage AWS services. You have the code commit, right? Private Git repositories. You can create the entire pipeline, right? DevOps pipeline, so to speak, that works hand in hand with code commit, code build. You have, other areas that you can really achieve operational excellence. You have AWS Lambda, right? You can create scripts, for example, to automate things. So that way your teams can focus on writing code, for example, just to create scripts or handle all of what is necessary that needs to be automated, and then actually use these scripts for other purposes such as deployment. Then again, we have config once again that helps you monitor the entire infrastructure as rules designed by you as a solutions architect, right? So that it helps you gauge what actually is going on with the entire AWS ecosystem. And once again, monitoring CloudWatch is the best way. You can take a look at these logs to collect everything. So, for example, you can have a log of who logged in, the usage of instances, and you name it. So a key component of operational excellence that, of course, I'm going to talk about later as well is being aware and being educated, continuous monitoring of your resources and tools, and continually evaluating all of these services and tools, and leveraging automation to really create an effective infrastructure. We also have the SNS, or the simple notification service that Amazon offers, right? Whatever happens, you get notified, whether it's the alert or email or whatnot, right? And that's real time. So as things change, you have the ability and you're on top of things. And last, we have the Amazon Athena, for example, that allows you to, let's say you're collecting all these logs from Amazon CloudWatch, and you have a massive amount of log data. You can then throw this into Athena and use the service. And you can query those logs, right? And then derive meaningful insights of what's going on from these logs. So when we look at the long list of services, it might seem a little overwhelming or daunting, right? But over time, as you work hands-on with these services and tools, you will definitely gain more insight and become more confident in using these services and tools, and actually get the entire architectural concepts as well that surrounds these tools and services. And that's really the goal of the solutions architect. It'll help you not only pass the exam, but more importantly, increase your skills, abilities, your knowledge on how to design an effective architect. Wait, one of the more important things is when you go to an interview, for example. I've had students come to me and ask me lots of questions. Like they ask me this on the interview, they ask me that question on the interview. This course will definitely prepare you to answer all of the questions that companies are looking for. Enterprise organizations are actually wanting, and they're going through some of the pain points. And any organization interviewing you as a potential candidate for a job, right? They will ask you all of these pain points that actually are occurring within the organizations. So we are going to provide you all of those areas within this course as well. So I hope this helps. Just wanted to run through all of these areas to give you a better understanding moving forward. I hope this helps. If you have any questions, post in the discussion area. And with this, let's move to the next lesson. Welcome back. Now let's review the best practices within AWS. AWS Best Practices white paper is available. I'm going to provide that as a downloadable resource, and you can see the URL here as well. And I would highly recommend that you read through within your studying for the certification. I would certainly recommend this at least a couple of times, if not 3. But I'm going to summarize these best practices here. First, enable scalability, right? Scalability gives you the ability to, let's say, meet the demands of your clients, whether the demand is coming from a client or more web requests or more API requests or batch processing that needs to be done. Maybe that demand is more, videos that needs to be transcoded, whatever it is. As the demand rises, you need the AWS ecosystem to scale along with that demand. So if your system cannot scale and yet the demand continues to rise, at some point, of course, things are going to be unavailable. And that scalability also applies not just to compute, but also storage as well. As your storage requirements grow, so should your storage capabilities. So you should enable scalability and some other services like S3, for example, scale automatically. Other services like VPS may need to be provisioned in order to grow the storage. Think of EC2 and other tools and resources as being disposable. So when you think of them, that kind of gives rise to a level of flexibility and agility that you as a solution architect will need to have. And you need to treat these servers, you're not trying to keep these any one resources alive, but instead you're actually flipping the paradigm over and treating these resources as disposable. That gives you the ability to simply throw them away if you don't need them. And also it gives you the ability to have an effective environment. You can perform experiments, test your prototype, get your results, and then throw that environment away, right? And stop spending money on it. So instead of working really hard to get any one machine back into the movable state, you can just throw it away and allow automated processes to do their job and maybe spin up a new instance or new machine. So you should also leverage automation. And I cannot stress this enough, right? Automation is key. It's going to make your life a lot easier. So the only way to truly realize all of the benefits of cost savings, the agility, the flexibility, the efficiency, operational resiliency, for example, that is achievable through actually automating the processes and leverage the key concepts. I'm going to talk about those, of course, in subsequent lectures. Another practice is to leverage loose coupling, right? So instead of having, let's say, multiple components tightly coupled, right, that are inherently aware of each other and independent of each other. So let's say, to avoid cascading failures. So you can avoid those type of failures by leveraging loose coupling. Maybe you want to have load balances between different tiers. Any one component does not necessarily have the relationship on something else. It's not dependent. So loose coupling says that one component continuing to do its own job while the other component suffers the failure. That's what loose coupling is. Another best practice is to leverage services, not servers. The idea is that we want to give power to our team to focus on building and adding differentiated value, right, to the applications, rather than being burdened by managing the infrastructure. So the more you can leverage these services rather than hardware, right, rather than servers, the more you can offload the burden and shift. So these are some of the areas that the white paper offers. Another thing, as far as databases are concerned, so for any particular scenario, for example, there's always room for relational data, and there's sometimes, there's room for non-relational data also. There's a time and a place to use, within the caching itself or within the databases, or replace or use the data warehouse, right? So instead of thinking, well, I'm going to use the relational data for everything, right? Or SQL for everything. Really take a look at, do your research, investigate which database technology actually makes the most sense for a given project. And then look around, take a look at these services, which fits the best. Another best practice that helps the availability is to avoid a single point of failure. So single point of failure leads to definitely downtime, right? If one thing fails, you have no built-in fault tolerance. That means your time to recover will be longer, right? It's going to increase. And then of course you want to optimize the costs. Cost savings, it's not necessarily number one for the solution architect, right? But you want to keep that in mind. Could be the primary reasons as far as the organization is concerned, right? And that's why the organizations are actually moving to AWS, is because of cost savings. So you need to be aware of the pricing and the cost optimization and monitoring as well. Another best practice is to leverage caching. You can cache certain types of data, any number of different areas where there is an opportunity to cache within memory, for example, so you can get results faster. There are, number of ways and opportunities you can get a number of types of data, both static and dynamic, right? And then move it closer to the end user. So you can leverage caching, would certainly improve the performance of the overall ecosystem and the user experience. You also want to apply security in layers. So you have tiers of security layers, right? And AWS provides a number of tools and services, both, whether it's in the production or the credentials themselves, the IAM roles, the policies, and so forth. You can configure firewalls for a certain network. You can have security within your data. So data could be encrypted, right? Going back and forth. And there are a number of options that how we can go about this. And then, of course, there's security of our operating system, security of our applications themselves. So you should be looking at all of these right tools for all of those different layers of security. So I hope this kind of helps. These are the areas that we'll be actually working and diving deeper into subsequent lectures, designing architectures, giving out framework as we move forward. But just the best practices in the white paper, I would highly recommend that you go through this white paper a few times. And of course, any questions, let me know, post in the discussion area. I'll be happy to answer. So hope this helps. With this, let's move to the next lesson. Now let's review the well-architected framework, which you've used before also. So as we move forward, the lectures are based on the well-architected framework, which is a collection of white papers. Now, this forms primarily the essential knowledge that you need to not only pass the exam itself, but also really become an effective solutions architect. The well-architected framework is simply a collection, like I mentioned, right, of best practices, processes, techniques, concepts that you can gather over the years, right, by hands-on experiences from various Amazon clients from across the globe, like large companies such as, Netflix or other companies, 20th Century Fox. So how these companies, enterprise companies, have actually solved their challenges. So the well-architected framework is presented in 5 pillars. So you have the reliability pillar, which talks about the availability, right? And building systems that are reliable and resilient. You have the performance efficiency, which we are going to talk about in depth. Basically the efficient use of computing and storage resources and other tools within the AWS ecosystem. Then you have the security pillar, which talks about securing our applications, securing a network, whether it's data security. Cost optimization pillar guides making decisions on how to save money for the organization. And then of course, lastly, we have the operational excellence pillar, which is really about the processes and methods and practices basically that the business uses to deploy and manage AWS services. So again, as we move forward within this course, the rest of the lectures are primarily based on these 5 pillars. So we'll be designing architectures. We'll be talking in depth about these 5 pillars because that's really what the exam guide entails. And also in my own experience as a real world, designing architectures, these 5 pillars are extremely important. So as we move forward, we'll be learning more and more about each of these areas. So I would highly encourage you not only watch the course, maybe certain lectures over and over again, because it's sometimes you have to go back to the lecture and take a look at it again to take a look at the concept and the architecture itself. So I'm going to highlight as we move forward which lessons are important and which lectures you need to review a few times. So I hope this helps. Practice with this. If you have any questions, feel free to reach out. With this, let's move to the next lesson. Welcome back. So moving forward in this section, I'm going to talk about the reliability pillar of the well-architected framework. And we'll review the architectural patterns, the availability and resilience of the applications, of course, and of course the data itself. So as we move into subsequent lectures, remember, this is where things start, and we'll talk about the reliability pillar of the well-architected framework. So many services enabling a high degree of availability is really because you want to satisfy the end users. So in this lesson, I'm going to talk about how to calculate service availability, how to plan for applications to be truly be made highly available. And that's the goal moving forward in this lecture. So let's review plan for failure. Amazon allows you to simply, take a look at, truly provides you a failover environment. So you have to understand that everything ultimately may fail. So you can get EC2 virtual machine, for example, and those EC2 machines are powered by physical loads. So if you've been in the industry for more than a month or so, you probably know things fail. It happens. So you could see failures because of an increased loads, inability to handle that increased workloads or demand itself. So your application can receive invalid data. Those are called poison pill data, right? An attacker could send data that is unintelligible for your application, and your application cannot handle, and you're expecting a certain type of data, and now you have a different type of data that could cause the application to crash. You could have credentials that are expired, right? So your applications cannot reach, users cannot reach the applications, or dependent services such as third-party API or databases. You can have dependencies fail. So your service depends on something else that is now unavailable. So you could have just the general underlying infrastructure failure as well, of various types. So the idea is that you're not trying to necessarily prevent any of these, right? While it would be nice if you never had any failures, right? As a solutions architect designing systems, right? Your goal is not necessarily to prevent these from happening. Our goal is to understand that they can fail and then design a system to mitigate all of these failures. That's the ultimate objective. So you're embracing the fact that this will happen, and then you're building a system that can tolerate and mitigate these failures. You must have a backup, a contingency plan in place. So as you're designing a system, you should be asking yourself a number of questions. The more questions you ask, the better. For example, what happens when an instance terminates? Whether it was terminated on purpose or by accident or by other failures, does the termination of an instance cause something else to fail? Does it cause the application to, or brings down the application? What happens if the disk becomes full? Does that cause the data to be corrupted or services to fail? What happens when the network link is unavailable? When data transmission slows, what happens when a client is sending or receiving data? 1 byte per second, for example, right? So does that cause network connections to stack up and then exhaust the available ports and then make the server unavailable? Or does your application recognizes that a client is being slow and just terminates the connection? So what happens when the entire data center is offline? Do you have the ability to leverage a second data center in minutes or seconds? What happens, for example, when other tools and services fail? So you need to ask questions to yourself as a solution architect. The more questions you ask, the better it is, because then you can design a solution that can mitigate all of these failures. So what happens when a security group rule is changed, for example, right? Item is misconfigured within the infrastructure. Does that cause an outage, for example, or you're able to mitigate that as well? So what happens when authorization is revoked, right? We have an application running on EC2 or within Lambda or within ECS, for example. It doesn't really matter where it is, the application is, but does that application needs access to other Amazon resources such as S3, DynamoDB, compute services, and so on. What happens to that application, right, when the authorization is revoked? So again, you need to, kind of for every component within the infrastructure, you have to ask several questions. What happens when this fails? What happens when, something goes wrong? Something becomes unavailable due to misconfiguration, a failure, or multiple other factors that you can think of. The more questions we can ask, the better it'll be. And that's the goal. So I hope this helps. Go ahead and practice with this. So if you're working within the AWS environment and you're trying to create a simple solution even, think of all these questions. It will definitely help you against reliability and providing a reliable infrastructure, right? And that's the goal as a solutions architect. So I hope this helps. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Welcome back. Let's take a look at the fault isolation, whereas building a resilient network topology. Remember, AWS has a number of mechanisms to isolate faults to different parts of the infrastructure. So first, we have the regions, and then within those regions, we have the availability zones, right? And remember, the availability zones is similar to a collection of data centers. So within the availability zones, we can place our infrastructure. You can create subnets, you can create EC2 instances, VPS or volumes, storage volumes, and by leveraging multiple availability zones, if you lose a particular, let's say, hardware or device, or the entire data center, or even the entire availability center becomes offline, you have other zones. So by leveraging multiple availability zones, you can isolate the fault to that particular zone. And your application running across those multiple availability zones can continue to run to mitigate faults by isolating those particular areas. And then of course you can take a step further and then leverage multiple regions. Again, regions also leveraging multiple availability zones, right? So now any particular fault is isolated per availability zone and per region. So here those availability zones are either geographical and physically isolated as well. And that allows you to be more resilient in case loss of a data center. So remember that in an architecture like this, you might use multiple regions, right? And those regions are and should be treated as autonomous regions. And great majority of AWS services like S3, DynamoDB, for example, and so on, are completely independent region by region. That any one region can become offline, and that service will continue to run in all of the other regions. So you should be building and treating your services the same way. Now also remember that for applications that run on EC2, or let's say if your applications that might leverage, say, Redshift or Elasticache or RDS, right? Or Fargate, for example, that you need a VPC in order to make that happen. So Amazon VPC gives you the ability to isolate it or create an isolated network. And in order to, let's say, choose the availability zones, when you launch an EC2 instances for an Elasticache or RDS instances, you don't just launch a VPC, you launch into subnets, right? So subnets are specific to an availability zone. So you might want to create a public subnet that has access to the internet. You might create a private subnet that do not have access to the internet. So by leveraging, creating subnets in a particular manner, you can then enable, or the architecture itself, create instances across multiple availability zones. So the idea is creating network resiliency, right? So we need to remember that VPC is providing logical isolation, right? It's logically ordered and the architecture is logical. So you create your VPC and out of the box, you have it completely isolated from all of the networks, from other VPCs, for example, from the internet, or you're from within your own network. It's like a safety first kind of mechanism. And then of course subnets, isolation between tiers. That's exactly what subnets provide. So you have public tiers for your load balancers, you have private tiers for your applications and your databases, and then subnets will give you the isolation within those tiers. The whole idea is that you can isolate the fault if that happens. And of course, also gives you the logical mapping to the physical zone. So by choosing a subnet, you then choose the availability zone, and that way you can identify easily. So when you create VPCs, for example, within AWS, you should consider how the creation of that VPC will affect the actual applications in the capacity of those applications themselves that are being deployed on that VPC. So a general best practice of the VPC is to select or choose your IP address ranges wisely. So you should choose an IP address, for example, that allows you to create more than one VPC per region. You should also consider the ranges that you use for all of the other VPCs for the IP addresses across every region that you want to use, and also consider ranges that you're using on premises as well if you're running a hybrid environment. So you should consider the VPC ranges across various accounts even, so you may have multiple accounts. So all of the networks that you actually create, you may want to peer them eventually in some way. Whether it's within one region, whether it's across regions, you may want to create a virtual private network on premises, right? So you need to be really careful on the ranges, IP address ranges that you choose. So you're not limiting those ranges, right? You need to have enough, let's say, IP addresses or a pool big enough to accommodate everything. So you need to understand that if you place, for example, an elastic load balancer, for example, right? The elastic load balancer will automatically scale. But when it scales, every time it does this, it adds a node, right? It uses an IP address from your network. So if you create, let's say, a subnet or a VPC that's too small, with not enough IP addresses, or the pool is too small, then you can prevent your load balancer from scaling. You can prevent your applications from scaling if you don't do that, right? You don't have enough IP addresses for the VPC. So when you're selecting or choosing how large to make a VPC, you would, maybe use a /24 or /20 or /16, right? Whichever range of IP addresses. Just make sure you have enough room to accommodate all of these scenarios within the architecture that's just explained. So remember, in terms of VPC, your application is running on infrastructure such as EC2, RDS, Elastic Cache, right? Or other instances, and those are really underlying within the VPC, and VPC forms the foundation on which those instances run. So if the VPC is the first step, right? Creating the first step, and that then allows you to leverage multiple availability zones for the sake of fault tolerance, and gives you a higher degree of availability and of course resiliency as well. So when working with network topologies, working with architecture, designing your network architecture, right? Make sure you understand these practices that I just mentioned, and of course, the guidelines, and ensuring all of the areas that we just talked about. If you have any questions, post in the discussion area. I'll be glad to assist. If you have any issues that you're currently facing within your problem or within your project itself or your network itself, or you're designing an architecture, let me know. Feel free to reach out. And with this, let's move to the next lesson. Welcome back. Now let's talk about resilient configuration. So remember that the VPC itself underlies your infrastructure, right? So in order for your infrastructure to be resilient, your VPC configuration itself needs to be resilient also. And also remember, in shared responsibility model, the configuration of AWS resources is your responsibility. So as an example, for example, if you think about the internet connectivity, right, within a VPC, that the resilience of that connectivity is your responsibility, not AWS's responsibility, right? So if you're leveraging two availability zones, for example, right, you have a public subnet per availability zone, and you have, let's say, a private subnet per availability zone. In order to gain internet access, of course, you need to have a gateway. So then, in order to allow the subnet or instances within the subnet to communicate with the internet, you need a route table. And of course, the route table needs to be associated with those subnets. So at this point, you may have one route table that is being applied to multiple subnets. So what's happening here is, as a result, instances in the subnet can communicate directly with the internet. Now, if that's what your application really needs, then you need to ask yourself more questions. First, consider that the internet gateway itself is inherently highly available, right? And automatically scales, it's fault tolerant, it's redundant, and all of those are already built in within the internet gateway. But what happens when the route table becomes disassociated with the subnet, or both subnets, right? What happens if the route table is misconfigured? So you're bound to have errors, right? So if you have one route table and becomes misconfigured in a way that, removes the internet access, for example, then all of your instances across all of these subnets will then lose connectivity to the internet. So one way to fix this issue is to leverage multiple route tables. One route table per subnet, right? Even though each route table would essentially duplicate the same route, but it's easier that way if you distribute those route tables, right? You can easily isolate, or fault isolation, back to that previous lecture, right? So, you can easily identify the availability zone where that route table was applied, right? And the fault is isolated. Easy. So in this particular example, you can achieve a higher degree of availability and fault tolerance by leveraging independent route tables. Now, one argument would be that you're actually doing more work, right? You're creating more route tables. But keep in mind, you have automation tools to work through it. You can create templates, right? You can deploy templates and so forth. So you're not really duplicating routes manually. You don't just have one big route table and then you're stuck with all of these instances getting down, right? So you can leverage the tools of automation like Cloud Formation, Terraform, right? And other tools. The tools are available. All you need to do is just use them, right? So multiple route tables is a good way, efficient manner to create the architecture. The other argument may be that maybe using one route table instead of two, that you don't have the tools to manage these processes or these changes that are made. So you have processes in place that you can actually ensure that you have the right level of access to the resources. So those kind of things don't necessarily happen, right? So whether you use one route table or multiple route tables is up to you, right? It's not necessarily, I'm not suggesting that you should have multiple tables, but just be aware that within your architecture, because each architecture is different, you can have your own areas. So lastly, remember that this is more of as much of a configuration area or a task instead of connectivity, right? So misconfigurations can happen anywhere. It could happen not just on a route table, for example, but on network access control lists, could happen on the security groups, could happen on the S3 bucket policies, right? So the goal, the idea, is the fact that a failure could occur because of a misconfiguration somewhere. So you really, as a solutions architect, want to understand and ask yourself, what happens when this particular component gets misconfigured, right? How do you actually handle that particular issue or challenge? How does that affect the application running all those resources? And that's the key when you're designing an AWS architecture, a resilient architecture, that is. So I hope this helps. Practice with this. If you have any questions, feel free to reach out. And with this, let's move to the next lecture. Welcome back. Now let's talk about the resiliency of your VPN connections. So, for example, if you have a corporate data center, right? And you have a VPC in an AWS region, and you would like to create a VPN tunnel between an on-premise or data center location and your VPC itself. So in order to do that, you need to create a customer gateway on the on-premises side. You'll have to create a virtual private gateway on the VPC side. And in between those two, you can create a VPN tunnel that connects the two, and the traffic goes from the internet, and you know exactly the traffic is encrypted during transit. Then, of course, using the example itself, you can apply, for example, multiple individual route tables that we talked about in the previous lecture and subnets, so that any misconfiguration of any one route table, you can easily isolate to that zone. And using those route tables, you can then communicate from on-premises to EC2 or RDS, or anything within that VPC with private IP addresses and encrypted communications. So keep in mind that any one VPN connection, right, is comprised of two tunnels. And that's because the virtual private gateway on the AWS side is powered by physically distinct routers and physically distinct facilities. So on the AWS side of things, right, you already have, let's say, resilience. AWS could lose any one device and still have another device for you. So if you lose one tunnel because of failure on Amazon side, right, you still have that second tunnel. But you need to ask yourself, right, what happens when your customer route fails, right? So for example, if you lose a customer router, right, or route, what happens when the customer internet connections fail? Then you'd be without a VPN connection. So if your single router fails, then you will lose that VPN. So how do you tackle this, right? A solution is to leverage multiple customer routers and create multiple VPN connections, right? One is being redundant, and each connection has two tunnels. So if AWS loses a device, you have another 3 on Amazon sides, right? If you, for example, lose a device, you still have another one. So, for example, if you require, let's say, a reliable, resilient VPN connection, then you can achieve that through multiple customer routers. In order to truly achieve automatic failover from one VPN to another, those multiple routers will need to be configured with, properly. So you can also leverage redundant internet connections. If you really need solid, reliable connections of VPNs, you could also consider the fact that if you lose or rely on one internet service provider, they could fail, right? So by leveraging multiple ISPs, you can then become, really a fault-tolerant network. And that's the key ideas I wanted to share, a couple of important architectures, the things that Solutions Architect can do in order to really create a resiliency. So I hope this helps. If you have any questions, reach out. Be happy to answer. With this, let's move to the next lesson. So let's talk about the direct connect resiliency. Within AWS, of course, you have the ability to create a direct connect connection, which is a dedicated fiber connection, for example, right? 1 or 10 gigs per second throughput into your bandwidth, for example, or within an AWS region. And of course, in order to make that happen, you would have to have the customer gateway or routers on premise. And then leveraging a direct connect location, right, physical, then establish the connection itself, partnering with, for example, let's say service providers to run a line from on-premises to the direct connect location. And then from there, you could then subsequently create, if you would like to access into your VPCs, you would terminate using a private virtual interface, let's say a VLAN into your VPC. You could also use Direct Connect to access Amazon services like S3, for example, DynamoDB, for instance, that live outside the VPC using a public virtual interface. And of course, you can terminate a VLAN into that as well, right? So that any one Direct Connect connection, right, can be divided into VLANs. Some VLANs terminating into VPCs, others terminating into the region, or in general, right, within the regions you can access other resources, AWS resources, which is, generally available through IP ranges. So now you have this environment, you need to ask yourself, what happens when your customer router fails? So, well, if you've seen from previous lectures, you need a high availability in this particular scenario as well. You could leverage, for example, a VPC failover from one customer router to a second router. So you'll have two customer routers. What happens when you add direct connection fails? So if that connection fails, then you no longer have that direct dedicated fiber connection, right? One possibility is to fall back to the VPN, right? So you can add high availability to your direct connect by leveraging a failover to the VPN by using multiple VPN connections, each having two tunnels that we talked earlier, right? So of course, all of that, if the customer routers with all of these connections need to be considered with the VPC. If that's not enough, let's say, for example, you have a particular scenario that requires a level of bandwidth, throughput, or network performance that VPN could not just meet, right? Then you can leverage a redundant connection, right? Just like if you have one connection that's terminating into the private and public virtual interfaces, you can establish a second direct connection, right? Again, that one terminating into the private and public virtual interfaces as well. So, and of course, further divided into VLANs. So you could also go even further. Ask yourself, what happens when a direct connect point of presence fails? When the actual facility that houses that connection, right? AWS routers, for example, that manages, that powers that direct connect connections, what happens when the provider fails? So you're getting access into the direct connect point of presence through some service provider. If their connection fails, you could have an issue, a real challenge. So what you can do here is you can leverage multiple customer routers, multiple direct connect connections, right? And multiple locations as well. Each location having redundant connections. You could also leverage redundant service providers, and that's one of the ideal manner where you have high degree of availability with redundant customer routers, redundant direct connect connections, and redundant facilities, locations, right? And redundant service providers. So if any one thing fails, you still have something else to bank upon. And that's a good architecture that a solutions architect can create and deploy and, of course, design as well. So I hope this helps. If you have any questions, reach out. With this, let's move to the next lecture.
Let's look at some AWS compute options. Within AWS, we have a number of options for computing, starting with instances. Within instances, we have many options and a number of choices in terms of choosing the right size or type. We also have containers. Containers, of course, give us a way of securely isolating processes so that we can run multiple applications on the same instance, and by doing that, we can leverage or utilize more of what that machine has to offer. All of these CPU cycles, memory, network, and disk that we're paying for are actually being used rather than remaining idle. So containers actually allow us to improve the utilization, the actual utilization of the instance that we're paying for. And lastly, we have functions. Within AWS, Lambda and functions are really great options for each event-driven infrastructures or tasks that may be performed asynchronously in the background. Functions also give us a very high degree of concurrency. So now when we look at EC2 instances types, we have a number of different families to choose from. We have the general purpose EC2 instances, which give us the T2 series, the M3, M4, and M5 series. And these are general purposes. They have mixed uses. They are good for a lot of different types of applications, but some applications may be of, more like CPU intensive, and some applications may be more of memory intensive. So we also have other families that of course, we have the compute optimized families, giving us the C4 and C5 series. We have families giving us access to GPUs or high performance computing, the P2, P3, and G3 series. We also have a family that is more memory optimized, giving us much more of memory, say the X1, R3, and R series. And we also have EC2 instances that are more geared towards internal storage. This would be the i3, H1 and D2 series. So it all depends on what application really needs right now. So when we look at the needs of that application and we know what this application might need, more CPU or memory or whatever, that depends on yourself. So in terms of performance, it's all about choosing the right computing solution for the work that's being done. So let's talk about the performance for instance-based applications. So in this examples, perhaps we have an application running on an EC2 instance behind a load balancer. Maybe it's an API or some type of web application. So the first thing that we want to consider is the fact that every component in our infrastructure will contribute to the overall performance. Starting with the load balancer. So we could ask ourselves the question, which elastic load balancer is the most appropriate for our application? Remember that we have three different types of load balancers. We have the classic load balancer, the application load balancer, and the network load balancer. And they all have their own options and will affect performance in different ways. So the application load balancer provides host name and path based on routing, which may be very useful for our application. The classic load balancer does not offer those. So generally speaking, we can expect that we're going to see constraint somewhere in the CPU, memory, network I/O, disk, and we don't really know again until we deploy the application and start monitoring it. The C4 series, the C5, C4, M4, M5 are generally good places to start for a new application, or one of those series you might choose to start with. And then of course, how do we know, that when we're going to be seeing in terms of infrastructure bottlenecks? The only way we know is to monitor that with CloudWatch. And so we should be using CloudWatch to capture those key performance indicators, and we can do that for both infrastructure and application metrics. So keep in mind that CloudWatch can collect custom metrics. Anything that can be recorded as a number over time can be published to CloudWatch as a custom metric. So we can have our application or even some secondary process rolling alongside our application report a number of things as custom metrics. We could report such things as thread and process count, JVM heap size, which collection rates, and other information related to garbage collection, disk usage. Keep in mind that with EC2 instances, we do get information automatically reported, but we don't get information recorded about how that disk is being used, right? So if you want to have a detailed information, we would have to report that ourselves, writing our own agent. We might also want our application to report the number of concurrent connections. We might report about anything, perhaps the number of failed of authentications we're seeing over some period of time, for example. And then, of course, any of these things can be turned into alarms. Any metric we can use to create an alarm. In that alarm, we can use to alert us to whether or not maybe there's an issue happening that needs to be addressed. Or we can use those alarms to trigger autoscaling. So one of the keys to performance is to match the current supply with the current demand we want. So to avoid being over provisioned, because over provision means that we are wasting money. Being under provisions means that we can't actually meet the current demand. And so leveraging CloudWatch to monitor these metrics and allowing those alarms to trigger through autoscaling allows us to match supply with our demand. Now another thing that we can do in this example is, like we've mentioned before, by offloading static content to S3, we can then reduce the load on EC2 instance, which would then give that instance more CPU cycles to devote to generating dynamic content. So again, for in terms of performance, we need to consider all the components in our infrastructure, the load balancer, the type of EC2 instance, whether or not we're offloading content to S3 in together as a whole, that will contribute to the performance of our applications. Alright, so moving on, now let's review improving performance with containers. So when we think about deploying applications to EC2 instances, we know that we don't want to be overprovised. because being over provisioned means that we're wasting money. We're paying for more resources than we really need. We don't want to be under provisioned too, because that means that we don't have the ability to meet demand. So the question we should be asking ourselves is how can we most effectively utilize all of the resources such as CPU, memory, and network I/O available to our instances. And so to answer that question could be very well to be leverage containers with Amazon Elastic Container Service, right? So now, if we're running a single application on an EC2 instance, that would very well mean that we have a significant amount of resources going underutilized. We have CPU cycles going by that are not being used to do work. We have memory that is potentially not being used. We have the potential for network I/O and that also might not be used, right? Than that are actually being utilized. And so we can capitalize on that by launching multiple processes, multiple applications that can run side by side on the same EC2 instances by deploying them with containers. And the reason we were using virtual machines for so long is because we needed isolation. But containers give us that. Containers give us a way to run those multiple applications, multiple processes on the same host, sharing the resources of that host, but also preventing those applications from interfering with each other. In that process, in that way, containers are giving us more efficient use of those resources, keeping those processes isolated on the same host. Now in this example, we are leveraging the Amazon Elastic Container Service as well as the Elastic Container Registry. The Elastic Container Registry will give us that secure private storage for Docker images. And of course, images form the basis of containers. And then the Elastic Container Service, that is the service responsible for scheduling containers and actually placing containers on a fleet of EC2 instances. So in this example, we're only showing one instance, but generally when we use a service like Amazon ECS, we would create a cluster of EC2 instances, some number of instances that could be 2 or 3, or maybe it could be 200 or 300 instances in that cluster. The ECS service is responsible for placing the containers on those instances. If so, from our perspective, we deployed to the cluster in ECS is responsible for making sure that same number of containers get deployed across that cluster. Now, another thing that we can use to even further improve performance is dynamic port mapping. So the question is, how can we place more than one container for the same process or same application on a single EC2 instance? And the answer is to leverage dynamic port mapping with ECS in the application or network load balancers. So when we use an application or network load balancer, we would define that what we call target groups. Target groups simply provide a group of targets, in this case containers. To route traffic to each container would be a target. And each target is capable of listening on a unique port. And so in this case, we deploy a container for a particular application. Once that container is deployed, the Docker engine will map a random host port to a fixed port within the container with Docker Bridge. Docker is essentially virtualizing the network so that it can map a host port to the container port so our application could be hard-coded to listen on a particular fixed port such as 80 or 8080 or 3000 etc. port. ECS will automatically register that target, that container on that port with the load balancer so that the load balancer knows that it can find that target on that port. And then of course, for that particular application, we could have multiple processes or replicas of that container running side by side, each one listening on a completely different port. So one application has, in this example, two containers, and then we might very well have another application also running two containers, each one listening on a completely different port, each one being a target registered behind the load balancers. And now with using the application load balancer, we can create rules to allow that application load balancer to route to those groups of containers based on host name or path. So when it sees a particular path, it knows to route to that path to that group of containers. And when it looks to that group and it picks up a target out of that group, it knows which port to connect to that target on. So again, dynamic port mapping is a very powerful way of really improving the performance and the utilization of our container cluster, because it also allows us to place multiple or replicas on the same application on a single instance. It allows us to scale the number of containers beyond the number of instances in our cluster, in that way making much more effective and efficient use of available resources.
Now let's review the storage and block storage options. So this lesson moving forward, we're going to focus on the storage performance. So when you think about performance of your storage, so whether it's block or object storage or even file storage, you need to be familiar with all of the options that are available and the nature of those options. So within AWS, of course, for block storage, we have several options. We have, let's say, Elastic Block Storage Service, in which you can, or you have SSD general purpose volume. And those are based on SSDs, right? But they operate at a baseline performance of 3 different IOPS per gig, or 3 IOPS per gig. And this will give you about 300 IOPS, right? Some apps, they may work fine. Other applications, that might not be enough. So you also have the SSD provision IOPS. And those provisioned IOPS says that we can allocate both storage and certain IOPS for that volume. So if you do need, let's say, 100 gigs or much greater than that, or 300 maybe IOPS, you can go with provisioned IOPS, guaranteed that you can get the system performance for that volume. Now, for random I/O, SSDs are a great option, and they'll give you good performance for random I/Os. But for other applications that require throughput or sequential apps, and then you have the hard gigs. In that regard, you have throughput optimized and cold storage. And throughput optimized is a great option when you need a lot of, let's say, high throughput volume rather than I/O. In that regard, with the HDD, right, throughput optimized storage, you can get up to maybe 5 megabits per second. And you also have EC2 instant store volumes. Keep in mind that those, you have a number of options in there. Storage optimized compute instances are there. Many of those are based on SSDs, right? But they are ephemeral, right? The trade-off really is that they don't have any type of built-in systems, by meaning of being ephemeral, right? So you do get a very high, IOPS. In some cases, you go up to or beyond 300,000 IOPS with EC2 instance or volumes. So we also have file system storage. You can use the Elastic File System, EFS, and that gives you, for example, the ability to create volumes that is shared among multiple EC2 instances. So remember that with EBS, the block store, right, any one volume can only be attached to one instance at a time. But if you need that volume, for example, to be attached to multiple instances, then you can look to the EFS, Elastic File System. And then we have the object storage. And of course, the option there is the Amazon Simple Storage Service, right? And we'll take a look at a little later on what S3 can give us in terms of performance. So you also have archival storage. You can use Glacier, right? AWS Glacier. You can upload data directly to Glacier or use lifecycle roles to transition big data automatically from S3 to Amazon Glacier. So when you think about the performance, right? The writing data and then the retrieval of data itself. With S3, you have the ability to upload directly and then at the same time do synchronous download immediately, right? So you save data to S3 and then you can immediately take a look at it. With AWS Glacier, for example, that's archival storage. And that takes a little bit of time. So for example, if you save data to AWS Glacier, it takes about 3 to 5 hours to retrieve that data because you have to send a request in. And that's how really the difference between S3 and AWS Glacier, right? So S3 is synchronous and Glacier is asynchronous, right? So that's really the strategy that you can take as a solutions architect of how you want to deal with your storage options. So for example, what are the access patterns? How your application will access this data. Will it be write once, read many, or there'll be a lot of random I/O or sequential I/Os, for example? Or do you need to simply store the data for long periods of time and really archive it and maybe access it once a year? So this will help you to become familiar with all of those options and the nature of each option, that you can then determine as a solutions architect what would be the most performant data store, in a particular given scenario. So in this lesson, just wanted to cover the several storage options and then of course the performance of each of those options. So I hope this helps. If you have any questions, post in the discussion area. And with this, let's move to the next lesson. Welcome back. Now let's review the performance of the block store option. So when you deploy applications, for example, to EC2 instance, right, that will use some type of block store volume, whether it's instant store or EBS or SSD or hard disks. You should be asking yourself several questions. First, will your app perform using sequential I/O? What throughput rates might be required for that particular application? How frequently will the data be read? How frequently will the data be updated? Will it be a write once, for example, read many type of situation, or will that typical files will be updating constantly in real time? So when you think about log files, for example, they're generally written once and then you can read several times. When you have other things like images or let's say JavaScript or CSS or other content, those might be written once and read many times as well. You might have database, right? So think of MySQL, right? For example, you have a DB, a data file that essentially contains the database. So when you are doing a lot of updates, the actual data in that file is constantly being updated and read by several users all across the enterprise. So answering those questions will help you determine what really you need as a good architecture, efficient architecture, random I/O or sequential I/O. So for random I/O, for example, to get the highest degree of IOPS, input-output operations per second, then you can take a look at the instance store volume. And in some cases, instance store volume can give you upward of 300,000 plus IOPS, but with no durability. That's really the trade-off. So if you need that data to be both highly performant and durable at the same time, then the onus of durability will be on you, right? So what you need to do is you can use third-party service or software or write your own script or application, right, to automatically, regularly copy that data off to something else that's more durable. So with EBS, now the trade-off is that you'll get the performance, no doubt, right, for the instance source volumes, but you do get some built-in durability as well. And with EBS, right, the Elastic Block Store, you have, again, the general purpose SSD volumes. Those will give you the persistent storage while at the same time balancing performance. So the idea there is that you can have the dual purpose SSD volumes operate at a baseline of 3 IOPS per gig. And then what you can do, for example, if you have a 400 gig volume, that'll give you about 1200 IOPS, right? And many applications will work wonderfully. And the general purpose volume are capable of bursting for some period of time. And they can burst, in many instances and can sustain a higher level of IOPS as long as they have credits. That's really the trade-off that we talked about. So ongoing high performance, right, unique for IOPS, you can leverage provisioned IOPS. So provisioned IOPS SSD volume gives you the guaranteed level of performance, up to 30,000 IOPS. And of course, there is a relationship to the maximum IOPS volume, and the size of the volume. The larger the volume, the greater the max IOPS you'll be able to actually provision. Now, if you need more throughput type of storage for doing, let's say, more sequential type of actions, right? You're more concerned about the throughput than with the random I/O, then you can look at the hard disk volumes. Again, you have the throughput optimized volumes, upwards to 500 megs per second, or sequential access. And then you also have the cold storage volume that will give you the absolute lowest cost for infrequently accessing data. Common question might be, for example, well, if you have data that is infrequently accessed, You already have S3 that can give you the actual low-cost storage, right? And that is true, but one of the benefits to the hard disk cold storage volume, as opposed to S3, is because the volume is attached to EC2, now you can add your own customized security controls on top of that and beyond what might be possible with S3. So again, when you think about the performance of your storage, you need to consider all of the options that are out there and the access patterns as well. Let's keep in mind that because EBS volumes are independent of the instance, right? They are connected to the instance over the network. And as a result, what happens is some EC2 instances that are not EBS optimized share regular network traffic, such as internet-bound traffic, EBS traffic, or using the same, for example, host network interface. So EBS optimized instances, right? They provide a dedicated network path specifically for EBS itself. And what that means, as a result, that the traffic is being delivered between the EC2 instance and the EBS volumes, is not having to, meet with other traffic such as the internet. So it stays independent, right? And as a result, you'll see better performance between your EC2 instances and your EBS volumes. So I hope this helps. Just wanted to kind of touch base on the actual architecture element of your storage options. With this, let's move to the next lesson. Now let's take a look at the performance of Amazon S3 buckets. So you might be using S3 in your architecture, for example, in your infrastructure, right, that you've designed for a number of different use cases. You might use S3 for static content. You might use S3 to perform a data link, for example, to store logs, right, to store images or ingested imports. Whatever the case is, if your requests to S3 is typically a mix of different things like get, put, delete, right, or list objects, operations, then how can you ensure that the consistent performance for that bucket is achieved? How do you avoid receiving slowdown exceptions being returned from the S3 APIs, for example? The answer to that is to add random hash to the actual object keys themselves. So you have to understand that S3 is a distributed system. No one server can handle all of the data that will be stored or all of the requests that you'll ask of it. So the data itself is actually distributed across a number of nodes. And that means that the data is partitioned. So the key name of your object will directly influence or dictate which partition that object is stored in. So if you take a look at an example here, right? So let's say you have a list of S3 object names or keys. So you'll notice that the pattern, is storing things by date, down to the day, for example. So what you have is, let's say, the number of objects you talk about or you're taking a look at, tens of thousands or hundreds of thousands, or maybe even millions of records per day could be stored. So when you have, let's say, sequence of data itself, like alphabetical or, ordering of numbers, it will introduce a performance problem by forcing too much data into too few partitions. So you have a lot of data that can only be stored and served by fewer partitions. So ideally, you have that data spread across as many partitions as possible. And you can do that by leveraging random hashes as prefixes to those keys. So for example, you can add a random hash to the very beginning, right? In that case, you could potentially replace, right, maybe the entire key, for example, by random hash if you really wanted to. So again, that random hash will allow your data to be spread evenly across a number of partitions. So no one partition is responsible for any more data than any other partition if you compare them. So the thing to keep in mind is that while random hashes in S3 key names can improve performance, they remove the predictable prefix, right? And by removing that predictable prefix can make searching for objects a little more difficult. And we'll explore that in future lessons. So keep that in mind at this point, that S3 performance, how you name your objects, will directly influence your performance of that S3 bucket. And that's really important when you work with S3 buckets. So I hope this helps. If you have any questions, post in the discussion area. We'll be happy to assist. With this, let's move to the next lesson. Now let's take a look at searching for data in S3 buckets. So, like we talked about earlier, when you want to guarantee the performance of a bucket, for example, you can leverage random hashes, right? Or at least random hash prefixes for your object keys to simply ensure that you're getting an even distribution across multiple partitions. So you can again guarantee performance. But since we've already discussed, doing so will make it more difficult to find the objects, find the items that you're looking for. So if your S3 key prefixes, for example, are randomized, how do we find objects? How do we search for those objects? And you also have to keep in mind that the S3 list objects command is not an efficient form of search. That doing an S3 list objects, there's no way of asking S3 really filter except by the prefix. You can only do so maybe 1,000 objects at a time within S3. So the answer here is to store a searchable metadata in an index store. And in that regard, we have several options. You could store the metadata in DynamoDB, for example, and then search based on primary key or a local or global secondary index. If you wanted to have more control or more flexibility over the searching, then you can leverage full text searching, in fact, with Cloud Search. Either way, the pattern here is that storing the S3 objects, large blob of data, for example, as an object in S3, and then any metadata that describes that blob, right, would be stored in something indexed like DynamoDB, for example, or Elasticsearch or Cloud Search, right? So your application, needs to find, something, a particular object or a series of objects from S3, it would simply perform its searches against one of those data sources. And that data store would return the key or keys and then use that to retrieve data from S3, right? So that kind of makes sense, right? So if you have, let's say, S3 bucket and you want to search objects, the key here is to have or create metadata and then use DynamoDB, which is fairly popular and common. So I hope this helps. With this, let's move to the next lesson. Welcome back. Now let's review improving the end user experiences. Okay? So over the years, several studies from, let's say, Amazon.com themselves have shown that delays in page load or delay in getting the user what they're looking for will result in lower conversions, which really affects the bottom line, right? So what you can do is to improve the performance for the end users themselves and get them what they're looking for, whatever is possible. So the question here is, how do you actually improve the experience or the user or the end user experience? One possible answer is to reduce the latency, using caching. And you can do that by leveraging CloudForm. So CloudFront, you could create a distribution, right? Whether it's a download distribution or a streaming distribution, for example, and then you can configure the origins. So, for example, if you want to serve dynamic content, right? Dynamically rendered HTML or whatever the case may be, JSON, right? Or an API, you can serve that dynamic, content to the load balancer. Static content such as images, maybe JavaScript, PDF files, right? It'll be served from S3 directly. So those will be the origins. You can then configure behaviors, right? To say that, those URL patterns, JPEGs, JavaScript, CSS will be served from S3. And then everything else would be served from the load balancer itself. Again, those are behaviors. And then as your users connect, right, to a particular domain, for example, or they connect to a subdomain, for example, they can actually connect to an edge location. And they can retrieve that content that's already been cached at that particular edge location, right? And by doing that, you are lowering the latency, which definitely improves the user experience, provides them the content faster. and reduce the load on EC2 instance at the same time, which could result in your ability to reduce the number of instances, right? Or the size even of the instances within that fleet. And that's really a lot of cost savings, right? So by building an efficient architecture, you could save your organization quite a bit of money, right? In the longer periods of time. And that's really what the solution architect really does, right? So I hope this helps. Practice with this. If you have any questions, let me know. With this, let's move to the next lesson. Now let's talk about the performance of AWS DynamoDB tables. So when you're actually leveraging DynamoDB, right, within your infrastructure or architecture, you should be asking yourself, how do you improve the performance of your DynamoDB queries? So in order to do that, right, first you need to understand the nature of DynamoDB partitioning and throughput allocation. You would also choose, for example, primary keys that would provide you, and even distribution, right, of storage and request loads. Because DynamoDB is a distributed system, and your keys, very much like S3, for example, will be distributed across the number of partitions. And what you want to avoid is any one partition being responsible for, the majority of any more storage, right, or requests than other partitions. Because that would be, a hot partition, and that will lead to performance issues or degradation. You would also leverage, for example, both local and global secondary indexes. And then finally, you would use the query versus the scan operation, right? So remember that DynamoDB is capable of single-digit millisecond response time, but that's only when you use query operations rather than the scan operation. So as the name suggests, the scan means, right, it's a full table scan. You'll not be able to get the absolute best performance by using the scan options or operation. You need to also remember, like I mentioned earlier, the tables are partitioned. So within DynamoDB, tables are partitioned according to the throughput capacity and the size of the data that you're actually storing. So when you look at DynamoDB, for example, how these tables are built and how they're partitioned, a single partition can handle about 3,000 read capacity units, 1,000 write capacity units, and up to 10 gigabytes worth of storage. So, for example, let's say a table requires 6,000 read capacity units, right? 400 write capacity units. And initially, or in the short or midterm at least, you're looking at about 5 gigs worth of storage. So, according to this particular scenario, you would calculate the number of partitions, right? And that would give you the ability to have the capacity for the throughput capacity across partitions. So one partition can handle, maybe 3,000 units. So you would have 6,000, let's say, divided by 3,000, so give you 2,000. And that'll give you read-write capacity units. One partition can handle 1,000 write capacity units, and you only need 400. So that gives you about 0.4, right? So in terms of storage itself, you only need half a partition because there's no such thing as half a partition, right? So you need just a space, right? So a number of partitions will be the greater of those two numbers, rounded up. So the greater of those would be 2.4. If you round it up to 3, so you need at least 3 partitions allocated to that table in order to meet the throughput demands that we're actually asking, right, talking about here. So you'll end up basically 3 partitions, as mentioned earlier, and your total throughput would be allocated evenly across those 3 partitions. So, for example, each partition would then, be allocated or limited to 2,000 read capacity units, and then 100, maybe 33 units write capacity units. So the thing to keep in mind here is that if any one partition, for example, goes beyond more than what it's allotted, then the throughput will be a problem. Even if your total throughput, for example, is lower than what you've actually provisioned. And any one partition going beyond its allotted throughput would result in throttle. And that's exactly what you want to avoid, right? hotkeys lead to, hot partitions, and hot partitions lead to problem issues, right? Degradation of performance itself. So just wanted to highlight in some of these important areas, so you as a solution architect need to be aware of these. Hope this helps. With this, let's move to the next lesson. Now let's talk about primary keys within DynamoDB. So with Amazon DynamoDB, for example, primary key can be, either a partition key on its own or a partition key plus a sort key, which could be a composite key. Either way, the value of the partition key, for example, determines the partitions that actually stores and serves the record for an item. So let's take a look at it more in depth, right? So for example, let's say you have an e-commerce site like Amazon.com or others like it, displays a product rating. In order to rate products on a scale from 1 to 5, and users can submit their vote, you can use DynamoDB to collect those votings, right? Those data. So initially, you might think that the product ID for this table might be a good partition key. But let's take a look at that. So by doing that, you might have, let's say, product-1, right, going to one partition, product-15 going to, partition key would be assigned to another partition, and product 237, for example, right, would be a partition in a different partition. So the issue is that any product that comes more popular than other products would create a hot key and a hard partition. And that kind of makes sense, right? A single product might receive many more voting or ratings as compared to other products. And then by doing so, that could very well overwhelm the throughput allotted for that partition. Remember what we talked about in the previous lesson. So the total provision throughput, right, is evenly allocated across the number of partitions that you have. So even if you have, or your total consumed throughput is less than the total provisioned throughput, you would still receive a provision throughput exceeded exception, right, for any one partition that's going above or beyond the actual allotted throughput levels to that particular partition. So what can you do, right? How can you actually improve the performance in this situation? How can you mitigate the hard keys, right? The best way to handle this is to try a strategy with the values of your primary keys that provides a large number of unique and evenly requested values, but sometimes that's easier said than done. So for reads, you can easily solve that, right, by leveraging caching, by either Elastic Cache or DynamoDB Accelerator, or known as DAX. The benefit of using DAX is that the data model itself and the API is compatible, for example, with DynamoDB. And you can leverage DAX by making any changes, right, to the code of the actual application itself. With Elastic Cache, however, you would have to make changes to the code in order to make the data model, right, within the API calls compatible with, memcached, for example. So for writes, you have a number of options. You could simply buffer that incoming data into either a queue service, right, using the queue service, or with streams in Kinesis. You could also append random values to the key. So in that regard, what you can do, let's say, for example, for product 1, let's say that's one of the more popular products. So here you could say, let's just append a random suffix, right, from a known range of values. So you can say product 1-1, that would go to one partition. Product 1-4 would go to another partition, right? Kind of makes sense. Product 1-10, for example, yet another partition. But now you need to aggregate all of those. So once again, appending random numbers to that set range performs a different hash, which would definitely spread those requests, right? And spread the storage across those partitions. So once you aggregate, right, within the required 10 requests, you would make a request for product 1-1, for example, product 1-2, 1-3, and so on and so forth, until you made 10 requests for product 1-1 through 1-10. And then you could aggregate all of the ratings for product number 1. So just to recap, right? It's really important to understand how your primary key, the nature of primary key, affects performance. Within DynamoDB, for example, when you consider the nature of partitioning within DynamoDB tables, right? So again, ideally, the partition key will have a large number of unique values, evenly requested, right? So no one partition is really responsible any more request or storage than any other partition. And by doing that, that's how you can guarantee the actual most optimized performance of DynamoDB. So I hope this kind of makes sense regarding primary keys. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Welcome back. Let's talk about the secondary indexes with Amazon DynamoDB. Of course, or before we take a look at the indexes, let's first take a look at, maybe creating, let's say, an example of creating a movie database, right? So in this particular example, you can use a title of a movie, right? And that's the partition key, right? Because you have a large number of unique values, right? And because of that value being unique, you can spread this information evenly across partitions. So in this particular instance or case, right, once this movie data is written, you probably won't update that data very often, right? New movies will be added, but generally speaking, you can expect that this table will have many more reads than writes. Now that kind of makes sense. It is possible for certain movies to be read more than others, right? Some films, for example, would end up with a hot read, but you can, of course, as we talked about previous lectures, right, mitigate with caching. So remember when we talk about in terms of querying, the most efficient way to retrieve information from DynamoDB is to query operation, not the scan. In order to do that, you need an index. So for example, the title or the partition key would be the only thing in this table that is indexed. So if you ever wanted to search, for example, based on a year, how can you query against that particular year across all of the partitions? What if you wanted to query, for example, maybe ratings, right, across all the partitions? For those, you can use secondary indexes. So, for example, think about this. If you're still taking movie data, right, and you're putting the relationship between the cast members and their roles, right, to a film in a second table. So here, what's going to happen is you're going to use the title of the film as a partition key, and then the member, the cast member, for example, attribute, right, is being used as a sort key. And that's going to give you the partition plus the sort key, and that's going to give you a composite primary key. And that's really helpful. So if you wanted to, let's say, for example, show me all of the cast members for the movie, let's say matrix, right, name of the movie, you can query where partition key equals matrix. And then you can use the sort key, as the name suggests, to sort based on the cast member name. So if you wanted to sort based on some other attributes, then you can create a local secondary index. A local secondary index would allow you to reuse the same partition key, but specify the different sort key. So here you can create, let's say, a secondary index, right? And you can sort based on the role itself. So what's going to happen is you can say find all movies where film or title would equal matrix, and at the same time sort by role or sort by member, cast member. So global secondary indexes would allow us or you to use existing table with the existing data and existing tables, right? And specify at the same time a new partition key. So what you can do here is you can have a way to perform queries and against the new partition key. So you can query data across various partitions that you have. So you might want to use here at this example, create a global secondary index by specifying the year, for example, as the partition key and the title as the sort key. So that way you can query where you can say, for example, find where all movies where the year is 1999, for example, and sort by the title of the movie itself. So when you're actually using global secondary indexes, right, any changes to the table will be reflected in the secondary index. Keep that in mind, and that will be eventually consistent. Even if you want to use, let's say, and there's no option, in fact, to use consistent reads when you're querying from a global secondary index, right? There will always eventually be consistent reads. So you could, for example, another approach would be creating another global secondary index, right? You can use, for example, the rating as a partition key and title as a sort key. Then you can say find where all movies or all ratings are, let's say, PG-13, and sort by the title. So a few things I want to point out here, right? First, the throughput for the global secondary index is provisioned separately, okay, and is independent of the table itself. So you will specify a particular throughput that you need for that table, and at the same time you'll specify the throughput that you need for the global secondary index. The storage is then, of course, shared. So the storage is being used by the table, right? But the throughput is different. So your table could have, one level of throughput, a secondary index, and then have its own level of throughput, right? And this really would help, right? But it kind of helps you understand the actual concept. But here, for example, if you think about movie ratings, there are only 5 possible ratings. That means you will have very few values across, maybe perhaps millions of records in this particular table. And as a result, you will, we'll take a look at when we talk about hotkeys and hot partitions, right? So it's going to put a lot of records across very few partitions. So a global secondary index, probably not the best idea for this particular scenario, right? Kind of makes sense. So remember, within DynamoDB, you have a number of things that contribute to performance. The choice that you make of partition key, for example, and once you have a good choice or good value, for example, a pattern of values to use for that partition key, then you can finally look at improving query performance by leveraging secondary indexes. Local secondary indexes would allow you to specify a different sort key, and then global secondary index would allow you to specify a new partition, right, and a sort key altogether. So it's really up to you as a solutions architect, based on the given scenario, what would be the most appropriate performance for DynamoDB. With this, let's move to the next lesson. Now let's talk about improving performance for read-heavy applications, right? In this particular example, and you can leverage, for example, a database instance from the relational database service. And of course, that's deployed within a multi, zone deployment, RDS, giving you the primary and the secondary asynchronous replication across multiple availability zones. How can you improve the performance when dealing with many read operations, even if those operations are not constant, right? Even if they only occur during, certain windows. You can still improve the performance by leveraging read replicas. With RDS, it's really easy to create read replicas, right? But you can simply ask for those replicas. And then RDS will create and manage the replica and at the same time ongoing application. And it's worth noting that most engine types, DB engine types, are limited to 5 replicas per master. With Aurora, that limit goes up to 15, right? Or per DB cluster. Once you have a read replica, your application will then send read requests to those replicas. What's going to happen is it's going to continue sending write requests to the primary, right? And the primary and the replicas will get different endpoints for that purpose. And by doing this, read replicas will reduce the load on the primary. That kind of makes sense. And it's going to improve at least the read, potentially both reads and writes. Another thing you may want to ask the same questions, right? When you want to read applications. How can you improve the performance when you're dealing with slow queries? Perhaps you already indexed by the book, right? And you've taken a look at the schema itself, the data model, and you've done all you can to improve the performance of those queries. But just due to the sheer volume of data and the volume of requests, perhaps you still have some queries that are returning slower response. So for that, you can leverage in-memory caching. And to do that, you can leverage Amazon ElastiCache, which offers fully managed, Memcached, for example. So the idea here is that you can put a cache cluster alongside with your application, right? And then ElastiCache can provide, the low latency, right? It can handle, it'll take that burden, right? Within its memory. So the application would first look to the cache to see if the results that the user is looking for is already cached. If it is, then simply return it to the end user with very, very low latency, right? Because that result set has already been generated and already there in memory. If not, then you can retrieve it from the database and then populate the cache. So keep that in mind, that when you're thinking about applications, right, that are read heavy, you have several options. You have read replicas and in-memory caching. You could always use both, right, within a given scenario or instance or your project. So I hope this helps. Just wanted to quickly cover the important areas of where you can leverage the Amazon ElastiCache, where you have slower query responses. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Let's take a look at how to improve the performance for write-heavy applications. So, for example, you maybe want to ask yourself how you can improve the performance of writes to a small RDS instance, right, for example. And the answer could be to leverage buffers. In doing so, the performance will be improved by leveraging Amazon Simple Queue Service and decoupled processing with either AWS Lambda or EC2. So in this particular scenario, if you're leveraging T2 small, for example, that could work pretty well, but suffer with spikes, for example. And this is a common pattern, right? A number of applications could very well be served by a smaller RDS instance. But during those periods where you see those spikes in writes, you could have those writes, for example, buffered by a queue. Your application, right, could then determine if you're seeing a high volume of spikes, then you can simply write your code to start sending writes to the queue. A simple queue service queue, for example, right? That would provide you a fully managed, highly scalable way to buffer those incoming writes. And keep in mind that a simple queue service will have several benefits. One, for example, in order to make it scalable, by default, out of the box, scales to millions of messages per second. It also provides you the first 1,000,000 messages per month, and that's free, by the way. So you can then leverage AWS Lambda functions, right? Which will give you, again, a fully managed, highly scalable way of processing messages in queue. So Lambda could be set to pull messages from the queue and write that data to the database at a pace that your database can keep up with that. And by doing that, this very well could improve performance, right? At the same time, save you or the organization money as opposed to simply increasing the size of the database itself. So in this case, for example, of DynamoDB, right, you can also use buffers. So going back to the earlier lecture, right, previous lecture, you have product ratings and you want to write those. You can perhaps improve performance of all of the product ratings, right? So you can have product 1, product 1 sees 3 stars, product 2, and so on. So all of these writes first go to a buffer, then to a queue, right, handled by the queue, and then you can have a Lambda function pulling those messages out, and then either you can submit those items to the database, right, at a pace that the database is, can keep up with that, or you can modify the primary key into a pattern like we talked about in the previous lecture, where you can append random values to the key. So you can get those into the table, right, without creating a hot key or a hard partition. So when it comes to, let's say, write-heavy applications, right, you have a number of options that you can work with. And using a simple queue service as a buffer, works pretty well. You can also use Kinesis as a buffer, right? So there's several areas that you can improve performance for write-heavy applications. So depending on the architecture itself, the one that you're designing for the organization, you can kind of keep that in mind, all of these different options. So I hope this helps. Practice with this. If you have any questions, let me know. With this, let's move to the next lesson. Now let's take a look at the design principles as they relate to the IAM, or Identity Access Management. This is one of the very important key areas as a solutions architect. So when you think about the IAM management, the design principles that you should keep in mind are that you're wanting to create a strong identity foundation. You can do that by leveraging the principle of least privilege. So not everyone needs to be an admin, right? Not everyone should be an admin. So members of your team should have, minimal permissions to do what they need to do, and not necessarily, have all access. So all of these components within your infrastructure, such as EC2 instances or Lambda functions, should have the permission, only to those individuals that need to do their jobs, and not necessarily more. You should also enforce separation of duties, and you should also reduce or eliminate the need for long-term credentials. So remember, within the IAM management service, you have the ability to create roles, and roles are very powerful, very effective, and that would allow you to delegate permissions to other Amazon services, maybe Lambda, Elastic Beanstalk, EC2 instances, or, let's say to another account even, cross-account. So instead of relying on long-term, right, embedded in the code, for example, or sharing long-term credentials, you can rely on roles to grant temporary credentials, so that if those credentials were somehow compromised, you would know that they will expire. So as you move forward, as we move forward through this IAM, keep these core design principles in mind. And these are important because they will take you a long way. And even in my experience working on enterprise projects, IAM roles, groups, they play an extremely important role. So with this, let's move to the next phase of IAM. Now let's take a look at the securing identities and credentials. How do you do that? So with the Identity and Access Management Service, this is responsible for authentication and authorization of, let's say, for users for accessing various AWS resources. You can create users. You can organize those users into groups, like I mentioned earlier. You can also set a password policy and enforce certain types of passwords to be created, and these are pretty basic, right? You can also enable MFA, multi-factor authentication. But remember, the management and configuration of these things is your responsibility. Any of these credentials that you actually create for end users, it's actually the solutions architect's responsibility, as well as the organization's responsibility to protect those credentials. And those credentials come in different forms. You have access keys, for example, which is simply a pair of access ID, right, with a secret key and ID. And those are used to access AWS APIs. You can, use the CLI tools or the SDKs. And those credentials, you can access, or secret keys are considered long-term credentials. You can also give your users the ability to log into the management console by granting them a username and a password, and that's typical. It's worth noting that when they log into the management console actually makes use of the API in the backend. So the management console does not have any kind of special hook, right, that bypasses the APIs. So all of these would be long-term credentials. But again, that's your responsibility to create and manage and secure and follow those principles, or the design principles that I just talked about earlier. As far as the users are concerned, you can use the IAM management service to create users, straightforward, and those are created and exist within the IAM service. Just like we talked about that you can give them, the ability to log into Management Console, each person can create its own access keys. You can create policies that allow them to create their own access keys, but also prevent them to interfere with someone else. And of course, they can use those long-term access keys to configure the local environment, local tools, CLI, SDK, for instance, or other resources. You can also enable the multi-factor authentication device per user. So you have controls, additional controls such as policies, so that each user can configure their own MFA device and not interfere with someone else's device. You could also organize users into groups, right? Let's say John is part of the developer team, right? So you can create a DBA group or developer group, right? So like we talked about in the design principle, you should be following the principle of least privilege, remember? So the users should have enough permissions to do their job, but not enough to step on someone else's toes, right? So if a user needs more permissions than what they currently have, then they should be following a change management process. In other words, they have to seek approval or explicitly request the additional permission from the solutions architect or the engineer, right? And so these are some of the core key areas that you need to, kind of think about. So remember, we have different credential types. So if you find yourself logging into the AWS Management Console within, let's say, an email address and a password, you are logging into the master account, which has the root account or root access, right? Or the admin access, for example. So if you're logging in with simply a username and a password, then you're logging into AWS as a web management console as an IAM user rather than the master account user. And then you have the access keys, secret keys, that are again used to configure the CLI tools for the SDKs. You also have temporary credentials, right, that we just talked about, and I'm going to talk about also in future lectures as well. So just to recap quickly, the IAM to choose the credentials carefully, right? So, and recall the shared responsibility model. So as a customer, your responsibility is to configure users, right, for the customers appropriately. And it's your responsibility to protect those credentials, whether it be a master account credential or a credential or particular credential for an IAM user. So as a solutions architect, you need to be very careful and also document these credentials, because over time they grow and you'll find yourself going all over the place if you don't have a solid documentation. So this is also just a tip for you as a solutions architect. So I hope this helps. Just kind of follow along the design principles of least privilege, understand the different types of credentials, know when to use them, only grant minimal access to particular users, including creating groups, policies, and roles. With this, let's move to the next lesson. Now let's take a look at securing access to resources themselves. Remember that the way you grant access to a particular resource in AWS through policies. Policies grant authorization to perform actions on resources within the AWS ecosystem. They're written in JSON format, right? And then you have two types of policies. You have the managed policy, which are first-class objects that you can actually create and apply to multiple entities, maybe such as users, groups, roles, and so on. So within managed policies, you have the policies that are created and managed by AWS itself. And AWS gives us you a long list of pre-built policies to choose from that you can apply. And of course, you can also create your own customer managed policies. And again, the difference between managed policies and inline policies is that a managed policy is the first class object. It exists on its own and can be applied to a particular or other entities. Inline policies, on the other hand, does not exist on its own. It exists as an intrinsic part of the user or group or role. And generally, you use an inline policy if you want to write something very specific that only applies to that one entity. So you can create policies in different ways. You can create them using policy generator within the AWS Management Console, for example. You can write them by hand, right? I don't really recommend starting a policy from scratch by hand because JSON has fair amount of syntax that, it's easy to miss at times, right? So you got to be careful unless you're really good at it. So what I would generally, recommend is start with the generator and then modify it accordingly, right? It's much easier. So you have a template to work with, and then you can simply edit the template itself. So the evaluation logic is also important to note that you should be familiar with how policies are evaluated, right? So evaluation logic says that, remember, that for any entity, you can apply multiple policies. And any one policy can have multiple statements. So when the permissions are evaluated, the IAM service, will take all of those statements across all of those policies together into one long list. It will first look for an explicit deny, for example. If you don't find an explicit deny in that list, it would then look for explicit allow. And if you don't find an explicit allow, you would then fall back to the default implicit deny. So it's a security first approach. In order, let's say, for a user to be able to perform that action on that resource, that user would have to not only have to have allow, but also not explicitly deny. So a little bit tricky, but a common question is, if you have to provide allow, why would you want to explicitly deny? And the answer to that is, by using explicit deny, you can create further guardrails, right, that your users would have. So now let's take a look at an example, right? So I'm going to talk about in depth. So here the policy, if you take a look at the version itself, version here is not our version, right? It's not your version. It's the version of the policy language that the DSL, or the domain specific language from which policies are written, right, would hold the value, date-based version of that policy. And this could be a couple of years old. And this represents the Amazon's version of policy, right? You can pull that from the documentation as well. Next, you have the statement itself. So even though, it's a short statement, singular statement, but it's a collection of, steps. So remember, one policy can have multiple statements, right? A list of permissions being granted by this particular policy. So from here, you would then point to explicitly state the effect of, whether to allow or deny, right? In this case, let's say you're allowing, right, the following actions. So in this case, for example, you're specifically allowing let's say the S3 object, get object, and put object actions. And you'll notice here that those actions are namespaced according to the name of the particular service. So here it's S3. Then you list all of the resources. So you're explicitly saying that you're allowing these actions on these resources, right? And resource is a list. So here you're saying you're allowing the get object, put object actions on any object in this particular S3 bucket. You'll notice it just says, there's a path, my bucket start, right, / or whatever that path is. You're applying those permissions to every object in that bucket, not the bucket itself. Okay, so you got to be careful. So as an additional example, you can have policy with conditions. So here you can allow this particular set of actions under the conditions, right? For example, that the request is made from a particular set of IP addresses, perhaps IP addresses that belong, let's say, to your corporate static IP address range. So this is much more granular control, in-depth permission, in-depth security, under what conditions the request would be allowed or denied. So you have a number of things to choose from within conditions. So here, let's say you're using the IP address range, right? The source IP. So very powerful, that the way you can work with these policies. So additional areas that you can work with and you can think of when you're working with policies themselves and trying to write. Let's take a look at another example, right? So here, if under the condition that the server-side encryption header is not set, for example, or does not equal, let's say, 256 encryption, then you would deny the request, right? So really powerful. So it could be, allowed, and we saw this in the earlier example, that you were allowing in one policy, but here you're saying if you're not setting the server-side encryption first or the flag first, it would actually deny the request altogether. So you get the idea, right? So working with these policies, build a template, and then you can edit the policy itself and add conditions, even more powerful control that you as a solutions architect can implement based on the organization policies. Another thing you can do is leverage policy variables, right? So policy variable, you can spell that out with $ curly braces, :username, for example. So that's a policy variable. This allows you to generalize policies rather than having to write many specific policies. So here, in this particular instance, this policy is applied to a group of users that would allow each user in that group to manage their own access keys, right? So notice the asterisk here means all, right? Everything. That's what it means, right? So it allows you to create, manage, delete, and so on. It also allows each user to change its own password, right? Because the resource contains that policy variable, and the variable will be replaced by their actual username at the time the policy is actually evaluated during the actual request. And this will allow you to write one policy that can be applied to multiple users rather than writing specific policy for each particular user, right? So to recap, let's keep in mind the creation of policies, the specification of permissions and conditions, allows and denies, all of this is your responsibility. Under the shared responsibility model, it's your responsibility to create the appropriate permissions for your users, roles, groups, right? And it's Amazon's or AWS responsibility to faithfully execute those permissions. So keep that in mind, and this is a good test scenario as well, right? So you can also create granular control, in-depth secure resources, and provide additional layers of security using these policies. So they're a very powerful set of tools that you can actually use and implement. I hope this helps. Practice with this. If you have any questions, feel free to post in the discussions area. Reach out to me. I'll be glad to help with this. Let's move to the next lesson. Now let's talk about the temporary credentials. So before we actually talk about these temporary credentials, let's first take a look at the patterns, right? Credential patterns. There's certain things that you don't want to do with regards to credentials. And of course, managing credentials is your responsibility under the shared responsibility model. So one thing is that you don't want is to have access keys within your code. The issue could be that those keys could be exposed, the developers can find them, and perhaps just copy and paste them and use them, even though they don't have the intention, right? So now you have a logistical issue in that you have to read or rebuild rather and redeploy when you want to switch out credentials or rotate credentials. So you also don't want to embed them in an environment or environment variables for the same reasons, because they'll be exposed. So now there are some logistical issues. Who has access to that machine? You don't want to share credentials either with third parties, for example. You don't want to share credentials with, or a single set of credentials, with enterprise users, right? You certainly don't want to, share credentials with millions of web application users. So you don't want to embed credentials in a mobile application, for example, allowing millions of users to leverage that same set of credentials. So they're making it very difficult to rotate credentials, by creating and deploying versions, in mobile applications. So in a way that you can get around that is to leverage temporary credentials. And you can leverage temporary credentials by using roles. And we'll talk about how roles work in future lessons, but just an important note here, right? So the better practice here is to delegate permissions to, let's say, EC2 instances. When you have applications rolling on EC2, for example, instead of embedding credentials within the application code itself, you can simply allow the application using the SDK to receive temporary credentials from that instance with a given role. You can then delegate permissions to AWS service such as Elastic Beanstalk, and then allow the Elastic Beanstalk service to actually perform actions on your particular behalf. You can also delegate permissions to a user temporarily. So you can follow, let's say, a sort of pattern with your accounts in that regard, and have some users generally, or let's say most of the day, or a particular set of, or have a particular set of permissions, right? And that is really the temporary credentials. They can actually assume a role and then use those temporary credentials, and then use those credentials to perform some particular action that they're not normally able to do, but you're allowing them temporarily. You can also, provide separate accounts, right? Which is a common practice. You could have an admin account where all of the users are, and then perhaps you have an account per department, per environment, per group, per section, right? Where users exist in one place, but you're leveraging roles and assuming roles into other accounts. And that other account could be a third party, such as a vendor or a client, and so forth. So again, just as a reminder, it's worth mentioning several times, right, that in a shared responsibility model, the creation and management of these things is your responsibility. So take all of these things very seriously and very carefully, right? And ensure that you're not just throwing out all these credentials, you're actually granting just temporary credentials for a particular task to a particular user, for example. Now let's take a look at the roles for EC2 moving forward, right? So here, for example, you have, let's say, an application running on EC2 instance, and it needs to authenticate to the AWS API so that it can access other AWS services, maybe S3, DynamoDB, Kinesis, or QService, and so on. So in order to do that, it needs credentials. Now, in order to get those credentials, you can apply a role to the instance, and that would, give that instance a way of retrieving the credentials. You then can apply a policy to that particular role, and that policy, as you had talked about earlier, right, specifies the actions that are allowed to be performed and the resources on which those access is allowed. Now, the security token service is a service responsible for generating temporary credentials. Important to note. So the security token service would generate these credentials and then deliver them to the hypervisor, or the hypervisor more accurately would be, would fetch them from that security token. The AWS SDK or the CLI tool, if they don't find credentials embedded somewhere, they would automatically look to the instance metadata service. So remember that the instance metadata service is available to all EC2 instances, and it's a small, service, let's say, that you can make calls to get information about that EC2 instance. So, for example, the application should not have any kind of credentials embedded within the environment variables or the code. As a result, the SDK would not find, and would automatically make a call to the instance metadata service to retrieve those temporary credentials that were put there by the hypervisor. Then your application can actually use those credentials to authenticate to other AWS services. And so the beautiful thing here is that now you've given the EC2 instance in your application a way to retrieve credentials that are regularly rotating, right? And these credentials live for some short period of time, for example, and then they are automatically rotated, let's say 5 minutes prior to expiration. So if those credentials somehow were compromised, for example, you don't have to worry about them anymore, right? Because you know that they will expire very quickly. So that allows you to stop embedding credentials within your code, within your environment variables, or any other configuration files. You don't want to embed those, right? So this is important when you talk about temporary credentials. So I wanted to cover in depth the actual scenario of how the actual process works when you're working with temporary credentials. And by far, this is also a good way of securing your infrastructure. Now let's take a look at the cross-account access, right? So let's say you have two accounts to actual AWS accounts. You have the admin account, and then you have the, let's say, the production account or a dev account. A very common pattern within AWS and across organizations. So the idea here is that you have the user that exists within the admin account, right? And then you have the resources that exist in some other account that the user needs access to. How do you do that? The way you can enable that is through roles, cross-account roles. Let's say you are going to create, or you've created, a cross-account role providing a secure way to allowing access to resources in that account from another account. So when you create that role, you're actually establishing a trust relationship within IAM, right? So, and the production account is trusted, delegating permissions to the actual admin account. You can then apply a policy to the admin role. Again, the policy will actually define the actions, right? The resources that are allowed or denied by use of that role. On the admin account, the only permission you'd have to grant is for that particular user is the ability to assume the role. So you're allowing the, let's say, STS assume role action, and that is that critical permission. So without that, the user would not be able to access or leverage that particular role. Then the user would make a call to the security token service to say, I want to assume this role. The security token service will then return temporary credentials, and the user can then use those temporary credentials, access resources in that other account. So that particular process of assuming that role and then collecting those temporary credentials and then making those temporary credentials available for subsequent requests, that whole process can be simplified using the SDKs, right? CLI tools, right? There are ways to configure those tools automatically. Go and fetch those temporary credentials, once you specify those from a different profile. So a normal work uses standard credentials, but if you want to leverage different profiles, right? So you'll say AWS configure, profile, and then the CLI and SDKs would automatically go and get those temporary credentials and use them for those calls. So again, keep in mind that a common pattern across enterprise organizations, in my own experience, is that they have multiple accounts. So instead of having multiple users in all of these different accounts, you can simply use the assume role scenario and use the cross-account access through those roles. So you can leverage these cross-account roles and gain access to other accounts and resources. And this could be accounts that you own, or it could be accounts, there could be vendor accounts or vendor-client relationship. So if you ever hire, for example, a consultant, right, like myself when I go, there's no need to create a new account, right? Because we have our own accounts, right? So all you need to do is just grant the ability to assume or provide, myself a role, and I can assume role to that other account. And that would mean that it'll be a secure access as well for the organization itself. So I hope this helps. Practice with this. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Now let's take a look at the federated users, right? So for any organization, for example, looking to leverage AWS services, might be thinking, I already have a number of organizational users, maybe an Active Directory, right? For example, such as LDAP or a Microsoft Active Directory. Maybe you have web and mobile application users who log in with, let's say, Facebook accounts or Google accounts or some other third-party provider accounts, and you want to grant them access to AWS resources. So the question becomes, how can you actually allow users to authenticate with existing credentials that they already have and access AWS resources? How can you avoid duplicating user accounts altogether? And the answer to that is to leverage identity providers. Within AWS, you have a number of options for identity providers that would allow you to use or provide those users wherever they are to authenticate within their existing accounts. So you can manage accounts centrally and grant those users temporary access to AWS resources. These options would be, for example, SAML, right? You can use the SAML 2.0, for example. You can grant access to AWS Management Console, to the CLI tools, to direct API access for users authenticating with existing enterprise credentials. You also have AWS Directory Service. That would allow, access to AWS Management Consoles to users authenticating with Active Directory username and password. You don't have to create a new account in AWS, right? So this is an ideal scenario if you already have credentials. So if you're focused around, let's say, the Management Console, or if your employees, team members need more lower level access, right? Maybe CLI or direct API access, then you would probably want to look at SAML. You also have Amazon Cognito service, right? So Cognito can actually provide API access for web and mobile application users, who are actually authenticating, using their own connections, or logging in with Facebook, for example, or Twitter or Google. You also have AWS Single Sign-On service. Single Sign-On provides access to multiple AWS accounts and business applications. It has, let's say, built-in SAML integration with business applications such as Salesforce, Office 365, and so on. So it's a very common practice within AWS to leverage multiple accounts. As I mentioned earlier, they can use AWS organizations to manage those accounts in a hierarchical structure. So that would allow you to integrate existing credentials that can then be used to access multiple AWS accounts. So as you can see and observe, that you have a number of options to satisfy whatever scenario you may encounter as a solutions architect. So if you have a team that needs access to AWS, there's absolutely no reason to duplicate those accounts. Leave those accounts wherever they are and just simply leverage one of these tools to provide that temporary credentials in a straightforward manner of gaining temporary access to various AWS resources, right? And that's the key to designing an effective infrastructure or architecture itself. So now let's take a look at the IAM best practices. First, with, let's say, the new accounts, there are some first steps, very critical first steps that you should take as a solutions architect. If you just recently signed up, let's say, and still logging in with your email or password, there are things that you need to really be careful. First, you should enable CloudTrail. CloudTrail, remember, is a service that reports all of the API calls made to the AWS APIs, right? So by enabling CloudTrail first, that will then record and leave, let's say, an explicit log of everything that you do, and that's pretty powerful. Then you can create an admin user, perhaps a super admin user, as an IAM user, right? You can then, let's say, add an optional condition. Remember, we talked earlier about conditions in policies, right? You could further contain, say from where or from what time a user is allowed to log in, or, actually use those permissions. So you can create an admin user, but perhaps, they're only allowed to use that account from on-premises, right? You should then enable multi-factor authentication on top of that, on the root account. Remember, the root account has absolute access to all resources all the time, and access cannot be limited. And we'll talk more about root account later on as well. So you should then enable, cost reports. And so one of the things that is generally done with the root accounts, for example, and then you should log out of the root account and then log back in as the admin user. So once the new account or accounts have been cleaned up and secured in this manner, you can then go on with that admin user to create additional users, groups, and so on. Some other best practices to keep in mind regarding IAM is to remember that the master account or the root credentials, if you're logging in with, let's say, email addresses and passwords, then you're accessing the master account. Keep that in mind. So you should protect that account at all costs. So your master account has, let's say, root privileges that cannot be limited. If someone compromises the master account, they could perform any number of attacks or any number of operations. They can spin up expensive resources that you would have to pay for, right? Or they could delete resources that you'd have to pay for in other ways. So be very careful. You should then, delete all of the existing access and secret keys, right? Because they will not be used. They only, leaving them there, basically increasing the surface area for a potential attack, right? So you should not be using your master account for day-to-day operations. You should only log into the master account rare occasions where you really would have to use, or maybe some billing purposes or other purposes that require the master account. So again, we talked about earlier, you should be following the principle of least privilege, giving your users and roles and EC2 instances and applications only those permissions, to provide or what they need to do on a limited basis. And you should, of course, rotate long-term credentials. So if your users have access keys, let's say, and passwords, those should be rotated regularly. And lastly, for anyone who logs into the console, especially the master account, you should enable multi-factor authentication. I've talked about that before also. It's very important, right? This is a key area or a security layer built on top of another layer, right? That would save you a lot of trouble in the long run. So I hope this helps. All of these areas are best practices when you're working with the IAM roles. So by following these best practices, you can continue to ensure that your AWS resources are best kept secured. I hope this helps. Practice with this. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Let's now talk about monitoring your infrastructure. So as a solution architect in any given infrastructure, that needs to be monitored, not only so that you're aware of the performance, but also so that you can actually determine whether there's a security event, right, happening, maybe. So in the beginning, it's important to establish a baseline of normal behavior. You can then later identify abnormal behavior within your AWS ecosystem. And of course, the only way to do that is through regular real-time monitoring. For example, rapid spike in load balancer or logins requests, could indicate a security event. A rapid spike in CPU, disk, or network I/O may also indicate a security event. You can use CloudWatch alarms to then trigger notifications or automate responses to deal or investigate with the security events that you might detect with your monitoring. Now, those are just a couple of examples, right, of attacks that come through your infrastructure. But there are other attacks that are designed to change your infrastructure, and you want to watch out for those as well. You can use AWS Config that provides continuous monitoring of resources inventory and the current configurations. You can create, for example, config rules that represent a desired configuration of resources at a particular given time. So that if, for example, config notices a change, detects a change to the infrastructure that violates the current configuration, for example, it will then send a notification to the admin or the solutions architect or to a Lambda function that can then be used to potentially reverse those changes. So again, automated procedures can be run by Lambda in response to either notifying you as the admin or reversing those changes. You may have a security group, right, that's defined by role to say that it should never allow port 22, for example. So if some, accidentally or with other intent, does something to port 22, right, config sees that, triggers the Lambda, and then undo that change, right? So pretty powerful. So those notifications can then be sent to other workflow systems that would allow you to, let's say, or routing escalation, right, for example. So by monitoring your infrastructure, again, not only for performance and availability, but also for security, you can create a much more robust, resilient, reliable, and secure environment. And all of this is leveraging managed services within AWS. The monitoring here itself is being managed by AWS, right? So you're not doing anything yourself. So you're not carrying the burden. AWS is, in fact, lifting all the heavy burden for you. So now let's take a look at the capturing logs. So before we talk about the technology that actually uses to ingest and capture logs, let's first review where logs come from. Logs can come from Elastic Load Balancer, generating access logs, for example. They can come from applications or operating systems running on EC2 or in containers with the Elastic Container Service. Logs can be generated by Lambda, whether or not it's your own code actually writing any logging output. Lambda service will generate logs anyway. You also have S3 access logs. You have VPC flow logs, for example, allowing you to capture metadata about the traffic passing through the VPC, whether or not the packets are accepted or rejected, source and destination information. You also have CloudFront access logs. And then, of course, you have CloudTrail logs. Remember, AWS CloudTrail is a service that records all given events, all calls, requests made to the AWS API for the purpose of managing AWS resources. So anytime credentials are used to manage resources, you can capture, which credentials were used by leveraging CloudTrail. And of course, this is not an exhaustive list. So you see, these are just examples of where you might find logs. And this is, important too, because when it comes to capturing logs, you have several choices. You have Elastic Load Balancer log, for example, can be stored in S3, right? You can, the actual application itself could leverage the SDKs to write to CloudWatch logs directly, or they can simply write to a file, placed on an EC2 instance and allow CloudWatch log agent to read those logs through the service. VPC flow logs are automatically sent by enabling those that are automatically sent to CloudWatch log service. And again, it contains metadata about the network packets flow and through the VPC. Lambda logs, for example, by default, are like CloudWatch logs that are required in order for you to be able to actually create a Lambda function in a, within that particular function, and it needs an execution role, by the way, that allows you to write those logs. CloudFront access logs, for example, can also be stored in S3, and these type of logs will give you the access, a way of seeing exactly what kinds of patterns of access that is happening through the CloudFront distribution. Now, it's a common practice that if you're using, let's say, S3 as an origin, then you would probably want to, let's say, enforce access to that, S3, content of S3, through CloudFront, so that through CloudFront access logs can be accurate. You also have CloudTrail events, right? They record, logs directly through S3, or you can use those through CloudWatch alarms, giving real-time access, providing you real-time, access to all of these events. You can also capture Route 53, DNS, right? So those could be another efficient manner and provide you real-time access into which domains are being requested from Route 53, for example. And then, of course, a lot of these logs could very well go to S3, whether the logs are collected in S3 directly or if they're collected in CloudWatch. CloudWatch can then send to S3, and then after some period of time, you might decide, well, I don't, maybe compliance reasons, for example, or other legal reasons, you may need to keep and secure these logs, even though you don't ever look at them again. So remember, you can leverage the lifecycle bucket role to automatically transition those logs to AWS Glacier to lower the cost of storage, right, for long term. So logging is a key component of securing your infrastructure, right? So you ideally want to log everything. Logging can, help you with security, for example. It can help you create and capture data that you can later analyze, right? Use to track trends, behaviors. Underlying security infrastructure is more visible that way. And, you can collect and store those logs, of course, for long term as well. So I hope this helps. Of course, logs are important, and they could be sometimes even cumbersome for a solution architect to go through all of these logs in different areas and, managing all of the infrastructure. But again, this is all under the umbrella of monitoring your infrastructure. And this is a powerful way of really understanding what's going on within the AWS ecosystem. Let's now take a look at and review analyzing logs. So within AWS, you have a number of options that you can actually use to derive meaning through those logs. So we've talked about, let's say, where logs come from. We've talked about how you can capture those logs. So here, let's take a look at the number of options that you have in terms of analyzing those logs. So first, you have CloudWatch alarms and filters. So you can use CloudWatch filters to derive custom metrics from those logs. And then from there, you can create different alarms. AWS Lambda can process log events directly. You can use Lambda to programmatically look for patterns that, generate some type of response. You can leverage AWS Simple Notification Service, SNS, right? So with these SNS topics, you can send notifications which can allow integration with some third-party service. So those notifications can and should be included in your workflow with tools such as collaboration or response services, right? So plenty of organizations out there today are using, tools like Slack, for example, in order to collaborate with team members in real time. So by having notifications be put directly into Slack, or a workflow that people are actually looking at, much easier for you to be aware of what's actually happening with your infrastructure. So as far as security and incident response is concerned, even if the response is entirely automated, at least users or humans are seeing what's happening. So if you see, for example, if something has happened and a response has started, then you might want to make a note of that and start to investigate yourself as a solutions architect, right? And if not, then you can just, take other actions. You also have CloudWatch subscriptions. These subscriptions can send logs in near real time to a number of services, such as Kinesis or Elasticsearch. And from there, for example, AWS Lambda can process the data from Kinesis, again, in near real time as the data is streaming in. You're actually using Lambda to pull from Kinesis and derive meaning to those log events. So maybe you want to store those results in some database, maybe in DynamoDB, for example, or if you wanted to create, let's say, some type of real-time dashboard related to the health or status of your entire system or user behavior, you could do so. So Amazon Elasticsearch Service can also be subscribed to CloudWatch logs, to streams in near real time. And this Elasticsearch service includes Kibana, right? Which is a powerful UI that allows teams to visualize and analyze all these logs. CloudWatch can also automatically archive logs directly to S3. And now you have a central place for numerous other services to access those particular logs. From there, you can use, Amazon, EMR to do any number of advanced big data operations, right? For example, you could transform those log files into, say, Redshift load files. You also have Amazon Athena, provides serverless platform for querying data, big data, directly in S3. It doesn't need to be extracted, transformed, it doesn't have to run through the ETL operation, right? It performs SQL-based queries directly on the data itself and gives you the results, right? Powerful tools that you can use. And then, of course, you have the business intelligence applications. Connect to Redshift or Athena with the existing ODBC or JDBC drivers, and then run any ad hoc queries that you can think of. And lastly, you have, let's say, a number of third-party services, such as Splunk, Loggly, right? They can actually grant read access to the S3 bucket, and those services can pull log data directly from S3 and then start to analyze, right? And give you some additional insights into the data. So you see there are several options and ways that you can actually analyze. And these are all practical ways because enterprise organizations use these tools every single day. This gives you a good way of monitoring and securing your infrastructure and really getting detailed about logs and what's going on, the patterns, the dashboards, and so on that you can actually create. I hope this helps. Practice with this. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Let's take a look at routing and security, right? First, routing, just to be clear before we get into the details of routing. Routing is concerned with whether or not traffic is allowed to flow from one network to another, right? So you do need to keep in mind that every VPC comes with a default route table, and you can create custom route tables, right? Also, by default, the default route table is also set as the main route table, right? And there's a difference between the default route table and the main route table. You can choose any route table to be the main route table, for example. So with no explicit association to a route table, a subnet by default will be implicitly associated with the main route table. And that's important to note, right? So a particular subnet, is by default is implicitly attached to the main, or, let's say the default route table, which is selected as the main route table, if that's the case. It's also worth noting that every route table, for example, includes what you call a default route. And default route is included there to ensure the local traffic remains local. So you'll notice that the, .0.0/16, which is the range of your particular VPC, so every route table includes that particular local route. Now, in order to gain access to the internet, you need to create a route table and routes in order to make that happen. First, you need to have, or you do have, an internet gateway, which is attached to the VPC, right? You can then, let's say, have a route table which is explicitly associated with subnets that you want to control with that route table. You can then, let's say, have a route added to a route table that says IP ranges other than local ranges are then routed to the internet gateway. And of course, you'll also notice that within this particular subnet, for example, you're allowing EC2 instances to be automatically assigned a public IP address so that users can access, right? So in order for these instances within the subnet, they will need a public IP address, and that makes sense. And once they have that, any traffic, according to this particular route table, for example, would be allowed to flow through the internet gateway. Now, it's also worth noting that, again, getting back to our point about routing as security, this is where it actually happens. You can, instead of listing all, let's say, zeros, right, which means any and all access to everything, right, you can whitelist specific ranges. So if you wanted your instances to communicate, let's say, over the internet, right, to a known group of hosts, such as a trusted third party, right, or a corporate static range, right, you can whitelist those IPs and allow communications with trusted systems. Any other traffic outside that range would not be allowed to, be used. So it's a common practice that in any given architecture, you have some instances, such as the backend instances, for example, that needs to reach the internet while remaining private at the same time. These instances may need to reach the internet in order to, let's say, download code updates or libraries or patches, right? They may call out to configuration management or some third-party logging services. So you want them to be able to do that, but you don't want hosts that are on the internet to reach in to those particular EC2 instances, right? So you want to keep them private at the same time. So you can leverage the NAT gateway that would give you the fully managed network address translation, essentially as a service, right? Fully managed by AWS. You don't have to do anything, right? And then leveraging a route table, you can then route internet destined traffic to the NAT gateway. And by doing that, you are actually allowing private instances to reach the internet while at the same time being protected from the internet. So the pattern I hope you started to see is that routing is concerned about whether or not two different networks are allowed to communicate with each other. Routing is not, is not concerned about protocols and whatnot. It's only concerned about whether, this range of IP address has what kind of access, that range of an IP address has another set of access. So, and this is important to know. So regardless of ports and protocols, once you have a channel by way of routing, then you can start to filter the traffic. And of course, we're going to talk about those later on as well. But for now, importantly, routing to the internet, routing to with network address translation, giving EC2 instances, whether it's private or allowing certain specific access, right? Another thing is VPC peering. You can use VPC peering. It's basically a communication channel between two VPCs. So that connection between two VPCs is fully managed by AWS. So it's not a single point of failure. It's not a network bottleneck, right? So as far as the communication reliability or resilience of that connection is concerned, you don't have to worry about that. It's all fully managed by AWS. And the way that you enable traffic to flow from one VPC to the other, you first have to create the connection, and then you create the routing rules. And each route table creates the local route and also contains a route to sort of like a complementary route with each VPC is pointing towards the other by way of the peering connection. So again, routing is your first layer of security, right? When it comes to allowing internet access, like I talked earlier, you can choose to whitelist certain ranges, so your systems can only communicate with trusted providers, right, or hosts out there on the internet. In terms of peering connections between two VPCs, you could choose to route the entire VPC, or you can choose to route only certain subnets. So you have a lot of control of how traffic flows from one network to the other. And this is the important concepts of working with routing and security. So I hope this helped. Practice with this. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Now let's review security groups. So picking up on previous lecture, you still have another layer of defense, right? So let's say you have a two-tier application. You have a load balancer and a public subnet, and an application subnet and a private subnet, right? So in this scenario, now the general practice with security groups is that each tier gets its own security group. So your load balancer would get a security group, and then all of the instances that are part of the application tier will also get their own respective security groups. So let's take a look at the security group rules for the load balancer, for instance. So just like what we did with network address list, right? You have to open up a hole in the firewall to allow traffic that is required. So for a security group, you're allowing port 80 and 443 coming in from the internet, right? You'll notice that if you specify all zeros, that means any and all IP addresses are allowed to come into the subnet. That means that any and all IP addresses are allowed to enter that security group. Now, for egress rules, for example, right? They're a little bit different than other rules here. So what I want to draw your attention to is the fact that egress rules apply to initiating new connections. So when you think about the nature of your load balancer and how it fits into the architecture of the entire infrastructure, the only connections that your load balancer will ever need to initiate, meaning there's a brand new connection that's being created, right? The only connections needs to initiate would be on port 8080, for example, to your backend instances. The load balancer should never need to create a new connection to any other host on any other port. So by specifying this egress rules, you're simply saying that the load balancer is allowed to initiate a new connection on port 8080, but only to a member of the app security group, hence the layer of defense security. So if the load balancer is compromised for some reason, the only connections to your application servers and do nothing else, right? So the way this is enforced is through security groups references. They provide a way to take security based on functional tiers. And you'll notice that the egress rules of the load balancer, instead of specifying an IP range, you're specifying the actual security group ID, right? So you're matching the security group ID with that of your application tier. It's a little bit easier that way. So now let's take a look at the security groups for the application server. So here, for example, you have different ports that are being used by the application, for example, and they're different from the load balancer. So the application server would get its own security group with own unique set of rules. And you may be using security group references here as well. So you're saying that the application server, for example, is allowed to receive traffic from port 8080, but only if it originated from the load balancer. No other system within the VPC itself or out there on the internet is allowed to connect to the application server on port 8080. Only the load balancer can do that. And then, of course, you have those packets coming in from the load balancer on port 8080 can get through the security group and into the instance. And notice, because let's say the security groups are stateful, right? They recognize the responses as being, okay, so they accept those responses. So you don't need to specify the ephemeral ports, right? They'll be returned automatically because the security groups recognizes the response as being responses. So again, you only need to specify the ingress rules, right, to have more control what other systems your application server is allowed to initiate new connections to. So perhaps, let's say, if you were to keep going and flush out the rest of the tiers, right, you would allow the application server to reach your database server on port, let's say 3306. To summarize, security groups are applied to instances. You can use EC2 instances or RDS instances. They can also be applied to load balancers. They are, let's say, stateful, right? Meaning that they do recognize responses as being responses. You can also specify ingress or egress rules. You don't have to specify both, right? Like you do with network access control lists. Keep in mind that by defaults, right, or the defaults rather, for new security groups, all ingress traffic will be denied, but all egress traffic will be allowed. Exam question, right? So security groups are firewalls for individual devices and load balancers, EC2 instances, let's say, or a database instance, or even elastic network interfaces as well. And they provide a way of tightening security based on functional tiers. And that's a good way to have another layer of security defense. So I hope this makes sense with security groups and how powerful they can be when you talk about these security layers. Let's review how to secure the operating system. So now that you have secured the subnets, network access control lists, security groups, you've secured your load balancers, EC2 instances with security groups, for example, you need to also be aware of yet another layer of defense, right? Which is the security of the operating system, which is your responsibility. So as far as the OS is concerned, for example, AWS is responsible for installing the operating system on that VM. And once that happens, you are then responsible for the ongoing security of that operating system. You're also responsible for the maintenance, right, of the operating system, access to the operating system, for example, and for installing and configuring any intrusion detection or prevention systems on that operating system. So the best practice would be very much like the AWS, other best practices that we talked earlier, which is the least privilege, right? Only provide access to those individuals who really need it, right? Do not provide access to every EC2 instance to everyone, right? And you don't necessarily need sudo or administrative privileges, okay? So you should also look to configuration management service within AWS, and you have options like, for example, OpsWorks. You can leverage from Chef or Puppet servers or Ansible towers, right? So there's several options, and you can use these kinds of systems to help maintain a known state rather than accessing systems on your own and doctoring these, right, in these systems individually, right? So, you can use these configuration tools to manage, different states. So leveraging configuration management using third-party tools like Chef, Puppet, as well as Systems Manager in AWS works as a key to manage all of the instances in a known state. You should also be leveraging change management. So any changes that are made, even if they're made to the operating system, are also recorded. So AWS Config as a tool can help you with that. So anything that is done inside that machine should also be logged. Capture that with CloudWatch logs, and that provides a trail of, for audit purposes, for compliance purposes, for other regulatory affairs. And lastly, you should also consider, immutable architecture, and kind of take a look at and research as a homework what that really means, right? So that talk about immutable architecture. The idea there is that once an EC2 instance is launched, it will not change. So that the EC2 instance, for example, very much like a row of containers, right? Once it's running, it will not change. So if you wanted it to change, you'd have to go back to your machine image, right? Or the machine image plus bootstrapping scripts or configuration management scripts to ensure that a new machine comes to life in a known and working state, rather than trying to create the state from an existing machine. So remember, to recap, all of these things, as far as the operating system is concerned, is the customer's responsibility. Okay? So I hope this kind of makes sense, talking about operating systems and also the shared responsibility model. And of course, on top of that, OS as being another layer of security defense. Hope this helped. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Welcome back. Let's take a look at how to secure data itself. So now let's talk about authorizing, let's say, access to private content. Now there are plenty of use cases out there where you have, for example, some content that is meant to be publicly available, such as website assets, right? Or website pages, CSS, JavaScripts, and so on. Now these kinds of files you want to be easily served from a publicly readable S3 bucket. And other content, such as PDFs, for example, right? Adobe files, other digital content, ebooks, or other video files should be kept private, only available to users who are authorized to see it. Perhaps users who have purchased, let's say, your subscriptions or your items. So you have a way of allowing users access to that private content through CloudFront signed URL or CloudFront signed cookies. So the cookie contains metadata about the object in question, timestamp, and of course a signature itself, so that if any of the metadata is tampered with, the signature will then become invalid. So a signed URL or signed cookie makes it very, very difficult, almost impossible, right, for someone to access the private content or some different content by modifying the actual query. The reason, for example, you're using CloudFront signed URL as opposed to S3 signed URL. The CloudFront gives you some more advanced controls over, let's say, standard S3 controls. One example might be that once you give the user that signed URL, you don't want them posting that URL to Facebook. So you can limit through CloudFront. You can actually limit, say, for example, what IP address the request comes from. So if the user shares with someone, the request would be invalid. So you need to keep S3 private while allowing CloudFront to access S3, and you can do that with the Origin Access Identity, OAI, right? Which is a special identity that allows CloudFront ability to read from the S3 buckets. And then your backend services running on EC2, for example, or someone behind Elastic Load Balancer, you would then dynamically generate that signed URL or signed cookie and turn that, to the end user, provide that to the end user. Give the end user a URL in order for the end user to access the authorized content. Now let's take a look at encrypting data at rest. So here, we're going to talk about AWS Key Management Service, also known as the KMS, right? It would ultimately store and manages the customer master keys. So, for example, let's think about your application, right? For example, encrypting data. So the application could make a call, let's say, to the KMS, right, to request a data key. The Key Management Service role uses that customer master key to encrypt that data key. It will then return to you both plain text data key and the encrypted data key. The application will then use the plain text data key to encrypt, right, the data itself. So now you have, both an encrypted data key as well as the encrypted data. That is your responsibility to store. KMS only stores the customer master key. So other systems are responsible for, storing the data key and the data. And remember, with encryption, if you lose the key, you lose the data. Very important. So KMS only stores and manages the customer key or the customer master key. So when you want to decrypt your data, you perform the process in reverse, right? You would then, give KMS the encrypted data key specifying the appropriate customer master key. KMS would then decrypt the encrypted data key, giving you back the plain text data key that you can use to decrypt the data. So the advantages to KMS is that it is a fully managed AWS service and very secured infrastructure. Managing keys in a very secure way is difficult to do. So rather than your own team be burdened with that, you can offload that to AWS ecosystem. Now, it's worth noting that technically speaking, KMS is a multi-tenant, software-based service. It is, backed and powered by hardware security modules. But the front end that you really interact with, right, software-based, is technically multi-tenant. So there could be regulatory policies, for example, may prevent you from using that tenant environment. It does log the use of your keys to CloudTrail, so you know exactly what credentials are being used, what are they're referred to as customer master keys. And it's also worth noting that the key material here, the actual encrypted graphic material that makes up the customer master key, never leaves the KMS. So it doesn't really goes out from the hardware security module. Only ever referred to the customer master key by ID, and that's all it provides you. KMS also integrates with a number of other services, and it is really a compliant and certified, SOC 2, let's say, SOC 1, SOC 3, and PCI-ISS level 1. So within scope for all of those certifications, right? So I'm going to provide you a list of a number of different services, right, that KMS works with. So if you wanted to, for example, perform encryption with S3, then S3 would manage all of the things that we just talked about. The whole process of gathering, let's say, data keys, encrypted data keys, storing those keys, right? That whole process is managed for you by these other services when they leverage KMS. So in case of S3, for example, you would end up with a unique data key per object. In case of AWS Glacier, you would use a unique data key per archive. For EBS, you would use a data key per volume. For Redshift, for example, it would use a 4-tier envelope encryption. Envelope encryption means that you're using one key to encrypt another key, right? So with Redshift, there are actually a number of different keys that are encrypting each other numerous times over. And then with RDS builds on top of EBS encryption while leveraging the key per volume. So keep in mind, the protection of the data is your responsibility, not AWS's. And within AWS, you have a number of options, let's say, to choose from and how your data is encrypted. KMS being one of them. And again, KMS, if you're able to use a multi-tenant environment, KMS is an excellent choice for managing encryption keys. So I hope this helps. And also remember, from a practical tip, as in my own experience is, working with these keys can become a little more tedious. So you need to be very careful and be very resilient with your architecture itself, so you really understand the security levels and the key levels down to the object levels, right? So make a note of everything that you do as you're designing these networks. So I hope this helps. Practice with this. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Welcome back, guys. I hope you're finding this content valuable and enjoying. Now let's take a look at how to manage SSL certificates. With AWS Certificate Manager, you can create free SSL certificates, including wildcards. And those certificates, for example, automatically renew and automatically deploy. Now, they are backed by a field or as a root authority. So Amazon would be the authority in that case. And because of that, they are trusted. And in all of the major clients, for example, right? Now, you can import existing, let's say, certificates if you have them already, but only the ones that are created by the AWS Certificate Manager will be automatically renewed. But either way, those certificates can be automatically deployed by the Certificate Manager to Elastic Load Balancers, CloudFront distributions, and the API Gateway. So when you look at, let's say, the potential infrastructure, you might have CloudFront Edge location, Elastic Load Balancer. Of course, the Certificate Manager would automatically deploy those certificates to those devices and automatically renew them as well. So if you need true end-to-end encryption, of course, you will need the connection between the load balancer and the EC2 instance to also being encrypted. And that means you need the SSL certificate, right? So in that case, since the AWS certificate cannot reach EC2, as a customer, as yourself, you'll be responsible for installing certificates on the instances. But the Elastic Load Balancer, by default, for example, will accept self-signed certificates. So you don't necessarily have to have a trusted certificate on the EC2 instance. So that makes your life a little easier as a solutions architect. If you want to, let's say, script the EC2 instance on startup to create its own self-signed certificate and install it, during bootstrapping. And by doing so, your connection will automatically be encrypted between the load balancer and the instance. It is possible to set a policy as an option on the load balancer, that tells the load balancer to only accept certain keys, right? So you can add a public key policy, let's say, to the load balancer that will then authenticate, the backend instance with that given public key. Now, it's also worth noting that CloudFront does not accept self-signed certificates from the origin. So if you place, let's say, an Elastic Load Balancer as an origin behind CloudFront distribution, you must use a trusted certificate, right? Now, I've seen that happen in the past where HTTP connections, right, to the CloudFront distribution, for example, are working perfectly, but HTTPS connections were not working. And I couldn't figure out, and spent a long time trying to figure it out, trying to debug it, and finally discovered in the documentation, right, that the edge location requires a trusted certificate. And of course, once I did that, everything worked fine. So keep in mind that in terms of security, encrypting the data in transit is a vital step in the overall security infrastructure scenario, right? So with the AWS Certificate Manager, that gives us a powerful option for ensuring that your SSL certificates, right, that are used by CloudFront, for example, load balancers and API gateways remain up to date, and that your traffic, remains trusted and secure throughout its journey from end to end. Now let's take a look at how to encrypt database connections. So we've talked about earlier how we can ensure encryption of when, that's a web or API traffic and using SSL certificates. But true end-to-end encryption would also mean that the connection between, let's say, the EC2 instances as well as your databases are also encrypted. So how do you do this, right? So it's important to understand that if you're using RDS, for example, it would also apply to running it on, let's say, EC2 itself. But at least with RDS, each DB engine has its own process for implementing SSL. So let's say Postgres, Oracle, maybe SQL or MySQL, and so on, will each do things a little bit differently. So keep that in mind, right? And of course, you can always refer to the docs as well. Now, you may need an intermediate certificate in order, for your application, for example, to trust, a certificate coming from the RDS instance. So in that respect, each region offers its own intermediate certificate. And of course, you can find, as well as, can find the endpoints and where to download the endpoints from the docs as well. And I'm going to provide you downloadable resources. So for most database engines, for example, some might be different than others, but generally speaking, RDS, at the time when you create the DB instance, for example, it will create and install the SSL certificate, right, on that instance for you using, the instance endpoint, the DNS endpoint as, a common name. So from there, it will be your responsibility to ensure that your application is using, SSL encrypted connection. And of course, whatever, user you've used that can be, attached to the RDS instance. So we can use, alter users, you can alter tables, you can grant users and enforce SSL connections, right, for that particular user. Again, between SSL certificates on the load balancer, for example, right, and CloudFront distributions, and SSL certificates on the databases, you can truly achieve end-to-end encryption, and you can really ensure that your data is being encrypted in transit, not just with the EC2 and the load balancers, but also with the database itself. Because applications at the back end, they use a database. So we've covered the entire security infrastructure as far as the layers of securities are concerned and the data, between services is concerned. And of course, we also talked about the private content, how to secure that as well. So I hope this helps. Hope this gives you a good understanding of implementing security layers. So in a given scenario on the exam, and of course you have to practice with this, right? Do a hands-on, as I will demonstrate using hands-on, how to create RDS instances, how to work with KMS, and of course all of these lectures will be hands-on for you going down as you progress further. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Now let's take a look at the design principles as they relate to cost optimization. So when it comes to cost optimization, there are a number of design principles that you can actually, pull from the well-architected framework that will guide your decisions. First is to adopt the consumption log. That means that within AWS, within the cloud itself, because of the on-demand nature of resources, right, and pay-as-you-go pricing, you can, pay for what you use, but use what you really need. So it takes some forethought and ongoing monitoring and constant reevaluation of your choices to ensure that you're actually using what you really need rather than being over-provisioned and paying for more than you actually require as the organization. Next, it would be to measure overall efficiency. You want to take the time to, again, monitor what you're doing, monitor your infrastructure, your business output, as well as monitor costs. So you can understand what it means by increasing output, right, and reducing cost. Next, you have, let's say, stop paying for services that you don't use. Paying for data centers maybe you're using. They're enormous capital expense. So, and you have ongoing fixed expenses if you maintain your own data center. So AWS, in the least, is responsible for the physical infrastructure. And in many cases, you can also, let's say, have AWS be responsible for other areas. You can have plenty of opportunity at that point in time, to have your own application. You can focus on your own application, right? And offload the burden to AWS, which lowers your total cost of ownership. You also have, let's say, the principle that says that you should analyze and, the costs, or total costs. So you have a number of mechanisms such as, multiple accounts. You can have AWS organizations you can manage that way. Cost attribution, billing alerts, cost explorer. You can create budgets. So you will know exactly down to the penny how much a particular project, environment, cost center, team, group, and so on is actually costing within AWS. And lastly, you also have reduced costs with managed services. So here, for example, like we talked earlier, for example, you have the ability now to shift responsibility, the operational burdens, not just for the physical infrastructure, but also for common services that don't necessarily add, for example, differentiate value to your application, right? So when you think about RDS or databases, allowing Amazon, to bear the burden to provide you the managed service, or maybe a NoSQL database or video transcoding, right? And the list goes on. And all of those cases potentially would lower your costs, right? Per transaction or per service. Once again, you have to evaluate those constantly, right? And that will give you a solid understanding of how to, work within these cost principles, right? So these are the design principles that I wanted to quickly cover as we move forward throughout this entire series of lectures on cost optimization. Let's talk about right sizing. What do you mean by that, right? When you think about the applications on EC2, for example, you need to consider a number of things, such as what size of instance does your application really need? Now, we talked about this very point earlier on when we talked about performance, right? The same question applies to costs. Not every application needs to run on an N4 16, maybe an extra large instance. The cost of such a machine is not, often warranted. So you need to ask yourself, what size EBS volume does your application really need? Not every application needs a 16 terabyte volume, right? And the same would be true for IOPS. What level of IOPS does your application really requires? And the only way to answer those questions, as we've talked about earlier, is through monitoring. So monitoring the performance of your application will give you an idea what usage is actually being utilized, right? And that will, allow you to make, good decisions. Now, you also think about, let's say, right-sizing your fleet. So, for example, not just the individual instances, but how many instances do you really require? Auto-scaling helps match supply with demand. Therefore, you'll avoid over-provisioning. No longer within AWS, for example, you're no longer provisioning, you're only provisioning rather your current demand. And you know that through monitoring, right? So just like we talked about in the reliability and performance, you can leverage monitoring to inform yourself, right? Inform you the current level of demand is. And then auto-scaling helps match the current supply to that demand so that you can avoid over-provisioning. And over-provisioning means you're wasting money, right? At the end of the day. The same questions would apply to RDS, for example. At what size RDS instance does your app really need? According to the data model, the amount of database, the amount of storage, the amount of queries, reads, writes, and so on. Now, you should also ask your provisioned IOPS. Really necessary. Keep in mind that this is true for EBSs as well, that some applications may not need the provisioned IOPS. So it's really whatever is actually going on, the patterns of data access, for example. Of course, monitoring will show you that, right? You would be perfectly served, perhaps, with the application will be served well enough with just a general purpose volume, right? With EBS volumes, you would pay for the storage and any provisioned IOPS. Those are requested. So that will lower your cost by reducing or even eliminating provisioned IOPS where possible, right? Another thing to consider, could you really run several different databases on a single instances? It may not be necessary for you to run an individual database on an individual instance, right? Because you're going to pay for that instance or having multiple instances, right? So in some case, you can even combine numerous databases on one instance and save money that way. So in terms of EC2, in terms of RDS, and really everything, right? These kinds of thought patterns, these kinds of decisions, these kind of questions will also apply to Lambda. How much memory do you need? What is the execution timeout, right? So these questions you should always be constantly asking yourself. Make sure you monitor all the resources so that you can have the most cost-optimized infrastructure for yourself and for the organization. Because at the end of the day, the goal, of course, is to reduce costs and increase the output. Now let's take a moment to understand costs of Amazon S3. When you have an infrastructure that's leveraging S3, for example, and this is true for any component, let's say, within the AWS infrastructure, you need to take the time to understand, be aware of, rather, not just the dollar amount that you're actually going to pay, but things that you pay for, and those things that actually contribute to costs. So with Amazon S3, for example, first, you need to understand that for the different types of requests, right, you're charged per 1,000 requests. So when you're making millions and millions of requests to S3, that will of course contribute to your final bill, right? So GET requests will have one fee, put, copy, post, and list request will have yet another fee, right? Either way, they all contribute to the overall cost of S3. So that's an important thing to consider. The cost of S3 is not just, the storage per month, it's also related to the number of requests that are made to the bucket. So in that respect, one of the things you can do to your code, and this is where the DevOps culture comes into play, and if you are part of the DevOps culture, you would know, right, that developers writing code against S3 to help understand how these decisions of code will affect your bill. So an example would be, let's say, in your code, instead of checking for the presence for the bucket before reading or writing, you simply handle any exceptions that might be returned, right? So if you think about that for a second, if every time you read or write to a bucket, you first have to check to see whether the bucket exists, that's a request, right? So by removing that request, you can cut the number of total requests in half. So that was just a good tip, right? So that's going to reduce the bill of S3. So keep in mind, as far as storage is concerned, the data that you don't really need to access, data that you need to keep, but you never really look at, you can use lifecycle bucket policy, right? Those roles, and transition data to AWS Glacier to reduce cost very significantly by transitioning that on to long-term storage. Another thing that you want to keep in mind, in terms of bandwidth, inbound bandwidth is free. So if you go back, let's say, to our previous lessons or lectures, you recall that end users are uploading directly to S3. That inbound bandwidth would be free, right? Outbound bandwidth, on the other hand, right, is a different story. So bandwidth between S3 and EC2 in the same region is free, but bandwidth from S3 to the internet or to another region will have a certain fee per gigabyte of bandwidth. So keep those things in mind. So it's important for you to keep in mind that all of the things that contribute to the cost of a particular service. So for example, we're talking about S3, right? So the idea applies to every service. Some services like S3, for example, the costs are more than just the storage, or more than what you actually might seem like on the face of it, right? So in terms of cost optimization, you really need to take the time to be aware as a solutions architect, right? Designing your infrastructure, and then analyze how the decisions are actually going to be made during implementation of that service or that architecture. So I hope this helps. Practice with this. These are very important considerations, and of course, good tip for the exams as well. With this, let's move to the next lesson. Let's now take a look at the costs of AWS VPCs, right? So when you actually deploy in any architecture, for example, that leverage Amazon VPCs, right? A number of things that you need to consider. So for most managed devices, such as the Elastic Load Balancer, NAT Gateway, for example, VPN connections, right? Direct Connect, those will have both an hourly charge and bandwidth charge. So keep that in mind. The costs are not just simply the hourly fees, but also based on the bandwidth that you're actually using or that passes through. So other things that you want to consider also would be network address translation. When you run it on a NAT gateway, for example, or do you want to run it on an EC2 instance? So you need to consider as a solutions architect that NAT gateway is capable of 45 gigabits per second and is fully managed. It's already inherently fault tolerant, horizontally scalable, right? Redundant, and all of those good things. So yes, EC2, for example, or EC2 instances can provide network address translation, but you need to consider that if you were to try and match the capabilities, right, of the NAT gateway by doing it yourself on EC2, you should keep in mind that the next closest instance is the M4, maybe 16 large, right, if I recall, which is, that you can use. And depending on the region that you're in, and that machine could be, 70 times more expensive. So because that only provides you 25 gigabits worth of bandwidth, right? So you need to be worried about what actually you're going to be using and how you want to architect that framework, right? So the NAT gateway, for example, will be cheaper and outperform an EC2 instance. So you need to kind of, again, be careful of what you want to use. So with that in mind, the fully managed NAT gateway would probably be the cheaper option, for performing network address translations. Other areas that you want to consider would be the fact that for many architectures, right, you may very well leverage cross, availability zone traffic. You may have instances in different availability zones, right, for the sake of high availability or fault-tolerant purposes, for the sake of being resilient, for the loss of data center. But you need to remember that traffic, right, crossing the availability zones does incur costs, and I've talked about that earlier. And the cost is per gigabyte worth of bandwidth. The same is true for VPC peering. So any traffic cost, going from one to the other will also incur a charge. Now, a VPC peering connection, keep in mind that even if, right, two instances that are communicating with each other are in different VPCs, even if they're in the same availability zones, the fact that they're communicating cross VPC peering connection, right, it would still incur that cost. When leveraging Amazon VPCs, and like we talked about S3, for example, right, for any service that you actually use within AWS, you need to take the time to be aware of the fine details of that service and how that affects your costs. And I've heard from first-hand accounts, right, numerous consultants and my colleagues, enterprises that I've worked with, right, on how these kinds of things, they've come back to surprise the organization with much larger costs, right, or bills than actually expected. So a good solution architect is, being very careful on what actually is being used. And eventually you want to save money. So even you get a new job, right, somewhere, the first thing you want to do is take a look at the cost, because if you reduce costs for the organization, you'll be the hero for that company, right? So all of these things contribute to the overall cost, like we talked about earlier, right? So you want to be really, really careful. And this is a great tip that I'm providing you, whether you're working for your organization, go ahead, evaluate all of these things, right? Or if you want to go take another job, first thing you want to do is lower the costs. And that's going to, take you a long ways within the organization. Another way you can reduce costs is by using temporary, let's say resources, right? So for any given infrastructure, for example, or for any environment, why do you want to pay for an environment that is not being used? So instead, you can turn out lights, right? You can clean up after yourselves. So you can build an environment and architecture, for that purpose only. And once that project is done, just remove everything, right? So that's another strategy that you can use to reduce costs. So when you think about certain environments, such as development environments may not actually be used at nights, on weekends, on holidays, right? You may have testing environments that are only used for maybe a short period of times, maybe weekly, maybe quarterly or whatever. And then they're not needed afterwards, right? So you can leverage things like Cloud Formation, right? That's a good tool to use. You can build a Cloud Formation template, and using code commit and CloudWatch event rules, a time-based rule that triggers code commit at a regular interval, say every morning, from 9 a.m. to 11 a.m., right? Whatever the case may be. So on that schedule, the CloudWatch events rule can fire, triggering code pipeline to automatically pull that template from code commit, pass it to Cloud Formation, allowing Cloud Formation to automatically build that environment, right? All of these components necessary for that environment. And then, of course, you only pay for that particular usage for the time that they exist, right? You perform your work, you're done with your project, and you no longer lead it. It's simply, you can go to Cloud Formation and delete that stack itself, thereby deleting all the resources and going to save you a lot of money. So keep that strategy in mind. This is a very effective strategy, and I've not seen, in my experience, being implemented. But if you were a solutions architect, you want to keep that in mind, because you may have certain projects that really would require this particular process. Okay, so this is a powerful pattern in controlling costs within the AWS account itself. So finally, let's take a look at billing alarms, right? So we talked several things about costs, but of course, billing alarms are equally important. They're one of the most crucial things you can actually use to ensure not only a cost-effective environment, but also a secure environment at the same time. So billing alarms can help you be aware of rising costs for any number of reasons. Could be the cost rising because of the runaway script, for example, right? Or someone made a poor decision. It was not you. Someone, maybe your account credentials were compromised. Maybe there's spikes and so on, right? So there could be several reasons that are beyond your control. So billing alarms will really help you identify those, right? So you may have, several load balancers, you have RDS, you have EC2 instances, you have multiple AZ deployments, right? You have 2 instances, for example. You have CloudFront distributions, multiple S3 buckets, right, that are storing different content. You have DynamoDB tables, right? Redshift clusters. You may have Amazon EMR clusters, for example. You might be using Athena. You might be using Glacier, Lambda functions, API gateways, and you name it. So all of these, this list goes on. In any given infrastructure, you can have a lot of different resources and moving parts that are all contributing to costs. So you might also, end up duplicating all of these, right, into another region. So you're doubling your costs. So anything that you add to your infrastructure, right, will increase your costs eventually. Okay? So billing alerts will give you the ability to really, manage all of these different resources that are spread across multiple availability zones, right? And that would allow you to maybe get email notification, right? Or, a message just letting you know the threshold that you've set those alerts to. And I've also talked about in the previous lectures as well. This is how you would actually notify yourself, right? So you would automatically know, if something changes beyond what you've specified. So you can monitor, let's say, S3 charges with Amazon CloudWatch, right? It connects billing metrics several times every single day. So that's another example, and the election of those billing metrics, it actually happens in the US East Northern Virginia region. So as a result, billing alarms would have to be created in that particular region. Think about this, right? The alarm triggers, for example, when the actual billing exceeds the threshold that you've actually specified or set. AWS does not use, for the sake of billing alarms, it's not going to use any kind of forecasting or prediction, right, for you for that billing alarm. It's actual value. So when your billing alarm actually triggers, that you've already spent that amount of money. So what I typically suggest or recommend is that use the monitoring when you're brand new to AWS, right? And you don't know what the spend amount would be. Use the monitoring to measure what your actually spend limit is over some period of time. So you'll have an idea over, let's say, 6 months, 3 months, or 1 year, a typical behavior of what you're actually spending, and then set a billing alarm accordingly. So let's say, for example, your typical monthly spend is somewhere around maybe $10,000, right? So you would set a billing alarm for, let's say, $10,500 or maybe $11,000 per month. So if the alarm didn't go off at all, then everything is perfect, or everything is working correctly. The alarm goes off in the last week of that month, close to the end of the billing cycle, and everything is still probably fine, you might want to look to see, let's say, investigate costs and see if anything was, being different. If the alarm goes off halfway through the month, right, maybe on the 15th or before, or closer to the beginning of the billing cycle, right, then something is going on. So that would definitely indicate that you really need to look around and take a look at or change to the environment, right? Or maybe change the architecture, and just again depends. So that way you can set these billing alarms and kind of gauge the costs accordingly. So I hope this helps. I've covered in depth. I hope you get a solid understanding of billing alarms and other areas where you can actually truly optimize your costs. With this, let's move to the next lesson.
Welcome back. Super excited. Moving forward, I'm going to talk about the newer aspect of EC2. Notice there's a dashboard where you can now visualize, take a look at all of your resources and options that you have available within the EC2 dashboard. You can always go back to the old dashboard, but the new experience adds new resources and options. So in this lesson, I'm going to talk about the placement groups in EC2. So when you launch a new EC2, for example, the EC2 service simply attempts to place the instance in such a manner that all of your instances are spread across underlying hardware. And the purpose of this is to provide fault tolerance, to minimize failures, in other words. We can use these placement groups to influence the placement of group of interdependent instances. Okay, what that means is in order to simply think of this as meeting the needs of your workload. So depending on your workload type, you can then create a placement group, one of these strategies. So the first strategy is cluster, the second strategy is partition, and the third strategy is spread. So what do we mean by cluster? Pretty straightforward. All it does is simply takes all of the instances close together inside a single availability zone. So what this allows you to do is simply enables your workloads to achieve low latency network performance for tightly coupled node-to-node communication. And that's typical of the HPC applications. The second strategy is partition. And what this strategy would do for you regarding your EC2 instances is spread your instances across logical partitions, such as groups of instances in one partition that do not share any resources. So all of the resources stay within that group of those instances in different partitions, right? So each partition has instances and they remain independent. So this strategy is typically used by large distributed workloads, maybe if you're working with Hadoop, Cassandra, or Kafka. And finally, the third strategy is that it strictly places small groups of instances across distinct underlying hardware. And of course, this is high fault tolerant. Good news is that there's no charge for creating a placement group. So before I do the demo, I'm going to of course provide the demo after we go through 5 or 6 slides, just so that you understand the concept, and I'm going to demonstrate how to create these placement groups. Next, let's take a look at the cluster placement groups. The cluster placement group is simply, once again, a logical grouping of your EC2 instances within a single availability zone. And this can basically, you can span tiered VPCs within the same region, right? And the real benefit of the cluster placement group is that in addition to the 10 gigabyte flow limit, the real benefit is the non-blocking, non-oversubscribe, and fully bisectional nature of connectivity. What do these all mean, right? So think of this as that all nodes within the placement group can talk to all other nodes within the same placement group at a full line rate of 10 gigabit and 100 gigs aggregate without any slowing down due to over subscription. So think of this as, in layman terms, is that you have multiple EC2 instances within the same availability zones, and each instance is connected, fully connected, and sharing all of the information. Okay, so that's really the cluster placement groups. Now, when do we use cluster placement groups? They're recommended for applications that benefit from low network latency, high network throughput, or both. And if the majority of the network traffic is between the instances in the group, that's when you really use the cluster placement group. So it is also recommended that you launch a number of instances that you need in the placement group in a single launch request. Because since you'll be using those together anyways, right? So it makes sense to launch multiple instances within a one placement group. And that you use the same instance type for all instances. If you're using, let's say, Linux AMI type instance, then you want to spin up 3 AMI based instances, right, within the same placement group. Next, let's take a look at partition placement groups. That's one of the strategies that you can also use. They simply help reduce the likelihood of correlated hardware failure for your application. So once again, when using these partition placement groups, the EC2 simply divides each group into logical segments called partitions. This is similar to your disk partitions, right? You have a C drive, you have a D drive, and you have an E drive, F drive, right? So think of those in layman terms as just going to take these EC2 instances and place them into logical partitions. And what this does, that EC2 ensures that each partition within the placement group has its own set of racks. Each rack has its own network and power source, so they're independent, right? So no two partitions within the same group share the same rack. The real benefit here is that it isolates the impact of hardware failure within your application. So in this particular example that you see, the image below is a simple representation of a partition placement group in a single availability zone. What it does, it shows you the instances that are placed into partitions. Placement group with 3 partitions, 1, 2, and 3. Now each partition comprises of multiple instances, and they do not share racks. Now, the groups, the partition placement groups, can be used to deploy large distributed and replicated workloads. Maybe if you want to use Cassandra or HDFS across distinct racks. So basically what happens is when you launch instances into a partition placement group, EC2 simply tries to distribute the instances evenly across the number of partitions that you specify. And we can also launch instances into a specific partition to have more control over where the instances are actually placed. The partition placement group can also, by the way, have partitions in multiple availability zones in the same region. So they're not limited to just a single AZ, but you can have multiple AZs. This type of group can basically have a maximum of, let's say, 7 partitions per availability zone. And they also offer visibility into partitions. You can see which instances are in which partitions. You can share this information with the topology-aware applications, for example, Cassandra, HDFS, like I mentioned earlier. And these applications use this information to make intelligent data replication decisions for increasing data availability and durability. So you ought to know the benefits and when should you use basically the partition placement groups. Next, let's take a look at finally the spread placement group, which is simply a group of instances that are each placed on distinct racks, with each rack having its own network and power source. Very similar to what we talked earlier, right? So here you can see in this image that you can have 7 instances in a single availability zone that are placed into a spread placement group. Now you might be thinking, why should I use a spread placement groups? And these are simply recommended for applications that have a small number of critical instances kept separate from each other. So launching these type of instances, for example, within a spread placement group will reduce the risk of simultaneous failures that might occur when instances share the same rack. And they also provide access to distinct racks, therefore suitable for mixing instance types or launching instances over time. And they can, of course, also span multiple availability zones within the same region. You can have maximum of 7 running instances per availability zone group. Next, let's take a look at some of the general rules and limitations. Now, there are several rules and limitations specifically related to the placement groups, but here I'm just going to highlight some of the important limitations. So before we actually use the groups, you need to know certain rules and limitations of utilizing or implementing these groups. First, the name you specify for a placement group must be unique within your AWS account for the region. So let's say if you have multiple accounts, and typical companies, enterprise companies have multiple AWS accounts, right? So you ought to kind of remember that placement group must be unique within your AWS account for the region. Second, you cannot merge placement groups. They're independent of each other. So if you're using a cluster strategy versus a spread strategy, they are independent. Third, an instance can be launched in one placement group at a time. It cannot span multiple placement groups. Pretty straightforward. Fourth, the on-demand capacity reservation and reserved instances provide a capacity reservation for EC2 instances within a specific availability zone. So what this means is basically the capacity reservation can be used by EC2 instances within a placement group. It's not possible to explicitly reserve capacity for a placement group. And finally, we have the instances with a tenancy of host cannot be launched within a placement group. So these are some of the general rules and limitations that are important for you to know regarding the placement groups within EC2. Next, let's take a look at a demo. Promised, I'm going to demonstrate how to create these placement groups and how to place those EC2 instances, your placement groups, and whichever strategy that you use within your own project. So now that I'm on my dashboard, notice this is the management console. I'm going to navigate to first EC2, and this will bring up the EC2 dashboard. On the top left, you'll notice the new EC2 experience. So if you would like to revert back to the old EC2 dashboard, you can simply switch from here. If not, of course, you will have the new EC2 experience. Now, within this particular dashboard, if you scroll down from the left navigation, you will notice within network and security section, placement groups. So if you click on it, you will see no placement groups because we have not created any, right? So I'm going to go ahead and create placement group. Click on this, give it a name, straightforward. I'm going to call it ClayDesk placement group or ClayDesk-PG. And then here's the strategy. So I can select either a cluster strategy, spread strategy, or a partition-based strategy. So let's go ahead and cluster first. Now you could always use the AWS Command Line Interface command. As soon as I click on the arrow here, you'll notice it'll provide you the command itself. In other words, if you were to run this command, it's going to go ahead and create the cluster, which is simply AWS EC2 create placement group, provide the group name, which is ClayDesk PG, strategy is cluster, and the region is US East 1. All right, so I'm going to go ahead and simply create our first placement group, click create, and this is going to go ahead and simply create the group for you. Now I could also go back to this button, create placement group, and create another group. So let's go ahead and do that. Go ahead and click on this. I'm going to call this my PG, right? And then here I'm going to choose spread, click create. And similarly, I'm going to go ahead and quickly create a third placement group, PG here. And then of course, in this instance, I'm going to use the partition based. Now, as soon as I choose partition, it asks me the number of partitions that I want to use. So if I want to use 1, 2, or 3, or 2, or 3, or 4, whatever, I could. Now, remember, you can have up to 7 if I don't. Yeah, perfect. So you can have within this placement group maximum number of 7 partitions, right? So I'm going to choose 3 as partitions and click create. So now that you have 3 different placement groups, our next task would be to create EC2 instances and place them within any of these placement groups. So let's go ahead, scroll up to our instances, click on instances. So currently I have 2 stopped instances. I'm going to go ahead and launch an instance just so that I can demonstrate how you can place this particular instance within a respective placement strategy. So here I'm going to choose, I guess, any one of these, but I'm going to, just for demonstration purposes, select the first Linux AMI. I'm going to choose the T2 micro, which is by default, right? Free tier available. So click on next, configure instance details. Now this is where you will see an option called placement group, which of course, if you're using the old version of EC2 instance, this is something new, right? And of course, good for the exam as well. So within this option here, I can simply click on this checkbox, add instances to placement group, and then I can simply choose the placement group. So notice in the drop-down arrow, I have 2 displayed strategies. One is spread, the other is partition. Wait a minute, what about the cluster strategy? We also created a third group called the cluster placement group, but that does not show here. And here's the reason why, and this is a good exam question too. You cannot create or you cannot add an EC2 instance to a cluster placement group if you're using a T2 micro. So remember, we selected the T2 micro, right? So you cannot add a T2 micro instance within a cluster. That's why, AWS doesn't show you the option here. If I were to go back, for example, let's go back here, previous. Instead of T2 micro, I'm going to choose, let's say, scroll down. Just pick one of these. So let's go ahead and do, let's say, M5 large, right? Just for demo. Click next. So it just gives you the option here. You've selected a different instance type and gives you the option. Yes, I'd like to continue with this instance type, M5.24x large. Click next. And now if I try to click on the drop down arrow, perfect. You will see that you have the option of using a cluster. Okay. So this way you can, of course, navigate and click on the next, which is add storage, which is straightforward. Add tags, configure security groups in the next option, right? If you have a default security group or an existing security group, you can do so. Again, rest of the options are pretty straightforward. So if I were to click on review and launch, it's going to go ahead and launch this particular EC2 instance within my cluster placement strategy group. Okay, so I'm not going to go ahead and review and launch, but just for demo purposes, you fully understand the EC2 placement group strategies. So based on your own project, your infrastructure, your AWS architecture, for example, or your applications, you can choose the right placement strategy for your EC2 instances. So I hope this helped. Practice with this. If you have any questions, post in the discussion area. I'll be glad to help with this. Let's move to the next lesson.
Hi everybody, and welcome to this lesson on looking at how we can build AWS architectures, and this one is focused on how we can build an architecture that's going to be used to host a web application. So building a highly available and scalable web hosting can be a very complex and expensive operation. Sometimes you have dense peak periods and wild swings in traffic patterns, which can result in low utilization of expensive hardware. Now, AWS provides the reliable, scalable, secure, and high-performance infrastructure required for web applications, while also enabling an elastic, scale-out, and scale-down infrastructure to match IT costs in real time as customer traffic fluctuates throughout the day, throughout the week, or throughout the month. Now here is a basic diagram of how we can develop an architecture of a AWS infrastructure which can host a reliable and scalable web application for us. So let me walk you through this step by step. Now first and foremost, we're going to obviously need a DNS service, which is what AWS does for us through Route 53. So the user's DNS requests, again, will be served by Route 53, which is a highly available domain name system specifically developed by AWS. Network traffic is going to be routed to the infrastructure running in Amazon Web Services. Next, we have something called CloudFront. Now, all of the static, streaming, and dynamic content will be delivered by the Amazon CloudFront infrastructure, which is a global network of edge locations. So requests are going to be automatically routed to the nearest edge location, so content is delivered with the best possible performance. So regardless of where you are in the globe, you will get the content cached locally in the edge location, of which AWS has around 160 locations throughout the globe. So next, the resources and static content used by the web application are going to be stored in a S3 bucket, which, if you guys remember, is a highly durable storage infrastructure designed for mission critical and primary data storage. Now this will be our best option as compared to EBS or EFS, which will not really work for a web application which will be used through CloudFront, because with CloudFront we can designate an S3 bucket as its primary source. So in the fourth step, the HTTP requests are first handled by the elastic load balancing, which automatically distributes the incoming application traffic among the host of EC2 instances that are going to be running in your infrastructure. Now, as you guys can see, the EC2 instances are developed and hosted in a multiple availability zone infrastructure. Now, what this is going to do is it's going to enable a greater fault tolerance. So if one of the AZs fails or is down, the other one can pick up the traffic while the first one is brought up to speed by AWS. So it's basically going to provide a seamless load balancing capacity needed in response to incoming application traffic. So next, in the fifth step, we have web servers, again, in both of the availability zones hosted on EC2 instances. Now, with EC2 instances, what's recommended is the organization developed AMIs, or Amazon Machine Images. So for example, since they are in an auto-scaling group, if one of the web servers or EC2 instances should fail, the auto-scaling group is going to automatically provision a new one. So it's highly recommended that we have AMIs for the web servers with the required applications, patches, and software already preloaded in the AMI. So when the auto-scaling group provisions a new EC2 instance, it can just grab that AMI, pop it in the EC2 instance, and it'll be good to go. And then in the last step, we have the core of the application service, which is the database service. To provide the high availability, the RDS, or the relational database service, is going to be used in a multi-AZ deployment, where you have a primary master RDS and then you have a standby RDS in a different availability zone. So as you guys can see, this architecture provides an overall infrastructure for you to operate a web application in a highly available and reliable environment. You have the CloudFront, which provides the quick access for the people that are accessing it globally. You have the auto-scaling group, which distributes the load to multiple EC2 instances. So if you have peak traffic, it'll be balanced accordingly. And then you have the elastic load balancing also for the application servers. We need the ELB for both the web servers, for the traffic, and the application server, so the application can actually handle the load also. And then most importantly, this is all deployed in a multi-AZ environment, so you have the fault tolerance. If one AZ should fail for some reason, the other one can pick up the load while the first one is brought up to speed by AWS. So this is the basic setup if you want to host a web application on AWS. And just as a reminder, the services and the architecture that's required is the Amazon Route 53, the Amazon CloudFront, the S3 buckets, the load balancing, the EC2 instances, the auto-scaling groups, and then the RDS for the database for the application server. Hi everybody, and welcome to this lesson in looking at the architecture for building a service and content media infrastructure. Now, most of us would assume that serving digital content is probably one of the most basic and straightforward tasks. Now, that gets complicated when you have serious requirements for low latency or high availability, durability, access control, and if you have millions of views, and obviously the most important one, it has to be under budget. Now, in addition, because of spiky usage patterns, operations teams often need to provision static hardware, network, and management resources to support the maximum expected need, which guarantees waste outside of peak hours. Now, the good thing about AWS is that it provides a suite of services specifically tailored to deliver a high-performance media serving environment. So let's look at how we can develop an architecture in AWS to overcome some of these shortcomings that we would have if we were to do it on-prem. So the first step in anything that's going to be available over the net is utilizing the Amazon Route 53 DNS service, which is going to be used to direct the user traffic into the AWS ecosystem. Now the first step will be the storage. And you guys can see that for this type of infrastructure, the best storage will be the Amazon S3 to host the static content on the web. The reason for that is because the S3 is inherently highly available and durable, and is by default designed for scaling out on the web. It also will provide a great way to offload the work of serving static content on your web servers. And most importantly, you can also provide the secure access to your content servers over HTTPS. Now, obviously, if we have global users, we'll want them to access the content in low latency. And for that, in the second step, we're going to utilize the CloudFront service of Amazon, which is going to utilize the edge locations that Amazon has around the globe, of which are 160 and counting to this day. Now, by using the S3 as the origin server for the CloudFront distribution, you gain the advantage of having a fast in-network data transfer rates, simple publishing and caching workflow, and obviously a unified security framework. Now, the S3 and CloudFront can be configured by a web service through the AWS Management Console or If, for example, you prefer, it can also be done through a third-party management tools, because some organizations, they have their own customized tools for their web applications. So the good thing about AWS is you can also utilize your own management tools if you want. Now, alternatively, as you guys can see in step 3, you can also utilize the EC2 instances as the origin server of the S3 for hosting the static content. Now, if, for example, you want to have a greater degree of control for logging and feature richness in serving the content, then you'd want to utilize the EC2 instances. Otherwise, if it's purely a static content, you can get by with S3 buckets. So it depends on the type of content and the type of information that you require. So if you require that additional control and the logging, then you would need the EC2 instances. But just keep in mind that if you do provision the EC2 instances, then that will also raise your costs. And then the fourth step is live streaming. Now, featuring the power of Adobe Flash Media Server hosted on EC2, combined with the CloudFront for stream distribution and caching, live streaming works really seamlessly on the AWS platform. Now, this configuration uses a web server to host a manifest.xml file, Amazon DevPay EC2 instances to host Flash Media Server with hourly license pricing, and then the CloudFront to serve the stream. So with this setup, you basically have an optimal infrastructure to not only host static content, but also provide live streaming. Now, if you specifically only have static content, then you can just get by with the S3 and the CloudFront. But if you have static content and you also want to provide live streaming, then you'd want to go ahead and do the EC2 instances for both the static content and also for the live streaming through the Adobe Flash server instance provided by AWS. So again, just as a recap, in terms of the resources required and available in AWS for you to develop a content and media serving environment, you obviously have those EC2 instances. You have that Route 53, which is the DNS server, and that's going to route the traffic to your environment. You have the CloudFront for the caching and the low latency, and then you have the S3 buckets for the durable and secure storage of your content. Hi everybody, and welcome to this lesson on looking at how we can use the Amazon AWS infrastructure to do batch processing work. So now there are lots of different batch-oriented applications in place today that can leverage this type of infrastructure. For example, claims processing or large-scale transformation, media transcoding, and multi-part data processing work. Now, batch processing on AWS allows for the on-demand provisioning of a multi-part job processing architecture that can be used for instantaneous or delayed deployment of a heterogeneous and scalable grid of worker nodes that can quickly crunch through large amounts of batch processing tasks. And the best part about it is they can do that in parallel. Now, lots of batch processing architecture are often synonymous with highly variable usage patterns that have significant usage peaks. For example, in finance, you usually have month-end processing, which is followed by a significant period of underutilization. So the best part about AWS is it can help you overcome that variable. So let's look at how we can develop an architecture to overcome some of these issues. So here we have the basic architecture of how we can get a batch processing infrastructure set up in AWS. So the first obviously is that the users are going to interact with a job manager application, which is going to be deployed in an EC2 instance. Now this is the main component that's going to control the process of accepting, scheduling, starting, managing, and completing batch jobs. Additionally, it's also going to provide the final results after all the crunching is done. So after the user interacts with the first EC2 instance, what's going to happen is the raw job data is going to be uploaded into an S3 instance. So we have that big S3 bucket that's going to store all of the raw data for the job. Now what we're going to do is, instead of just making that entire large batch job flow through the infrastructure, which is going to cause bottlenecks, what we're going to do is break that up by using the simple queue service, or SQS. So individual job tasks are going to be inserted by the job manager in an SQS input queue on the user's behalf. Then what's going to happen is the worker nodes, or basically a host of EC2 instances which are deployed in an auto-scaling group, and that auto-scaling is going to accommodate for the peak and off-peak instances. And additionally, you can utilize the spot instances if that batch work is going to be done during off-peak hours. Let's say if it's big data processing and it can be done during off-peak hours, you can utilize spot EC2 instances to even save even more costs. So getting back, those EC2 instances are going to be in an auto-scaling group. And the group is basically a container that ensures health and scalability of the worker nodes. So worker nodes are going to pick up the job parts from the SQS queue automatically and perform single tasks that are part of the list of a batch processing steps. So after they've processed those tasks, the interim results from the worker nodes are stored back into the Amazon S3 bucket. Then in the sixth step, progress information and statistics are stored in an analytics store. And depending on what type of data you have, that can be either a Amazon SimpleDB or a DynamoDB domain, or a relational database. If you require the complex relationships, then you would use an RDS service. If it's a simple data, you can use the DynamoDB. And then lastly, you can also have a chaining process. So in the seventh step, you guys can see completed tasks can be inserted in an SQS queue for chaining to a second processing stage. So it all depends on what type of batch processing work you will be doing. It can additionally be changed on a second stage if required. So this infrastructure optimizes the flow of batch processing jobs by breaking up that huge batch job into smaller tasks, which are handled by SQS queues, and additionally the worker nodes in an auto-scaling group, which can accommodate for the usage peaks. So again, in summary, the services that are required to build a optimal batch processing architecture are the EC2 instances. Again, one would be the main one that the user will interact with, and then you have the worker nodes. Then you have the Amazon RDS or the DynamoDB, the simple database. You can have the Amazon S3 buckets. We're going to have the auto-scaling group for the worker nodes, and then finally the SQS queue to break up that large batch processing job into smaller tasks. Hi everybody, and welcome to this lesson on how we can build a fault-tolerant environment within AWS. Now, AWS provides services and infrastructure that are inherently fault-tolerant and highly available. But there are some aspects of the AWS environment that are not inherently fault tolerant, that need extra configuration in order for them to be fault tolerant and highly available. For example, EC2 instances within AWS provide infrastructure building blocks that by themselves may not be fault tolerant. For example, hard drives may fail, power supplies may fail, and racks may fail. So it's important to use combinations of features that AWS offers that we're going to look at in order for you to achieve fault tolerance and high availability. So before I get into describing the models that you guys see, most of the higher level services in AWS, such as the S3, the DynamoDB, the SQS, the load balancing, have been built with fault tolerance and high availability in mind. Now, services that provide the basic infrastructure, such as the EC2 or the physical hard drives, the EBS, provide specific features such as availability zones, elastic IP addresses, and snapshots that a fault-tolerant and highly available system must take advantage of and use correctly. So just moving a system into the cloud does not inherently make it fault-tolerant or highly available. So when we're moving our on-prem system onto the cloud or thinking about moving it onto the cloud, we have to develop an architecture to make use of the services that enable us to make these services into being fault tolerant and highly available. So looking at the diagram on the left, load balancing is an effective way to increase the availability of a system. For example, instances that fail can be replaced seamlessly behind the load balancer while other instances continue to operate. Load balancing can be used to balance across instances in multiple availability zones of a region. As you guys can see, there are two availability zones, A and B. And we have web and application servers in both zones, along with a database server, which is replicated in both zones. So what the elastic load balancing basically does, it directs the traffic to either zone A and zone B. And if, for example, one of the instances were to fail, it will automatically direct traffic to the other instance, whether in the same availability zone or in a different availability zone. So this not only caters for failures of specific EC2 instances or hard drives, but also if an entire availability zone is down, it can also cater to that by directing traffic to another availability zone. So it's important to run independent application stacks in more than one availability zone, either in the same region or in another region. So if that, again, like I mentioned, one zone fails, the application in the other zone can continue to run. And if you do not have those independent application stacks running in each availability zone, then that's not going to happen. So another way to accomplish that is by using elastic IPs, which we can see on the right side of the diagram. Now, elastic IPs are basically public IP addresses that can be programmatically mapped between instances within a region. So they're associated with an AWS account rather than with a specific instance. And those elastic IP addresses can be used to work around host or availability zone failures by quickly remapping the address to an other running instance or even a replacement instance that was just started by using an AMI. Now, reserve instances can help guarantee that such capacity is available in another zone. And lastly, another important thing to keep in mind is that valuable data should never be stored on the instance storage, because instance storage is linked to the EC2 instance. So if the EC2 instance is terminated, which sometimes can be very easily done, all of the data in that storage will be gone. So first of all, it's recommended that we use EBS, or the elastic block storage, which offers persistent off-instance storage volumes that are durable and persistent as compared to the on-instance. Additionally, those EBS volumes are automatically replicated within a single availability zone. So what happens if that availability zone fails? Well, you're going to lose those EBS volumes. So to increase the durability further, what we need to do is do snapshots. So do point-in-time snapshots, which can be created and stored on S3 buckets, which are then replicated to multiple availability zones or can even be stored in a different region. So this accommodates not only failures of the instance, but also failures of the availability zones and also failures of the physical EBS hard drives, because S3 buckets inherently are highly available and durable. So by taking snapshots or point-in-time snapshots of our EBS volumes, we can ensure that if those EBS volumes or those instances fail, or even if the availability zone goes down, we have those exact replicas available in S3 buckets in a different zone or even in a different region. So in closing, when we're moving our infrastructure from on-prem to on the cloud, we need to make sure that we take advantage of the services that are available in order to make our environment highly available and fault-tolerant, because by default, not all services are fault-tolerant and highly available. So some of the services that we do need to keep in mind and configure are Amazon EC2 instances, the EBS volumes, the elastic load balancing, and the Amazon S3. So we need to make sure that we get all of these services working together and coherently in order to have an environment that is fault tolerant and highly available. Hi everybody, and welcome to this lesson on looking at the architecture for building and hosting an advertising environment in AWS. So internet advertising services need to serve targeted advertising and must do so under a very limited time. And these are just a couple of the many technical challenges that most of these environments face. Now, good thing about AWS is that it provides an infrastructure for you to build a fault-tolerant, highly reliable, and available ad serving platform in the cloud. So let's see how we can architect that sort of environment. So let's say if a visitor loads a web page, what's going to happen is the ad servers are going to return a pointer to the ad resource to be displayed. Now these servers are running an EC2 instances, and what they're going to do is query a data set in an Amazon DynamoDB table to find the relevant ads depending on the user's profile. Now a DynamoDB table or a DynamoDB database would be a best suited for this sort of environment rather than using the RDS service, just because of the performance of the DynamoDB and the type of data which is required in terms of the log files. The DynamoDB would definitely provide a better performance in this sort of environment. So after that, all the ad files are going to be downloaded from the CloudFront, because the users in an advertising environment are scattered throughout the globe, and you want to make sure that they have low latency, and that's accomplished through the CloudFront. And what CloudFront's going to do is going to load the log information from S3 instances. So after CloudFront delivers that information, let's say the user clicks on the advertisement, what's going to happen after that is that we're going to run into the click-through servers, which are also going to be running Amazon EC2 instances dedicated to collecting click-through data. This information is contained in the log files of the click-through web servers, which are periodically uploaded onto the S3 buckets. So after that's done, all the ad impressions and click-through data are retrieved and processed by the Amazon Elastic MapReduce or EMR cluster using a hosted Hadoop framework to process the data in a parallel job flow. So the cluster's capacity can be dynamically extended using spot instances to reduce the processing time and the cost of running the job flow. So rather than have on-demand or reserved instances, we can utilize the spot instances to process this type of information and save huge amount of costs in those EC2 instances. And then lastly, the data processing results are going to be pushed back onto the Amazon DynamoDB, which again is a NoSQL database. And the DB tables can be stored And the DB tables can store and retrieve any amount of data and serve any level of request, both of which are specific requirements for storing and quickly retrieving the visitor's profile information. The high availability and fast performance of the DB enable ad server front ends to serve requests with predictable response times, even with high traffic volumes or if the profile datasets are large. So this is a optimal environment if you want to do and host log files and build an advertising environment in the AWS infrastructure. So again, just to recap the services that we're going to be utilizing in order to build this infrastructure, we have those EC2 instances serving both as click-through servers and ad servers. And just to save on costs, we can do spot instances for the click-through servers. We have the auto scaling, again, for the high availability and fault tolerance. We have the elastic load balancing. We have the Amazon CloudFront for the low latency. We have the EMR to do all of that bulk processing. We have the S3 buckets to store all of the static repository files for both the click-through servers and the ad servers. And then we have the DynamoDB as our main database to store and process the information. Hi everybody, and welcome to this lesson on looking at how we can architect a WordPress hosting infrastructure in AWS. Now, WordPress is probably one of the world's most popular web publishing platforms, and statistics say that almost 27% of all websites that are online are using WordPress. From personal blogs to some of the biggest news sites out there are on WordPress platform. Now, since WordPress is used so widely, there is a AWS architecture that we can develop to start hosting the WordPress on AWS. So let's look at how we can go ahead and develop the architecture in AWS. Now, don't worry, this might look pretty overwhelming, but let me walk you through this step by step. So let's start from the left-hand side where we see the users coming into an Amazon Route 53, which is AWS's DNS service. Now the DNS service is going to route the traffic into our Amazon CloudFront, And the CloudFront is going to store the static and dynamic content. And the reason we're going to store it in CloudFront is so we can reduce the latency, because CloudFront utilizes edge locations, which Amazon has spread all across the globe. So this way, doesn't matter where your users are, their first point of contact will be the edge location where the CloudFront static and dynamic content is hosted, therefore reducing the latency by quite a bit. So after it hits the CloudFront, so let's say if the content is not cached locally at the edge location, the CloudFront is going to go ahead and submit the request into the network, and the first point of contact is going to be the Internet Gateway. And the gateway is basically going to allow communication between the instances in the VPC and the Internet. So after it hits the Internet Gateway, we're going to go ahead and take the traffic to a NAT gateway, Network Address Translation Gateway. In each subnet, there's going to be one NAT gateway. You guys see one up on top, and then there's one on the bottom. And that's going to enable the Amazon EC2 instances in the private subnets, both application and data, to access the internet. And it's always good practice to have a NAT gateway to segregate your internal and your external networks. And the reason you guys see there are two NAT gateways in two different availability zones is for the high availability. So if one availability zone was to go down, or for some reason go down for maintenance or for some other issues, the other availability zone will be able to pick up the traffic, so your users are not going to notice any downtime. After the NAT gateway, we're going to utilize the application load balancer, and that's going to distribute the web traffic across an auto-scaling group of Amazon EC2 instances in multiple availability zones like I just mentioned. And the load balancer is not only going to help us distribute the traffic of our users, it's also going to reduce the costs since we are using an auto-scaling group. As the traffic increases, our EC2 instances will also increase, but consequently, as the traffic decreases, so will our EC2 instances. So this way you don't have to have a whole bunch of reserved or on-demand EC2 instances always running. The auto-scaling group will automatically scale up and scale down based on the need and the demand. So from the application load balancer, we're going to go on to step number 5, which we're going to run the WordPress site using an EC2 instance. And with Amazon EC2 instances, we can install the latest versions of WordPress, Apache Web Server, PHP 7, and OP Cache, and build an Amazon machine image that will be used by the autoscaling group, launch configuration to launch new instances in the group. So for example, as the traffic increases, the autoscaling group is going to recognize that more EC2 instances are needed, and it will use that AMI or Amazon machine image to trigger new instances to be launched and set up. Now, if database access patterns are read heavy, we might want to consider using a WordPress plugin that takes advantage of cache layering like Amazon Elasticache, which you guys see memcached, in front of the database layer to cache frequently accessed data. And again, the whole point of this is to make sure that we reduce the latency so the end users don't notice any lag regardless of how many users are accessing the WordPress website. So by using the Elasticache or memcached in front of the database, we are greatly going to reduce the stress that is put on the database. Next comes the database. Now, it's highly recommended to simplify the database administration by running Amazon RDS or the Relational Database Service using either Aurora or MySQL. And Aurora, if you guys are not familiar, is Amazon's own database service, or you can use an industry standard MySQL database. There's also Microsoft SQL Server, and depending on the type of data, DynamoDB could also be used, but again, that is specific to what type of data is going to be stored in the database, whether it's relational or whether it's not. Will determine whether you use Aurora, MySQL, or DynamoDB. And then the Amazon EC2 instances access shared WordPress data in an Amazon EFS file system using mount targets in each availability zone in your VPC. So you guys see that as a last step, or step number 8. Because by using an Amazon EFS, which is by nature very simple and highly available and scalable, the WordPress instances have access to the shared unstructured WordPress data like PHP files, config themes, plugins, and etc. So this is a basic setup of how you would want to have your environment provisioned on AWS if you are going to be hosting a WordPress website. So just as a recap, the services that we would want to provision in hosting a WordPress website is first of all the CloudFront, which is to reduce latency, and then we'd want to get the VPC set up in a multi-AZ environment. You can have either one VPC like you see on the screen, or if you prefer, you can also have multiple virtual private cloud networks if you want to host them in separate regions. But for the sake of simplicity, we've kept it in one VPC but put them in 2 availability zones to make sure that our environment is highly available. Then we have the application load balancer and the auto scaling group. The load balancer is just going to distribute the load to the different EC2 instances, whereas the auto scaling group is going to scale up and scale down our environment based on the demand. Then we have obviously the EC2 instances, and optionally the Elasticache or Memcache, depending on if our data can be cached. And then we have our database instances. Here you guys see Aurora, but MySQL or even DynamoDB could also be substituted depending on the type of data and the type of actions that the database will be performing. And then finally, all of our files are going to be stored in an Amazon EFS, which is the optimal storage system for a WordPress hosting website as compared to an S3 bucket or an EBS volume. So if you are going to be setting up a WordPress website, this is the optimal architecture that you want to make sure is set up at a minimal level to make sure that your WordPress website is hosted in a highly available environment and also is reducing the latency for your end users. So regardless of where they are in the globe, they will get the best performance based on the CloudFront locations. Hi everybody, and welcome to this lesson on how we can architect for an optimal file synchronization architecture in AWS. Now, given the straightforward stateless client-server architecture in which web services are usually viewed as resources and can be identified by their URLs, dev teams are usually free to create the file sharing and syncing applications for their departments, for enterprises, or for consumers directly. So let's look at how AWS can help your dev team accomplish those tasks in a secure manner. So basically, the file synchronization service endpoint will consist of an elastic load balancer distributing incoming requests to a group of application servers which are going to be hosted on EC2 instances. Additionally, an auto-scaling group automatically adjusts the number of EC2 instances depending on the application needs. So this not only makes it highly available, it makes it redundant, and it makes it durable. On top of that, it's going to save you costs because the auto-scaling group will automatically increase and decrease the number of EC2 instances that will be required based on the need. Now let's say if a user wants to upload a file, what will need to happen is a client will need to request permission to the service and get a security token. Now this is what is going to make this a secure operation. After checking the user's identity, application servers get a temporary credential from the AWS STS or the Security Token Service. These credentials allow the users to upload the files. Next, users upload the files into the S3 buckets, which again is a highly durable and available storage infrastructure used for mission-critical and primary data storage. Now the S3 is going to make it very easy to store and retrieve any amount of data at any time. And the best part about it is that large files can be uploaded by the same client using multiple concurrent threads to maximize bandwidth usage. Now to increase the performance, the file metadata, version information, and unique identifiers are going to be stored by the application servers on an Amazon DynamoDB table. As the number of files to maintain in the application grows, the DynamoDB tables can store and retrieve any amount of data and serve any level of traffic. Now, file change notifications can be sent via email to users following the resource such as the Amazon Simple Email Service or SES, which is an extremely easy to use and cost-effective email solution. So if any changes to files occur, the SES is going to shoot over an email to the file owner to let him or her know that this file has changed. Now, other clients sharing the same file will query the service endpoint to check if newer versions are available. Now this query is going to compare the list of local file checksums with the checksum listed in the DynamoDB table. So instead of going to the application servers and bog them down, it's going to go directly to the DynamoDB table. If the query finds newer files, they can then be retrieved from the S3 bucket and sent to the client application. If it does not find any newer files, then it does not have to increase the network traffic and access S3. The DynamoDB table will let this client know that there is no newer file available. So this is how we can synchronize and optimize a file service in the Amazon AWS environment. This not only makes the entire infrastructure highly available, it also makes it durable, and it also decreases your costs by using the auto scaling and by using the DynamoDB table to decrease the traffic that's going to your application servers. So in conclusion, the services that we need or we would need to develop an architecture to have a file synchronization service in AWS, we're going to need those EC2 instances as our application servers. We'll need the auto scaling and the elastic load balancing in order to automatically scale up and down those application servers and then balance the incoming load through the ELB. We'll have the DynamoDB table for storing the metadata and accessing to see if there are newer versions available, and the S3 bucket as the main storage repository, the STS or the security token service to make sure that all the requests coming in are from authenticated users, and the SES, which is going to be used as our main notification service to send email to users letting them know that newer files are available or specific files have changed depending on how we want to have this set up. And then additionally, we can also have the Route 53, which is our DNS service. If these files are going to be accessed through the internet outside of the organization, this can also be accomplished by using a Route 53, which is Amazon's DNS service. Hi everybody, and welcome to this lesson on looking at how we can develop a framework if we want to do media sharing on our infrastructure. Now, media sharing is probably one of the hottest markets on the internet right now. Customers and consumers have a staggering appetite for placing photos and videos on social networking sites and for sharing their media in custom online photo albums. The growing popularity of media sharing means scaling problems for the site owners who face or are facing ever-increasing storage and bandwidth requirements and increased go-to-market pressure to deliver faster than the competition. Now, since most businesses today have limited manpower, budgets, and data center space, AWS offers a unique set of opportunities to compete and scale without having to invest in the hardware, staff, or the additional data center space. Utilizing AWS is not an all-or-nothing proposition. Depending on the project, different services can be used independently. So let's see how we can architect for such an infrastructure. So this infrastructure is basically broken up into two parts. We have an uploading part, and then we have a content delivery part. So let's take a look at how we can, or how users can upload data onto the AWS environment. Now, the sharing content first involves obviously uploading the media files to an online service. So what we're going to do is have an elastic load balancer distribute incoming traffic to upload servers, which is going to be a dynamic fleet of EC2 instances. And what's going to happen is the Amazon CloudWatch monitors these servers, and an auto-scaling group automatically manages them, automatically scaling them up or scaling them down based on the load. So after that, the original uploaded files are then going to be stored in an S3 bucket, which is a highly available and durable storage service offered by AWS. Now, to submit a new file to be processed or further processed after uploading, the upload web servers push a message to the SQS, which is the simple queue service. The queue is going to act as a communication pipeline between the file reception and the file processing components. Now, by breaking up the file reception and processing components, we are reducing the load on the EC2 instances, thereby increasing the performance. and the upload and processing speeds that the customers are going to encounter. Now, the processing pipeline is basically also a dedicated group of EC2 instances used to execute any kind of post-processing task on the uploaded media files. For example, video transcoding, image resizing, and many other things that users usually do to uploaded photos or uploaded media. Now, to automatically adjust the needed capacity, again, an auto-scaling group manages it. You can use additionally spot instances to dynamically extend the capacity of the group and to significantly reduce the file processing costs. So by having those additional spot instances, we can reduce our costs by doing the post-processing tasks during off-peak hours, so we can reduce the number of dedicated EC2 instances in that auto-scaling group. Now, once the processing or post-processing is complete, the S3 again is going to store the new output files. Now, as a choice, what we can do is the original files can be stored in a regular S3 bucket, while the process files can be used in an infrequent access or a reduced redundancy bucket to further decrease the costs. Now, media-related data after that can be put in a RDS, or an Amazon Relational Database Service, or a Amazon DynamoDB, depending on the type of information that is required and going to be stored for that media. Now, after that, a third fleet of EC2 instances is going to be dedicated to host the website front end of the media sharing service. So this is our second half of the infrastructure. Media files are distributed from the S3 to the end user via the CloudFront, which is a content delivery network to reduce latency by using edge locations. And then again, an elastic load balancer and autoscaling is used on the web servers to not only balance the load, but decrease the costs by increasing or decreasing the number of EC2 instances in the autoscaling group. So in this infrastructure, we're basically breaking up the upload and delivery into two separate streams, breaking up this infrastructure into three separate EC2 instance clusters. We are not only increasing performance, but we're essentially decreasing the costs by using that auto-scaling group. So if the demand is there, the EC2 instances will automatically scale up. If it's not there, they'll automatically scale down. So this keeps your costs in check, but also increases the customer satisfaction because they will have low latency and faster processing. Additionally, by using the CloudFront, they will have the low latency of accessing those files, either the original files or the processed files through the CloudFront content delivery network. So again, to sum it up, the services that are optimally required to have a media sharing network, we have those EC2 instances in the upload section, in the processing section, and then in the web server section. Optionally, we have those spot instances for processing the pipeline. If, for example, there's large amounts of media that needs post-processing tasks like transcoding, this can be done during off-peak hours by further decreasing costs through using spot instances. Then we have the auto-scaling and the load balancing in order to decrease the cost and increase the performance and make it highly available. We have the Amazon Route 53, which is the DNS service, through which the users can access the web servers and the upload servers. We have the CloudFront to decrease the latency of delivering the content back to the end users. The S3 buckets to store all the media files, both the original and the processed files. The RDS in terms of the data store, whether it's an RDS service in terms of a relational database or a DynamoDB. And then finally, the SQS to break up the uploading and to increase the performance of the processing by keeping all the jobs in an SQS queue and then delivering them to the EC2 instances when they can process them. Hi everybody, and welcome to this lesson on developing an architecture on AWS if you want to host games online. Now, if you're hosting games online, most of the times there's unexpected traffic patterns and highly demanding request rates. Now, the good thing about AWS is that you can have the ability and the flexibility to start small and power up your architecture in response to your players. So as they grow, your architecture can grow with them. So you can scale up or scale down your architecture to make sure you are only paying for the resources that are driving the best experience for your game. So you can use the managed services in AWS for popular caching and database technologies, and leverage architecture that captures the best practices of some of the largest games running on AWS today. So let's look at the architecture that some of those games are utilizing. So I know this looks quite overwhelming, but don't worry, let me walk you through this step by step. Now the first thing that we need to do is utilize Amazon Route 53. What that will do, it will make sure that our players or your players are always able to discover your service endpoints. You can use the built-in routing policies to route users based on latency or geography, because most of the times your players are going to be geographically diverse. So you want to make sure that they are logging into your endpoints from wherever they are in the globe. And the Route 53 enables you inherently to route their traffic based on where they are in the globe. Now, after we figure out where they're located, the second step is we can route users to our backend using the elastic load balancing, which again scales automatically for incoming traffic. Additionally, we can keep the player's data secure in transit via the HTTPS by leveraging the SSL termination capabilities of the ELB. Next comes our web servers, which again are going to be running on EC2 instances in an auto-scaling group that will span multiple availability zones. What that will do, it will not only accommodate for the growing and shrinking of your players, it will also do the fault tolerance. So if one of the availability zones goes down, the other one can pick up the slack. Now just a tip, AWS recommends using the M4 instance types with the enhanced networking and EBS optimize enabled. That will provide the best performance for gaming. So after the traffic hits the EC2 instances, the next step is if we separate the app tier from the web tier and leverage an internal ELB. Now this load balancer provides additional benefits of added security by residing in a private subnet and making sure that no external traffic overwhelms your app tier. Moving on down, we have the Amazon ElastiCache for Redis, which is going to provide a fully managed solution that enhances robustness and reduces the cost of installing, operating, and maintaining a highly available and scalable Redis cluster. Additionally, we can also leverage the multi-availability zone ElastiCache in the game to provide automated disaster recovery and a scalable tier with read replicas if required, depending on how large your game is going to be. Then we come towards the end and utilize the Amazon Aurora, a MySQL compatible database, which provides a high read and write throughput up to 64 terabytes 6-way replicated storage and up to 15 low latency read replicas in a multi-AZ environment. Now when compared to other instances in an RDS, this by far has the best performance. If you compare it to MySQL or the Microsoft SQL Server, this would provide the best performance. Now just another tip or an food for thought. Amazon did a survey and gaming customers have seen a 2 to 3 time reduction in cost after migrating to Amazon's Aurora database service from another database service. Additionally, the game can also benefit from the high-speed, low-latency managed NoSQL database, which is the Amazon DynamoDB, which provides predictable performance and scalability. So it depends on which one you want to utilize, either the Aurora or the DynamoDB. But just keep in mind, DynamoDB is a NoSQL database. So depending on what type of data will be stored will determine whether you use the Aurora or DynamoDB, but both have the best performance. Now for storage, the best option is going to be using the Simple Storage Service or S3 to store the game assets, the DLC and log files generated by the servers. Now, as a user base grows geographically, we can also utilize the Amazon CloudFront as a distributed cache for content, which is going to use the edge locations of which Amazon has around 170 throughout the globe. And lastly, we can use push notifications through the SNS or simple notification service with out-of-the-box support for Apple, Google, Amazon, and Windows platforms. So with this setup, we can provide the best performance for gaming experience for the users. What this will do, it will grow and shrink with the user base. So if you have maybe a few hundred users in the beginning, the auto scaling group will keep the EC2 instances to a minimum. As the user base grows, the auto scaling group will enhance the EC2 instances, and that will accommodate for the increased users without having an impact on the latency or the performance. Now, in conclusion, the services required to build the optimal gaming architecture in AWS is the Amazon Route 53 to route the traffic to the best geographic point. Then we have the load balancing to make sure that the performance is not impacted. Then we have the EC2 instances, which is going to act as our web servers and our app servers on different subnets to ensure that public traffic stays in the public subnet and does not go into the private subnet. Then we have the Amazon ElastiCache, which is to store the cached content. And then as our primary database, we can either utilize the Amazon Aurora or the DynamoDB, depending on the content. And the main storage, we have the Amazon S3 buckets. And then finally, as the users and the traffic grows, as the popularity of the game grows, you can utilize the Amazon CloudFront to reduce latency by utilizing the edge locations distributed throughout the globe. Hi everybody, and welcome to this lesson on looking at the AWS well-architected tool. So this is a tool that is basically going to help you review the state of your workloads and compare them to the latest AWS architectural best practices. It's developed by AWS to help cloud architects build a secure, high-performing, resilient, and efficient application infrastructure. So it's going to provide you with a consistent approach to evaluate architectures, and believe me, it's been used by tens of thousands of organizations across the globe and been given great reviews by all of them. The best part about it is a free tool available in the AWS Management Console, which we'll look at in a few minutes. And all we do is basically just define our workload, answer a set of questions, and it's going to pop out a results for us. So in the diagram that you guys see, what we're basically going to do is we're going to identify the workload to review. So we're going to answer a set of questions that AWS is going to pose to us. And the tool is going to review the answers against the 5 pillars established by the well-architected framework, which is the operational excellence, security, reliability, performance efficiency, and cost optimization. If you guys remember from the previous lesson, we briefly looked at all 5 of these. And then after that, what it's going to pop out, you'll get videos and documentation related to the AWS best practices. It's going to generate a report that summarizes the workload review, and then we can also review the results of the workload across the organization in a single dashboard. So when we are deciding to migrate to AWS and develop an architecture in AWS based on our business, it's always best practice to use this tool to first define our workload and what kind of changes we need to do. Because if you are migrating to the cloud, or if you are developing something new, a new architecture in AWS, you always want to make sure that you're using the latest technologies and you are following the best practices. So this is a free tool to help you do that. So let's log into our management console and see how we can get this tool to help us figure out if our architecture is following best practices. So here we are, we're in the dashboard of the AWS management console. I've already gone into the well-architected tool, and this is the diagram that we basically looked at. So I'm going to go ahead and click on define workload to start answering the few questions and see what kind of results we're going to get. And here we can select which industry our company falls under. There are a host of industries that we can select from. So what I'm going to do, I will just pick a sample one, let's say digital advertising. And then there's also an option to further dive into the specific industry. So if I've selected digital advertising, it's going to break that down for me. If I, for example, selected financial services, it will break down that one differently. So let's just stick with our digital advertising. Let's say that I am a publisher of ads. And here we can select where the workload is going to run for our organization. Now these are all of the AWS regions across the globe. So depending where our organization is located or where our offices are located, we can select that specific region. And if we have multiple regions, we can also select multiple regions, and it will pop out the workload for us there. So let's say if I have my main operations in the US, and then I also have a team operating in India, I'm going to select these two regions within the AWS framework, and the environment in which the workload is going to run, whether it's production or pre-production. I'm going to just select production. And if you have multiple AWS accounts, you can also have this span across those multiple accounts. I'm going to go ahead and define our workload. And here is where we can start answering those questions based on these 5 pillars, which we've already discussed previously. So what I'm going to go ahead and do is click on Start Our Review. And here it's going to ask us 9 questions about operational excellence. It's got 11 questions on security. It's got 9 questions on reliability. It's got 8 questions on performance efficiency. And then it also has 9 questions on cost optimization. So we would have to go through and answer each one of these depending on whether they relate to our business case or not. If, for example, we look at the first one in operational excellence, it's asking how do we determine our priorities, and then it has a set of answers for us. Additionally, we can also put notes. So if there's additional information we want AWS to know based on how we determine our priorities, we can also put them in the notes. Or we have multiple other options. If this question does not apply to us based on our type of business, we can say this question does not apply. Or if none of these are applicable to our business, there's also an option for all questions for none of these. Additionally, if you want to know what they mean by evaluate external customer needs, there's an option for info here. If we click on that, on the right hand side, it gives us details to all of these answers. So for example, evaluating the external customer needs, it lets us know that what AWS means by that. It means involve key stakeholders, including business development and operation teams, to determine where to focus operation efforts on external customer needs. This will ensure that you have a thorough understanding of operations support that is required to achieve business outcomes. So if you want further clarification on which answers are right, just click on the info and it will give you details of all of these answers on the right hand side. And this is the same for all of the 5 pillars. So if you click on security, again, like I mentioned, all of it is the same, and we can get additional answers here. Like for example, the first question in security is, how do you manage credentials and authentication? So here we can select, and again, most of them are multi-select, so there's not one or the other. We can select as many options as are applicable to us. So I'm going to go ahead and just quickly answer all of these questions, and then we can come back and see how AWS has evaluated my answers. All right, now that I have answered all of these questions that we saw previously, you guys can see that the status here down here has changed to all of them to be answered. So let's say if we want to go back and change any of the answers that we've specified in any of these 5 pillars, we can go ahead and continue our review. And it will take us back to all of these questions. We can choose which ones you want to change if, for example, you have a requirement to do so. So let's say that we're all finished with our answers. We've decided that we've fully explained our workload and what we're trying to do, and we want to generate the report. Since we can either generate the report to download a PDF of it, or we can click on the improvement plan, and it gives us a status of our current setup that we have and how we operate based on these 5 pillars. So you guys can see that it has identified 21 areas that are considered high risk by AWS based on their best practices, and it's identified 24 areas considered medium risk based on their own framework. So if we click on the high risk, it gives us the questions or the areas which they feel are a high risk when you're migrating to the cloud, or even if you're not migrating to the cloud in your own on-prem system, these areas should have improvements to increase the risk level of them based on the 5 pillars. So you guys can see that one of the questions that I answered was, how do you detect and investigate security events? So if we click on the down arrow, it lets us know recommended improvement items on how we can improve on how we detect and investigate our security events. And the same goes for all of the other questions. How do you protect your data at rest? Based on the answer that you provided, and again, those answers should be how you're actually operating your current environment. It gives us a recommended action plan to improve how we protect our data at rest, and that goes hand in hand for all of these 21 items is identified as high risk, and the same goes for medium risk. So if we click on any of these, it takes us to their documentation and explanation on how we can go ahead and improve on managing our credentials and authentication. So here we can get multiple information on how we can do multi-factor authentication or set up password policies and so on. Additionally, it also has an option for resource and partners. So for example, if you would like a consultancy to come in and help you, this will give you a list of available organizations that are AWS certified that can come in and do an overall overview of your system and help recommend how you go about improving all of these areas identified as high risk and medium risk. Additionally, they also have a improvement status where you can choose the status of your workload improvements, whether they've started, they're in progress, they're completed, or the risk is acknowledged, meaning you know that there is a risk associated with it that's been identified by AWS, but this is how you operate and you're not worried about it, so you can flag them as risk acknowledged. So this is a very good tool and a very good dashboard for you to not only see what areas you should improve on based on best practices, but give you a good project management platform where you can manage identifying and correcting these areas that are identified as medium and high risk, or just stating that yes, the risk is acknowledged, you know, but there's no way to mitigate it based on how you operate your organization. And here also you can define the pillar priority. So let's say that operational excellence for you takes priority over security or reliability. We can go ahead and change these priorities by clicking on the edit button here. So again, depending on what your business processes are, what your goals are, you can define which priority takes precedence over the other, and it will automatically change the high and medium risk and identifying based on this risk, because as you guys can see from the bottom, most of these high risk items are security related, such as security events, protecting your data, because we've specified security as a first priority pillar, which most of the time by default it should be your first priority pillar, but again, every organization operates differently. So if it's operational excellence or cost optimization, you can put that on top and it will identify the risks based on this priority. And just one final thought for the generating report, if you generate the PDF, it will basically pop out a PDF that can be shared within your organization that just gives an overall overview about all of the questions that you've answered. And it gives a good overview about the industry and the details you've selected based on this review. It gives the high and medium risk areas that is identified in terms of these 5 pillars. It's identified 4 areas that are high risk and 5 that are medium risk in operational excellence, and same goes for security, reliability, efficiency, and cost optimization. And then it goes on to provide the answers that you've provided for all of the questions for all 5 pillars. So it gives a question, it gives us choices that you've selected and the choices that you have not selected. So if you are sharing this report within your organization, they can see all of the options that are available and the option that you've selected. So if there is one that you have not selected that should be selected, they can flag it and identify it, and you are able to go back and edit your answers, and it will again give you a different improvement plan based on those edited answers. So this is a very good PDF, a very good tool to share within your organization to help you identify areas that can be improved when you are moving to AWS and areas which should be improved based on best practices, because if you are going into the cloud, if you are changing your infrastructure, if you are architecting a new architecture on the cloud, whether it's in AWS or in any other platform, it's always good practice to make sure that you identify what you're currently doing and to benchmark it against best practices. And this tool is very robust and helps you do that in a very easy and simple fashion.
Welcome back. Super excited. Before we actually dive into the course in depth, just a few things that I would like to highlight. First, very importantly, you would like to be able to set up your billing alerts, because AWS, of course, requires a credit card, right? And then it gets easy to get into the course and start to navigate between one service, from one service to another, and so forth. So you may lose track of your billing, right? So even though we are going to be using AWS free tier, I like to make sure that we set up the billing alerts right off the bat, so that if something happens, right, you get the billing alert. So this is just for our own protection, because we like to stick to the free tier account, at least for yourself. All right, great. So once you navigate or log in to your AWS Management Console, let's navigate to the billing. So I'm going to go ahead under services. Of course, you can find by typing billing, or already recently visited the billing console, it should display on the left navigation pane. So I'm going to go ahead and click on billing, and this will take us to the billing management console. I already have a few cents bill, right, because I spun up an instance. So not to worry, once you're here, you should see $0. So from within the billing and cost management dashboard, if you scroll down, you'll notice there's a section of alerts and notifications. And here you can take a look at and see that AWS allows you to create custom costs and usage budgets and alerts that alert you when you exceed or are forecasted to exceed the budget threshold. So we want to be able to set an alert so that if a threshold is crossed, which is 0 in our instance, right? If $0 is crossed at any given moment in time, you should receive an email. Great. So let's scroll up. From the left navigation pane, notice, click on Preferences. This will load up all the preferences for you. And what you want to do here is just make sure that you check this box called Receive Free Tier Usage Alerts. Enter your email address. Once you've entered the email address, make sure this is a verified email address. In other words, if you enter an email address that is not verified, AWS will prompt you to do the verification. Also, very importantly, make sure that this box is also checked, Receive Billing Alerts. So you need to be able to ensure that this feature is turned on in order to monitor your AWS usage charges and recurring fees automatically. And this makes it easier to track and manage what you're actually incurring costs or spending on AWS. We can also set up the billing alerts, and that's what I'm going to show you next. Okay, so make sure these two boxes are checked, turned on. Make sure you have an email address here. Click on Save Preferences. Once the preferences are saved, next let's navigate to the CloudWatch and create an alert, so that if a certain threshold is surpassed, we get an email. You could directly go from here. Let's click on Manage Billing Alerts, and this will navigate you to the CloudWatch Management Console. CloudWatch is yet another service I'm going to get in depth later on during the course, but right now we're just creating a simple billing alert. Once you're on this page, from the left navigation pane, notice there's a billing option. Let's click on Billing, and here you can set or create a billing alarm, which essentially helps us monitor the charges for our AWS bill. And we are going to receive an email. So I'm going to go ahead and click on Create Alarm, and this creates a new alarm for us. Let's scroll down for the billing alarm section. Here we can create a billing alarm to receive an email alert when the AWS charges exceed a certain threshold that we choose. So simply first enter a spending threshold. In our instance, I'm going to say 0, and then send a notification to, let's go ahead and click on New List. So once I've entered the correct email address, here's the important reminder, or for each address you add, you will receive an email from AWS with the subject AWS notification subscription confirmation. Click the link provided in the message to confirm that AWS may deliver alerts to that address. So all this is simply making sure that your email is being verified. So make sure you do that. If you have any questions, post in the discussion area. It's important that you set this before you begin this course. All right, so once you've set this, all you have to do is just click on create alarm, and this is going to go ahead and create alarm for you and confirm the email address. And in my instance, I have not confirmed, right? So if I were to navigate to my Google Gmail account, open this account, I will see the link. All I have to do is just click on that link, verify. That's all. And then I should be able to view the alarm and I'm all set. So go ahead, do that. If you have any questions, once again, post in the discussion area. I'll be glad to help. And with this, let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to demonstrate the use of AWS Command Line Interface tool. So with the AWS CLI, you can essentially run scripts using a command line. All you have to do is, let me jump right in and navigate to this tab where it says amazon.com/CLI. So you just need to navigate to this particular page, and here you'll notice that the Amazon Command Line Interface CLI is a unified tool that you can manage your AWS services with this tool. The CLI is a unified tool to manage all of your AWS services. So with this particular tool that you can download and configure, you're able to control multiple AWS services right from the command line and automate them through scripts. So I'm going to demonstrate here how to download, and then maybe you'll run some commands just so that you understand how powerful the command line interface can be. Although you could accomplish the same with using the GUI interface, but it's always helpful to understand and know the command lines as well. So from this page, all you have to do is just navigate to the right side of the screen. If you're running Windows, you can download the 64-bit or 32-bit version. If you're running Mac and Linux, you can use the pip install AWS CLI command to install. Please note that this requires Python 2.6.5 or higher version, and then you have to install the pip as well. So I'm going to go ahead and download and run the 64-bit Windows. So this will open up the Windows Explorer. It'll just save the MSF file. I'm going to go ahead and click save. And once the file is saved, it's about almost 20 megs file, so it's not going to take that long. Once the file is downloaded, we are going to go ahead and install. And while this is being downloaded, I'm just going to mention that the AWS CLI introduces a new set of simple file commands that we're going to take a look at, right, for efficient file transfers to and from Amazon S3 buckets. So we can get started and take a look at the CLI reference here. We can visit the GitHub project and also navigate to the community forum. And this is helpful, especially if you're running commands and you need some help in taking a look at some of the challenges that you would like to accomplish. If I scroll down, there's also AWS Shell, which is in developer preview at this point, which is a command line shell program that also provides convenience and several other features to help both new and advanced users of the AWS command line interface. So some of the additional capabilities of AWS Shell is fuzzy autocomplete on, dynamic inline documentation, execution of OS shell commands, and so forth. So this is also part of this. All right, and then of course you can scroll down and take a look at the usage and various commands that you can use with the AWS command line user guide. I will provide this as a downloadable resource, so you'll have a list of all these commands that you can reference as you're progressing through this course. Great. So once this is downloaded, I'm going to go ahead and run this. Simply click on this. This will open up a new window and we'll start the installation process. Let's go ahead and click on next, accept the license, click on next once again. And this is the location of this particular AWS CLI where this is going to be installed. Program files, Amazon. If you wish to change, you can. Let's go ahead and click next and then click on install. It just asks for the permission for the user account control. Click on yes. And this is going to go ahead and install the interface for you. Great. So let's go ahead and finish the setup for this. Great. So next, you would like to take a look at where the command line or the MSI installer actually installed all the files, because we use the Windows 64-bit MSI. So I'm going to navigate Windows Explorer just so that you can see. And here's the path, right? So program files, Amazon, and then AWS CLI. And within this CLI folder, you'll notice you have bin, resources, runtime, and so forth. So if I were to expand any one of these, for example, bin contains the AWS.cmd, and then the resources contain a bunch of images, and then runtime are all the Python files, okay? Because Python 3.6 is also installed, or the files are made available. Great. Let's minimize this. So once you have this, I'm going to go ahead and open up the command line, the Windows command line, so we can now execute the AWS commands right from our command prompt. Let's navigate to command prompt here. Perfect. So once I have the command prompt open, I can now start to execute these commands. Now, of course, there's a whole list of reference commands that I will provide as a downloadable resource, but just so that you're aware, I'm going to demonstrate how to configure the AWS environment, how to connect to AWS, input our access ID keys, and so forth. But before we actually do all of that, let me bring up my handy notes here that I will also provide. You'll notice that, let me scroll up to download the MSI file, which we did already. And now you can also run some of the commands here. For instance, I can type the AWS, check the version. So just type AWS space 2 dashes and version. And this is going to bring up the AWS CLI. And that's the installation we did with the MSI, right? Great. And of course, Python is also there. But to verify whether Python was there, I can also check the version of the Python. This is Python 3.6.7. Awesome. Next, I can run AWS configure if I need to connect to AWS. But before I actually do this, just the word on pip, by the way, you can install the pip install AWS CLI right from the command prompt as well. So if you do not download the MSI package, right, for Windows, let's say you're using Mac or Linux, you can simply type this command, pip install AWS CLI. And if you can also use the curl command to install. It will get the pip and install pip for you. And then once pip is installed, you can then use the package manager to install the rest of the tools or Python for it. Great. So for instance, let me just demonstrate this. So if I were to use pip to install, and you can of course uninstall this as well, and then type this, this is also going to collect the AWS CLI and it's going to install for you, right? So it's going to navigate to pythonhosted.org, fetch all the packages, and start the installation process. Okay, so I just wanted to demonstrate both ways. Since the requirement is already satisfied, it's there. But in your case, if you're installing afresh, it's going to actually go ahead and do the install for you. Great. Once this is installed, next, let's go ahead and continue on with configuring our actual AWS environment. So I'm going to go ahead and do AWS configure, and this is going to go ahead and ask for my access key ID and then of course the secret ID and so forth. So let me go ahead, navigate to the Management Console and fetch those access ID for this user. So I'll navigate to the Management Console page, go under Services, the IAM under Security, Identity, and Clients. Once I'm on that page, I'm going to, from the left side, I'll be navigated to the users, right? That's what I'm looking for. Go ahead and click on Users. And I should have a couple of them. Perfect. So I'm going to pick, let's say, this, my name here, Syed, for security credentials. And then here are my access keys that I've created a couple of. You can use each one of them, any one of them, right? And this, of course, you like to keep it secret, right? Because you have the access key ID and there's a secret key ID that was downloaded once you created the access key, okay? So go ahead, fetch that, and then let's navigate back to our command prompt here. And I'm going to go ahead and enter first the access key ID. And then, of course, I need the secret key as well. So after I enter the secret key, just hit the enter key. The default region name is none. You know the region name, you can type US East -1, for instance, or you can leave it blank. The default output format, if you leave it none, that's fine. Otherwise, it's typically JSON. And then you have run the AWS configure command at this point in time. So let me go ahead and clear out the screen here so we can continue forward. Next, what you'd like to do is take a look at all of the instances that are part of the AWS. Since we're already connected to our account using the command prompt, so I'm going to go ahead and type the following command. See if I have it here. There we go. So it's AWS and then EC2 describe - regions and then output a table. If I run this command, this is going to list all of the that I have available within the AWS ecosystem. It takes a few seconds or so because it's trying to connect, and then it will print out the output table for you. Perfect. So if I scroll up, notice this is all the endpoints that I have available and then the region names within the AWS ecosystem. Great. So let's scroll down, run another command here for you. Here we are going to create a new bucket, right? A new S3 bucket within our AWS ecosystem. Straightforward. I'm just going to run this command AWS S3 MB make bucket, and then of course the name of the bucket after you provide the path. So in this example, I'm using the name called new CD bucket. So if I were to execute this, this is going to go ahead and create a new bucket within AWS. Let's verify this. Let's navigate to our management console here under services. I'm going to go ahead and go to S3, and this will list all of the buckets. And within this list, I should be able to see the recently created bucket. And if I scroll down, perfect, there we go. So it's the very last one on the bottom here, right? It's called new CD bucket. And if I need to remove the bucket, just bring up the command line and then use the same command. Instead of make bucket, we are going to do RB, right? Remove bucket. So if I execute this, this is going to, in fact, remove this bucket behind within my console. So if I go to my console, just refresh, you will notice, perfect, now I have 8 buckets instead of 9. So it's very powerful to use the command line or the command prompt, especially if you're working with the Amazon ecosystem. You can, of course, use the GUI interface as well, but it's really your preference as DevOps engineers is sometimes easier when you're working with command line. If you've been around for a while, like myself, with well over 15, 20 years, you're pretty comfortable with the command prompt, right? But if you're a new user, then you may want to use the console itself and use the GUI interface. However, I would recommend that you do both. Okay, so you need to be pretty good at both of these. And as you progress, as you get more experience, I've provided you the command line reference. So just practice with all of these commands. And as we move forward, we'll be using this as well. So I hope this helps. Practice with this. If you have any questions, post in the discussion area. I'll be glad to help. With this, let's move to the next lesson. Welcome back. Super excited. In this lesson, I'm going to talk about the core concepts as well as demonstrate what these developer tools are within the AWS console. So before we actually start building the pipeline, it's important to understand what Code Star does, what code commit is, what is code build, deploy, pipeline, Cloud9, X-Ray, and then there's one more, AWS Corrado, that just released. So let's begin. Take a look at the concepts. It's important to know them before we can actually start our journey towards building various DevOps pipelines. First is the code commit. It's a fully managed source control service. So that's what you have to remember. Code commit is simply a source control service that hosts Git-based repositories. Okay, so you need to have Git client, you You can install it, you can go to Git, Google Git, and then you can download it to your computer, whether it's for Mac, Linux, or Windows. So Code Commit makes it easy for teams to collaborate on code in a secure and scalable AWS ecosystem. So not only you have one developer, you may have developer teams working on your enterprise app spread across the globe. They can be working and then committing code to AWS or using AWS Code Commit. It also eliminates the need to operate our own source control system or worry about scaling its infrastructure. So that's essentially what AWS takes care for all of our source control system needs. You can use Code Commit to securely store anything from source control binaries to binaries, and it works seamlessly with our existing Git tools. Let me show you what I mean before we move to the next set of service. So I'm going to switch to our management console here. So here's the AWS Management Console. I'm logged on to my console. Let me navigate to the services, and you'll notice under Developer Tools, we have all of these services listed. So to create the entire CI/CD pipeline, we'll be using Code Star, and then of course all of the rest of the services as well. So each one of these services that we're taking a look at, so I'm just going to demonstrate or show you Code Commit, right? So I already have it open, I believe, in the next tab here. Here's Code Commit. So if you click on that, it'll take you to this particular dashboard. So you'll have all the repositories here. On the Getting Started page, you can see that you can create secure repositories for sharing your code in the cloud, right? And you can scroll down and kind of read about the benefits and features of Code Commit. And that's your homework. If I click on repositories, it will list all of the repositories for you. I already have all of these apps created that we're running on various Elastic Beanstalk or serverless, whether it's a Java Spring app or PHP project and so forth. So this is Code Commit. And notice right under Code Commit, you have build, deploy, and then code pipeline as well. So let's switch back to our slides. Next is the AWS Code Star that I'd like to talk about. Very important, the core set of service, right? AWS Code Star enables us to deploy, build, and develop applications on AWS. So think of this as the main thing, right? Or the main service. Code Star provides a unified interface, so one GUI interface enables us to easily manage our software development activities in one single place. With Code Star, we can set up our entire continuous delivery toolchains in minutes, allowing you to start releasing code faster. And that's important because as DevOps engineer, this is exactly what your mission is, right? So you like to monitor the entire CD pipeline or CI/CD pipeline, and then ensure that all of the code being committed by various developers is being or passing through the pipeline in a very, very efficient manner. Okay, and there are no bottlenecks, there's no downtime, there's no slow time for the code. So AWS Code Star really makes it easy for the entire team to work together in a secure environment, and it also allows us to add additional owners like project managers, solution architects. Maybe you have an entire QA department, right, working on testing, whether it's behavior tests, functional tests, unit tests. And each CodeStar project comes with a project management dashboard. And it also links up with our issue tracking or provides the issue tracking capabilities, such as a third-party outage in JIRA, or you can also do a GitHub issue tracking as well. So CodeStar is a very robust service that AWS offers that allows us to really work with our CI/CD pipeline. And that's exactly what we'll be doing moving forward throughout this course. Code Build is a fully managed build service that compiles our source code. Okay, so once we commit the source code, it goes to the Code Build area. This is where the tests are run and produces software packages that are ready to be deployed. So we don't need to provision, manage, or scale our own build servers. Code Build will do it for us. And code build also scales continuously and processes multiple builds at the same time. So we're not waiting in a queue. We can also easily get started with code build by using prepackaged build environments, or of course we can create our own custom build environments as well. Then we have the code deploy, which is a service that automates that code deployment to any instance, including EC2, or whether on-premise or on the cloud. So code deploy is or makes it easier for you to release new features of your software application and avoids downtime, right? So it's really little downtime if you use code deploy during the application deployment and handles the complexity of updating your application. You also have the option within this code deploy to release manually the code commit. So instead of running through the entire automated pipeline, you have the option to manually release as well, because we understand the difference between CI and CD. We can also use code deploy to automate software deployments, eliminating the need for error-prone manual operations. And that's the key here. Working through the pipeline with AWS is really error-prone, and you'll see as we move along, it's a very robust code pipeline. The service scales with our infrastructure, so it's easy to deploy to one instance or thousands. So as your app grows, as your team grows, it's all scalable. Then we have the code pipeline itself, which is a fully managed continuous delivery service that helps us automate our release pipelines for fast and reliable infrastructure and application updates. So what code pipeline does, it essentially automates the build, test, and deploy phases of our release process every time there's a code change. So let's say your developer is using an IDE such as Eclipse, or they're using Cloud9, which is a native cloud-based AWS IDE. If they're using any of these IDEs, then they're working on master branch, or they're working on other branches committing code. Code pipeline would automate that particular process. So they would commit code within the IDE, and once they use Git to push the code to AWS, code pipeline will take care of that. And of course, the result is very advantageous, because now you can rapidly and reliably deliver features and updates. And we can easily integrate code pipeline with GitHub or with our own custom plugin. And with code pipeline, we only have to pay for what we use. And that's also a real benefit, because there are no upfront fees or long-term. Next is the AWS Cloud9. I think I mentioned earlier, this is simply the IDE, which is cloud-based, right? That AWS offers. Very robust native AWS IDE, which lets us run, write, and debug our code within a browser. So think about this. If you have developers spread all across the world, they don't have to use an external IDE, for instance. They can just log into the cloud and use this particular IDE, which seamlessly integrates with the entire AWS code pipeline, Code Star. So Cloud9 comes with prepackaged essential tools for almost all the programming languages, such as JavaScript, Python, PHP, and more. So we don't need to install files or configure our development machine to start new projects. So Cloud9 also provides a seamless experience for developing serverless applications. And that's also, the future is all about serverless applications, serverless computing, right? So Cloud9 fits very well within this, and we can easily define the resources, debug, and switch between local and remote execution of those applications. The good thing about AWS DevOps Code Star, or the pipeline that we'll be building, is that we can switch our IDEs. So for instance, you can have a Cloud9 IDE for one of your projects in Code Star. You could have an IDE using Eclipse on the other projects within Code Star. So you're not bound by any of these IDEs. And of course, I'm going to demonstrate all of that. Amazon X-Ray, or AWS X-Ray, helps developers analyze and debug distributed applications in production or under development, such as those built using a microservice architecture. right? So we don't have to worry about the monolithic traditional application, right? That's gone, or that's the idea, right? Moving forward. So with X-Ray, we can understand how your application and its underlying services are performing. So you can identify and troubleshoot the root cause of performance issues and errors. Hence the name X-Ray, right? So you can really have a real vision of what the errors are, and you can easily troubleshoot and identify issues. So X-Ray provides an end-to-end view of requests as they travel through the application, and kind of shows a visual map of your application's underlying components. And this is pretty powerful because we can use X-Ray to analyze both application development and in production. This is AWS Corretto. However, you might have noticed that within the console, this is not listed, okay? But they just recently released it as we speak. It's still in preview. The Amazon Corretto is a no-cost, multi-platform, production-ready distribution for the Open Java Development Kit. So it's the Open JDK. It comes with long-term support that includes performance enhancements and security fixes. And you can simply download for either Windows, Mac, Linux, right? Different versions are available if you need to download and play with it. Amazon runs Corretto internally on thousands of production servers, and Corretto is certified as compatible with Java SE standards. With Corretto, we can develop and run Java apps on different operating systems, such as Linux, mentioned, and Mac, as I mentioned earlier. And again, still in preview. Now I'm going to provide downloadable resource for some of these services, right, which are important, especially the newer services, because as DevOps engineers, you need to be aware of what's coming in future, or what is actually current, right, or latest technology. So this is one of the latest areas. Here's a overview of AWS code pipeline, whatever we just talked about. So you have an app, changes are being committed to the source control, goes to code commit on the bottom here, and moves towards write to code build, where the tests begin. Then the code pipeline continues to staging, which is code deploy. We also use Cloud Formation, for instance. These are just templates. We write in YAML or JSON format. Typically it's YAML because it's easier to manage. It also involves the Elastic Beanstalk, ops work, and AWS now supports Puppet, right? Before it allowed the support for Chef, but now you can spin up a Puppet server as well. The QA tests, such as integration and load tests, are also performed within staging area. And then finally, the production is deploying to production. So we have the continuous delivery and the auto deployment options throughout the pipeline. So just a high-level overview at this point. Before I end this lesson, I'm going to quickly demonstrate all of these services by going to our Amazon console. So I'm going to go ahead and navigate to my AWS console. There we are. So the last console we visited was the service was the code commit. I have all these tabs open for ease of use. So next is the code build, which again is right after code commit. Notice on the left navigation pane, you'll see the code build. It allows us to build and test code with elastic scaling. Pretty neat. So it's a fully managed continuous integration service. Okay, code build is your integration CI, similar to Jenkins that I'm going to talk about and demonstrate later on as well. How to integrate Jenkins with our AWS environment, because even though this is fairly new by AWS, Jenkins is fairly popular, right? Fairly popular tool that is used for building up a DevOps environment. So next would be the code deploy, which is right here, which automates code deployment to maintain our application time. And once again, it's a fully managed deployment service that automates our code to compute services such as Amazon EC2, or we can use Amazon Lambda on our own servers or cloud. And code deploy really makes it easier to deploy new features, right? So let's say you're managing or running an enterprise app, and you as DevOps engineer are, of course, overviewing or monitoring the entire pipelines for different projects. And the customer requires updates, in a short amount of time. So building a DevOps pipeline with AWS should fairly robustly solve that challenge or issue. All right, next one is the AWS Code Pipeline. Here you can visualize and automate the different stages of your software release process. So this is the continuous integration and continuous delivery service. Okay, so that's what Code Pipeline is, CI/CD. The next one is X-ray that I just talked about. So this is just to analyze, identify issues of your distributed application, and it provides tracing capabilities, exception collection, and profiling capabilities. And last one, of course, is our AWS Cloud9 environment, which is the IDE that I mentioned earlier. So instead of using Eclipse, for instance, as an IDE, you can use the native AWS Cloud9. And I already have a project here. Let me, in fact, open the IDE so you can actually see what it looks like, right? Might as well you have it. There we go. So this is what the IDE looks like. So you can see, you can change the code. You can do whatever you want to do. There's, on your left, you'll have all of your project explorer navigation pane, all of the projects, but all of the files. So you can open up any one of these files. For example, you can open up index.php and start typing code. Once again, this is an example of IDE. So I hope this helps. I just wanted to cover in this lesson, show you all the services or the developer tools that we'll be actually using as we move forward with our learning journey. So any questions on any of these services, let me know. I will provide several downloadable resources for you to study with it. Is working hands-on is great, but understanding the concept is also important. With this, let's move to the next lesson. Welcome back. Super excited. Moving forward in this short lecture, I'm going to demonstrate how to install the AWS SDK or toolkit within your Eclipse IDE. In the previous lesson, we installed the Java Enterprise Edition on our Eclipse Neon, and I demonstrated how to download and install the IDE itself. Here, moving forward, we need another area or piece, which is basically installing the AWS toolkit within our IDE. Why do we need this? Well, like I talked earlier in our previous lesson, just quickly, we need this so that it installs the web tools, install the Elastic Beanstalk tools, and so on. So it allows us to work with our Code Star. So let me, in fact, show you this quickly before I do the actual installation within the IDE. So it's easier for you to really visualize and see what I really mean. So let me scroll down here. Let me find the developer tools called Code Star, Code Commit, and this is exactly what we're be working with within this particular area moving forward, because we are building our CI/CD pipeline, the entire DevOps pipeline. And the reason why we need, of course, the IDE is because our code resides in our IDE, could reside rather, because you use Eclipse IDE, Visual Studio. You could also use Cloud9, which is a wonderful cloud-based IDE, okay, that AWS offers. So if you choose not to use Eclipse, perfectly fine. Cloud9 rather within AWS. All right, so in order to use or work with CodeStar, one of the prerequisites, of course, is to have a repository or code where you're going to code, right? So we install the IDE. Now, next prerequisite is the actual installation of the toolkit so that CodeStar or this particular code commit, build, and deploy, all of these services can communicate with your IDE or where your code resides. Okay, so for instance, if I were to, let's say, click on CodeStar, we can create a new project, and then throughout this process, of course, I'm going to get this to this later, right? So throughout this process, you will see where you need to link up or have the SDK installed. So I just wanted to kind of briefly high-level overview at this point in time. And of course, once we get to the actual CodeStar, you will see how easy it is to actually build a DevOps pipeline. So all we're doing here is just making sure that we have all of the necessary tools that are already there, so we have a smooth flow later on. You could start right away, by the way. Okay, so if you're looking for some challenges, perfect. So go ahead, you can start out with a project, and during the project, you can create roles, you can create the SDK, you can install the Eclipse IDE, and so on. So it walks you through anyways, right? But I find it easier, and of course, from a learning perspective, it's better if you kind of understand not only the concept, but the applications of each of these areas as being prerequisites. All right, perfect. So let's navigate to Eclipse. Here's my IDE. And from within the IDE, I need to simply go to Help and then click on Install New Software. Brings up the dialog box. The Work With field, this is where I need to type the software that I'd like to install. So I'm going to simply click Paste, and this is the URL. You can get this URL from the Amazon site. It's fairly straightforward. You can note this down. I already have it noted within my notes area, remember? We're keeping a tab of all the notes, and it's a good practice, by the way. And I will provide this as a downloadable resource to all of my students so that you can actually reference as you're progressing through. It may not be in the right order, guys, but you should be able to find all of the areas. So what I'm going to do is just maybe do a line within my notepad here and then do some additional commands. It's going to build up this particular document. Okay, perfect. So to install the AWS toolkit for Eclipse, you need to just simply copy this URL, aws.amazon.com/Eclipse, and then paste it here. Simply go ahead and click on Add, and you can provide a name to this. So you can name the repository as you like. I'm going to call this AWS Toolkit, and then click OK. And this is going to work with this particular AWS Toolkit, the name that you provided, and then of course the URL. And at the bottom right, you can notice it's fetching all of the children of AWS Toolkit, kind of installing, and it's going to give you a list of all of the areas or options that you can pick and choose. Install AWS Toolkit. So it may provide options like core services, which is a mandatory requirement to install the toolkit. The rest of the options may be optional, such as even the Android development is optional, but we'll wait once it fetches all of the list items. There we go. So we have a list of all of the components within the AWS toolkit. Take a look at all the details that are part of the core management tools. For example, the Cloud Formation tool, which allows us to actually build manual templates or in JSON or YAML format, and then deploy our instances and the entire code pipeline also. So very powerful tool, Cloud Formation, that of course I'm going to be detailing out as we move forward. It also installs the simple workflow tools and the toolkit for Eclipse core, which is the required. Okay, so I'm going to select all of this for now. And then for development or deployment tools, you have the code deploy plugin. You have the Elastic Beanstalk, you have the Lambda, and the ops work. Kind of works with Chef as well when we build the pipeline. But I'll be using Jenkins to later on demonstrate the entire workflow of building a continuous integration using Jenkins. So we are going to select all of the deployment tools as well, so that all of the tools will be installed within our Java Enterprise Edition IDE, Eclipse. Next are the set of developer tools. If I expand that, notice there's the Code Commit plugin and the Code Star plugin. So essentially, all of these are dev tools. So I'm going to go ahead and select all of these as well. And just so you know, quickly, if I navigate to my AWS console and navigate to services, scroll down a little bit within the dev tools, here you'll notice all of these services, right? So Code Star, Code Commit, Build, Deploy, Pipeline, Cloud9, and then X-Ray. Okay, so these are the plugins that will be installed within our IDE. So once we start coding or creating web apps or any other software application, AWS can easily link up with the entire pipeline. Great. So let's navigate back to our Eclipse here. So we have selected the AWS developer tools. Let's scroll down. The rest of these are optional. So if you are willing to or looking to do Android development, then you can install the Android SDK for Android as well. And AWS data management tools, such as the RDS management or the simple DB management, is also available. So if you need to use, let's say, the relational DBS or DB for AWS from within Eclipse, you can choose these options as well. I'm going to go ahead and select one of these optional data tools as well. Perfect. So once you have selected all of the necessary AWS tools or services from within Eclipse, simply click on Next, and this is going to go ahead and start the installation process. It's going to calculate the requirements and dependencies, and it's going to begin by giving you all of the details that you can review here. So for instance, if I expand the code deploy, this is the toolkit for Eclipse core. If I expand the Code Star plugin, it'll say AWS toolkit for Eclipse code, and so on. So once I've reviewed everything, click on Next. Of course, accept the licenses. You want to go ahead and read the license. Perfect. Finish. And this is going to begin the software installation. Click on Run in background. It's going to install while you actually do your work within the IDE. You can also click on the detail button here. It just kind of shows you the progress so far. So this sometimes takes a while, depending on the internet speed and the connection itself. And secondly, is fetching all the artifacts, right, from the repository. So it takes a while. So we're going to let this run. Once this is finished, it should install the AWS toolkit for us. So once everything is installed, all you need to do is restart Eclipse. I'm going to go ahead and click on Yes. And this is going to close Eclipse, of course, and open it back up again. So once Eclipse restarts, it prompts you to enter the access key ID for your AWS toolkit for Eclipse, as well as your secret key ID. Okay, so this is, of course, is obtainable from the AWS console, where you have created the access keys under, I believe, the IAM role. So that's where you'll be able to get those. Let me, in fact, quickly show you. Let's navigate to our AWS console. So once I'm in my console, scroll up here, navigate and click on Identity and Access Management. And within this page or service, you'll be able to find the access key for your account. Navigate back to the IAM console page. Let's go to our dashboard, and this is where you'll be able to take a look at our root access keys. And if you navigate or click on root access key, click on Manage Security Credentials. This is where you'll be able to find your secret key and your account key as well. So let's navigate to Change to Security Credentials. And of course, if I expand the access keys here, you'll be able to see two sets of keys. And of course, I'm not going to show you this, right? But you get the idea. If you have an AWS account, you should be able to see both key ID and secret access key. Perfect. So let's navigate back to our Eclipse. So here, let me go ahead and paste both the access key ID and the secret key as well. So I have both my access key ID and secret ID. If you do not have an AWS account, by the way, you can always click on this link and navigate and create a new AWS account. Or if you have an existing account, just click on the existing credentials link here from within this dialog box, and it will take you directly to your AWS IAM console page. So once you have the keys, let's click on Next. Just a simple collection of analytics. Leave it checked if you like, and click Finish. And what this will do is open up the AWS services or the AWS Explorer for you. And this is where you can take a look at all of these services that the toolkit actually connects to. Pretty powerful. So once you have it all connected, of course, notice you'll have the code commit, right? That's part of this. You have the beanstalk, you have the RDS, you have the apps work even, you have the code commit, SQS service, Lambda, code deploy. So all of the required services that you would be needing once you start developing the DevOps pipeline for both CI and CD. So practice with this, try installing the toolkit. If you have any questions, post in the discussion area. Be glad to help. With this, let's move to the next lesson. Welcome back. Super excited moving forward. In this short lesson, I just would like to highlight and demonstrate that although I demonstrated the Windows download the MSI file from the Amazon.com CLI page, what you can do is you can also fork the repository from my GitHub page so that you have it available within your own GitHub repository. So all you need to do is just let me navigate to my GitHub page here. And then once you're on that page, just navigate to repositories. And then within repositories, you are going to find the AWS CLI repository. Here it is. So it's the first one right here. And then you can kind of click on it. This is the universal command line interface for Amazon Web Services. Okay. So once you're on this particular page, you can navigate to each one of these folders. You can scroll down, take a look at the AWS-CLI package itself. The installation steps are also available. And again, I've demonstrated this, but if you need to use, let's say if you're using Anaconda, for instance, and creating a virtual environment, you can use pip in that, or you can also take a look at different CLI releases. Okay. You can also fork it from AWS GitHub page as well. Okay. So I just wanted to quickly demonstrate in this lesson that you need to have GitHub page for yourself, right? If you have an account, that's fine. If you do not, then go ahead and create one. It's always a good idea to create a GitHub account so you can maintain your own repositories, your own code, practice code, and whatever areas that you're working with. So I hope this helps. If you have any questions, post in the discussion area. With this, let's move to the next lesson and continue with our CLI commands. Welcome back. Super excited moving forward. In this short lesson, I'm just going to quickly demonstrate how to download Eclipse. Not a big deal, but a few important considerations. First, when working with AWS, you need to either install the Eclipse version Mars, version Neon, or Luna, right? So there are 3 versions that are supported at this point in time. So I just want to make sure that you have the correct version that you're actually installing for Eclipse. So all you have to do in order to install is just go to the downloads page. There's a couple of ways you can install Eclipse. You can directly install the version that you know of. If not, what's recommended is download the Eclipse installer. And from there on out, you can actually choose which IDE you like to install. So in this particular demonstration, what you need to do is just navigate to eclipse.org to the downloads page, and you can click on download to download the installer. Okay, so this is not actually installing Eclipse, but it's just downloading the installer. And I'm going to show you in a moment what that looks like. So go ahead, download it, and then once it's downloaded, run it. Once you run it, you'll get a screen something like this. It'll say Eclipse installer. So if you have a warning symbol here next to the 3 lines here, or the hamburger icon, right, something like that, just click on it and click on update. And what this will do is it will bring up the updates for the licenses and others as well. So click on accept, and this is going to quickly update the installer with the relevant packages that form part of this Eclipse installer. So once this is completed, then it's a good idea to navigate and install your preferred version. So once all of the updates are completed, it's going to give you a prompt saying OK to restart. So let's go ahead and click on OK. And this is quickly going to restart the Eclipse installer. And then you should be able to navigate to your preferred version, whether it's Mars, Luna, or Neon, right? So that's the 3 versions. However, you can also install the latest version, okay? But before I get to that, notice within the installer, if you scroll down, you'll see Eclipse IDE for C++ developers, for PHP developers. You have the DSL tools, modeling tools for Android developers, and so on. So there's a whole list of different versions of Eclipse that you can actually use. So I'm going to navigate up, and I'm going to choose for my own purpose. Of course, you can choose others as well. I'm going to go ahead and click on Eclipse IDE for Java Enterprise developers. Okay, so let's go ahead and click on this. As soon as you click on it, notice the product version. If you click on the drop down, here you'll see the Neon, Mars, or Luna, right? So these are the three that you can install if you choose to do so. Or you can choose to install the latest version of Eclipse IDE for Java Enterprise. So for example, let me quickly show you this. So if I click on Mars, you can simply choose Mars and click on install. The only difference here is that it installs Java 1.7 plus the VM, right? So Java 1.7 version is installed. And you can choose 64-bit or 34-bit. By default, I have 64-bit Windows running. Similarly, if you were to choose Neon, you could do so. Neon installs, in fact, the latest version of Java 1.8. So you could install Neon as well. So it's really up to you, okay? So I'm going to go ahead and select Neon, and then make sure you specify the folders where this is going to be installed. If you choose to install a different folder, just simply click on the folder icon and navigate to that folder directory. So once you have selected the Neon, I'm going to go ahead and click on install. And this is going to go ahead and start the installation process. Of course, straightforward, license, agreement, accepted. And then once the installation is complete, you should be able to open up the IDE. The next screen simply accepts additional licenses. You can always choose to click on remember accepted licenses. Click on accept. This is the first time actually I'm installing on this particular computer. I don't have an existing IDE, so this is great, right? So you see it from scratch. And IDE is also required, especially when you're working with Code Star, AWS Code Star, right? When the developers are actually working with it. So this is one of the prerequisites, so to speak. You can use Visual Studio as well, IDE. You can use Eclipse. You can also use Cloud9, which is the native AWS cloud-based IDE. So I'll show you that later on too. But again, since most developers are comfortable working with Eclipse, so I figured it's a good idea to demonstrate this. The rest of them will follow suit. And also note that once you install the Neon, the AWS SDK would support this, right? So once we install the AWS tools within our Eclipse Neon IDE, it will be much easier and of course supported as well. So once everything is installed, you can directly launch the IDE. You can click on the README file or Systems Explorer and so on. So I'm going to go ahead and click on launch just so that you can see what Neon Eclipse IDE looks like. So I'm going to go ahead and click on OK because this is the workspace. You can of course create additional workspaces, just provide a path. And it's a good idea to have different workspaces for different projects or maybe different environments, okay? So as you work more and more with, maybe you should have a workspace for Java only and then a workspace for PHP projects and so forth. So I'm going to leave this as default, click OK. And this is going to go ahead and open up the IDE. And there we go. So maximize this. So it just gives you the welcome tab. You can take a look at certain elements or things within the Enterprise Java IDE for web developers. So of course, once you have it installed, then you can open up the workspace or you can work with tools, install software, and that's exactly what I'm going to demonstrate next, is basically how to work around within your IDE, and then especially in relation to the AWS SDK. So I hope this helps. Just go ahead, practice, straightforward demonstration. So I just wanted to quickly get this out of the way, just so that for those students who are not familiar with the IDE itself, or you may be using a different IDE, this is a great practice. If you have any questions, post it in the discussion area. We'll be glad to help and answer. And with this, let's move to the next lesson. Welcome back. Super excited. In this brief lesson, about 4 to 5 slides, I just want to talk about our next few steps that we'll be performing as we progress through this particular course. AWS serverless computing is important. As the cloud computing grows exponentially, more and more DevOps engineers are required because enterprise companies are having a difficult time in identifying and finding the right skilled individuals. So I just want to spend 4 to 5 slides, a few minutes in talking about what serverless computing is, Code Star, Lambda, AWS services, and then finally I'll list out all of the deployment for our Spring Java app that we'll be doing, and then I'm going to demonstrate, of course, the entire pipeline, and then also creating branches from our master branch, create a test branch, and then code in our Eclipse IDE. So all of that, of course, is forthcoming. For now, just briefly, AWS serverless computing. You may already be aware, but serverless is basically a native architecture of the cloud that enables you to shift more of your operational responsibilities to AWS. So you don't need to handle your servers, you don't need to spin up VMs or virtual machines anymore. It's just shifting all of the workload to AWS. And of course, the benefit is that you, in return, get more agility and innovation. Lots of benefits. Serverless also allows you to build and run applications and services, infrastructure services, without thinking about servers. So no more hardware. It also eliminates infrastructure management tasks, such as server or cluster provisioning, patching, capacity provisioning. You don't need to worry about backing up your servers, for instance, nor you need to do server maintenance, so there's no downtime. You can build them for nearly any type of application or backend service, and everything required to run and scale your app with high availability is handled for you by AWS. The question is, why use serverless? Why is it so important? Of course, besides the obvious benefits, it also enables you to build applications with increased agility, and the ultimate benefit is the lower cost of total ownership. Building serverless apps simply mean that your developers can focus on their core product instead of worrying about managing and operating servers or runtimes, either in the cloud or on-premise. So it frees up your time for your developers, which essentially are the core or the meat part of the entire DevOps pipeline or building your enterprise app. So in essence, this reduced overhead allows developers to reclaim their time and energy that they can spend on developing great products which scale and that are reliable. So in my experience, working with DevOps pipelines and managing hundreds of developers in any given project, for instance, developers also require a lot of learning, right? As they're actually developing and working with their core set of expertise, they need time to also keep up to date. Okay, so they use a lot of GitHub resources, a lot of learning tools that, for instance, are provided by the organization. So serverless helps developers. AWS Lambda, just quick, briefly, you can always look that up, but just Lambda is a compute service that lets you run code without provisioning or managing servers. So even on AWS, you're not really provisioning any virtual server or Elastic Beanstalk, for example. You're just using this compute service, which allows you to run code without any hardware itself. So Lambda executes your code only when needed and scales automatically. And of course, if you don't use it, it's just going to sit and wait. With Lambda, you can run code for virtually any type of application or backend, all with zero administration. I'll demonstrate that, of course. It also runs your code on a high availability compute infrastructure and performs all of the admin tasks for you. So you don't need to do anything basically. All you need to do is supply your code in one of the languages that it supports. For example, if you're building a web app in Node.js or Java, C++, Go, and Python. So it supports all of these. Perfect. Last slide. Deploying our Spring Java web application. So I'm going to start off in the next series of lectures. We are going to be working with AWS Code Star. I'm going to demonstrate that, how to use Code Star and build the entire DevOps pipeline. We are also going to be working with AWS Lambda, just briefly show you how AWS uses Lambda. And then, of course, our endpoint gateway or the API gateway is created once you deploy the web app. We are going to build the entire CI/CD DevOps pipeline. So our developers are actually using Eclipse IDE, which is the source IDE or the integrated development environment where our developers are going to be coding in Java. We are going to install and configure the AWS toolkit so that our IDE is in fact connected to, configured with the AWS environment. We could also use other IDEs, by the way, just as a footnote. We could use Cloud9, which is an AWS service, by the way. It's a native AWS cloud-based IDE. So I may demonstrate that in addition to Eclipse. So we'll create some master branch or work with default master branch. We'll also create additional branches. We are going to code and run the code through the entire pipeline. So this is the next set of lessons that are forthcoming. So I hope you're excited. I'm super excited. So let's begin. Let's jump right in and take a look at AWS Code Star and deploy our first Spring Java web app, which is serverless, right? And then it's going to use Lambda. Perfect. Let's jump right in and let's move to the next lesson. Welcome back. Super excited. Moving forward, in this lesson, I'm going to demonstrate how to create your first Code Star project, because we are going to deploy a web application and then, of course, run it through the CI/CD pipeline, essentially completing the entire DevOps framework, right? Or the lifecycle. So to begin, we have already taken care of some of the prerequisites, such as installation of our Eclipse IDE. We also installed the AWS toolkit within our Eclipse IDE. So everything is set up there, right? And works perfectly fine. And that's been conducted in the last few lessons. Here, moving forward, I'm going to demonstrate how to create a Code Star project and then, of course, move forward with the pipeline. So this is an important lesson. So let me go ahead and scroll down and navigate to the Developer Tools section and then choose Code Star. This will bring us to the AWS Code Star dashboard. And here I can simply develop, build, and deploy applications on AWS. It's really a 2 or 3-step process, fairly short process, and you get a fully deployed web app, okay? Whether it's Node.js, whether it's Java, whether it's PHP, Python, you name it. So let's go ahead, start our first project. Click on Start a Project. This brings us to the next page. Essentially, the circles that you see up on top is basically a 3-step process, right? So you select a template, you set up your tools, which essentially are the Eclipse or any other IDE that you're using, whether it's Cloud9, AWS Cloud9 IDE, and then you start coding. The entire pipeline will be built by AWS. That's exactly what we'll see as we move along. So first things first, we select a template. So what kind of project are we intending to make, right? Whether it's a Go application, web app, it's going to be based on the AWS serverless Lambda or serverless computing. Whether it's a Node.js web app, again, running on Lambda, serverless, whether it's a Python, HTML, static website running on an EC2 instance. We have apps running on Elastic Beanstalk, right? That's something I'm going to demonstrate later on too when we get to Jenkins CI part. So there are several options, right? There's PHP, Laravel, Java, Spring, and you name it. So you can kind of scroll down and take a look at the type of application that you like to deploy. Great. So let's navigate up. On the left navigation pane, it's the same thing. So you can quickly navigate to any one of these by simply selecting within the application category or programming languages, which is fairly common. So if I need to, let's say, build a Node.js app. Okay, it'll just display the options that I have for Node.js. Similarly for Java and PHP and so forth. So I'm going to click on Java. So for Java, I have a few options. I can either do a web service using AWS Lambda running serverless. I can do a Spring web app, which is running on Beanstalk. I can do a Java Spring web app running on Amazon EC2 instance, right? For the virtual servers that we manage ourselves. We can also choose Java Spring web app running on Amazon EC2 or just a web service using Beanstalk. So it's really up to us as to what we need to run and choose. If you're not sure, you can always click on Help Me Choose and it'll take you to the documentation page. You can kind of explore that area as well. And as DevOps engineers, it's always a good idea to not only learn hands-on, but also kind of understand the concepts as to what is the best option. Because a company or a project that you're working on may have certain requirements that you need to cater to before you choose and select the type of application they need to deploy. So for right now, I'm going to use the serverless computing, okay? Develop a Java app in serverless environment. The web app using Elastic Beanstalk, I'm going to demonstrate that later when I get to Jenkins, so you can kind of learn about the managed application environment, which is pretty neat as well. But here we are intending to do a pipeline on the Java Spring Web Service. So let's go ahead and click on the Java application here and simply enter the project name. This could be any name, so I'm going to call this CD Java Serverless, right? That's the project name and project ID. The next option is the repository, right? Where the code resides. So AWS Code Star will essentially store the source code with the service that you choose between the two, whether it's going to be AWS Code Commit or if you're using GitHub as your source repository. So of course I'm going to demonstrate GitHub later on, right, with Jenkins. No worries. Here we're interested in using AWS pipeline, right? Because the goal for this is to build entire pipeline using AWS services. So the code commit is a highly available Git source control from AWS, which includes encryption, IAM integration, and more, right? So I'm going to click on code commit, scroll down, click next. Great. So here I can review the project details. So CodeStar includes all of the tools, and I repeat, all of the tools and services that you need for a development project, right? It's as powerful as I can say. So this project includes the following, right? So it's going to start with the source, which is AWS commit service that's going to be using on this behalf or this part. Then we're going to move to the build. So AWS code build service is going to help us in this phase. We have our testing phase, or this where we actually test the code, and this is where the QA testing comes along. And I'll take a look at it and I'll demonstrate what this is once we actually move to these areas. So each of these areas are going to be detailed out. So I'm going to have several lessons on code commit, and then build, and then testing, Cloud Formation, which is the deployment stage, and then monitoring, which is conducted by the AWS CloudWatch. So essentially the entire pipeline. Great. So make sure this AWS Code Star will like permission to administer the resources on your behalf, which is fine. And then once we're comfortable with all the settings, let's go ahead and click on Create Project. And this is going to spin up the project. Before it actually ends and continues to spin up the project, which is on the bottom here, you'll notice it's cloning the repository, it's creating the repository for us, and will provide a link to us, okay? In the meantime, we navigate to our second step, which is set up our tools. So pick how you want to edit your code. And we have 4 options. We can use the AWS Cloud9, which is a cloud-based IDE. It works wonderfully well, and I may just demonstrate that in a separate lesson. You can use command line tools, such as your Git tools or your Git commands. You can use the CLI commands. You can use if you're deploying a Python application. So I'm going to demonstrate this in the later half of the course when we talk about Jenkins CI. I'm going to use Beanstalk and command line tools. So you'll be comfortable with using scripting and using Python, deploying Python and PHP applications later on. For this purpose of our code pipeline, we are going to select Eclipse because that's the one that we've actually configured, or you can use Visual Studio as well. And we can switch tools at any time. So I'm going to go ahead and use Eclipse. So select Eclipse. And then we have our repository URL here as well. And if I click on See Instructions after I highlight the Eclipse option here, click on Skip or See Instructions here. So it gives me the prerequisite, right? So it ensures that I have everything that is required before we actually connect to the Eclipse IDE. So before we can import the project, right? So this particular project that we're creating, we will import this into the Eclipse IDE, right? We need few things. First thing is the IAM access keys, the access key and the secret key, which we already have. I demonstrated that in the previous lesson. We need the Git credentials. To use Git with our root account, you'll need to configure the AWS credential helper, which is included with the AWS Command Line Interface. So we also need the Git credentials. You can download Git, by the way, go to Git and then simply download for Windows or Mac or Linux, whichever version you're using, and then you save the credentials. But we'll come back to this because I'll demonstrate how to create the Git credentials for the user account within AWS. Let me in fact show you this. So before I move forward, let's take a look at, I'm going to open in a new tab, the services, just so that you know exactly what we're talking about here. And then go to services. Let me navigate to the user. Click on IAM, and then users. We already learned how to create a user, right? So I'm going to go ahead and click on this particular user. And then under security credentials tab for this particular user, if I scroll down, there we have the HTTPS Git credentials for our AWS code commit. Okay, so we can generate a username and password that we can use to authenticate the connections to code commit repositories. You can generate and store up to 2 sets of credentials. So we'll come back to this, right? So I just wanted to quickly show you what essentially am I talking about. Great. Let's navigate back to our code start. So connecting to Eclipse, we need these 2 things, right? And then step 1 is get the AWS toolkit for Eclipse. We can download and install from here, which we already have downloaded and installed. I demonstrated that in the previous lesson. And then we can simply import our AWS Code Star project. To do this, we just need to go to Eclipse, choose the AWS toolbar button, and choose import the Code Star project. Simply follow the wizard, and that's about it. And then step 3 is start coding in Eclipse. So within the Package Explorer, expand the tree to find your project and the files and start working on code. And step 4, of course, is commit and push changes, right? So we can open Git staging, move the files to staged changes, type a commit message, and choose commit and push. But before we actually do all of this, right? Before I demonstrate each one of these separately in other lessons, some of them I've already demonstrated, some as we move along, I'm going to demonstrate. But these are the steps, right? These are the prerequisites or the steps to connect to Eclipse. So let's go ahead and navigate, click on back so that now you understand the restrictions, right? Or the instructions rather. So you select, pick how you want to edit the code. Similarly, if I were to pick Cloud9, I can choose the cloud-based IDE, or I can choose command line tools. I can choose the video or the Visual Studio. So each one of these, whether I choose Eclipse, Visual Studio, or command line, I need to see the instructions and follow the instructions, right? Just like I showed you how to do the Eclipse integration. So since I'm not connected yet, therefore I need to go to my Eclipse IDE, right? So this is my Eclipse IDE, and we already installed the AWS Toolkit. So essentially, we need to import the Code Star project into our Eclipse IDE so that we can change the code and then start the commit process and push the code to our AWS environment. So this is the idea behind what we're essentially doing when we're starting a project in CodeStar. Great. Let's go back to CodeStar here. So I'm going to skip this for now because I'd like to show you the actual application, and then we'll come back to the Eclipse and then configure it or bring the application into Eclipse. So let's click skip, and it brings you to the CodeStar dashboard. Now this may seem pretty complex, but this is it, guys. This is the meat part of building the entire pipeline for the project. Notice at this point in time, we have a project successfully created. However, we're still waiting on connecting our IDE. But before I actually begin or move forward with the IDE, let's close. I'm going to click on close on the dashboard here. The application endpoints is the fully deployed Spring Java application. So if I were to open this link in a new tab, here's my output. So this is a fully deployed sample Hello World Java app running on AWS serverless. Okay, so let's navigate back to our dashboard. Close this for now. Navigate back to our CodeStar. So once you're back onto the CodeStar, let's click on our CD Java serverless project. That's the one that we actually created because you can create several other projects. So let's navigate to that dashboard once again. There we go. So now we have a fully deployed application. And what's more powerful about this CodeStar dashboard is that for continuous deployment, okay, not continuous integration, but the deployment. And of course, there's a difference, right, between CI and CD. So here, notice the source, the build, the deploy, the entire pipeline that we saw earlier is provided to us, right? So the application itself has succeeded from the source to build and then to deploy. I also have the option to connect to JIRA. Okay, so AWS provides default JIRA integration. So JIRA is essentially an agile, it works on an agile methodology, right? You can build dashboards or Kanban, you can use Kanban or agile methods for your software development needs. Okay, so it's a great tool, and then you can, it's free for now. You can go to JIRA's website and then create an account and connect to it. So I'll maybe demonstrate that later on as well. But on the CodeStar dashboard, kind of gives you a nice picture of your entire continuous deployment pipeline, as well as your integration with JIRA, if you're doing project management or agile project management. Also gives you the application activity using Amazon CloudWatch. And then commit history for our project. So at this point, our project is CD Java serverless running on master pipeline, master branch. And of course, I can drag and drop, as you saw, right, these tiles on my dashboard. If I click on AWS commit details, opens up a new tab, and it will provide me the details within the code commit management console, the commit for the master branch, right? So here you can actually see the commit ID, the messages, the date, the author, and so forth. And as we work more with this, I'm going to demonstrate in the next lesson. My purpose was here just to create the project and demonstrate the concept, as well as the flow of our CodeStar project, going to Eclipse IDE, and then of course working on the dashboard. So we'll come back to this, but I just wanted to show you that the code commit, once we actually start working with it, and I'll demonstrate the entire flow of our app going through the pipeline, it'll become much easier for you. Okay, for now, it just shows you all the commits that you have. Close this for now. So this is just the dashboard. So explore the dashboard that you already have at this point in time. So moving forward, I'm going to demonstrate how to connect our IDE with the CodeStar project. So I hope this helps for now. Maybe a little too much in this particular lesson, but just relax, take it easy, understand each of these things, just kind of know the concept at this point in time. So with this, let's move to the next lesson. Welcome back. Moving forward in this short lesson, I'd just like to demonstrate one important concept. Notice within our Hello World handler.java or actual application here, you notice that we have the output as Hello World, right? This is our basic app, even though I made the changes here, but go to this. There we go. So within this Hello World app, we have under our package, right, which is coming from Code Star because we imported this project from AWS Code Star so that we can work with this. If I expand all of the import libraries here, you'll notice it has JSON, it has the Lambda context and request handler. So the Lambda function, right, serves an important element of this entire process. What do I mean by this? What I mean to imply and say that Lambda functions are automatically created within AWS Lambda service. And that essentially is the entire code itself or the function itself. Let me show you. Let's navigate to our console here. And then let me scroll down here a little bit, where I can simply go to my history and click on Lambda. And this will take me to the Lambda Management Console page. And there you go. So this is exactly what I was referring to. Notice what AWS does. It creates the serverless or the Lambda function get hello world, and then the post hello world as well. Let's talk about the get hello world first. If I were to click on this get hello world, it's going to give me the details of this particular function. So this function now belongs to the AWS Cloud Formation stack, which of course I'm going to demonstrate later on. But right now I just want to show you my purpose. The objective of this short lesson is to let you know that whenever an app is created, right, the Lambda function is also created for this particular app. Not the code itself, but just that function that plays an important role. So as I scroll down, you'll see the API gateway is being created, the Lambda get hello world. If I scroll further down under function code, the deployment package of this Lambda function, large for inline code editing, which makes sense because it's about 11 megs. And then the code entry type is Java or jar file. The handler info is right here. This is the same handler info that is being imported within Eclipse. So notice this particular com.aws or the handler.hello world is the same as we saw in our Eclipse environment. And of course, we have our tags, the execute role, memory, network, bugging, and so forth. So all of this can be managed with our serverless Lambda function in AWS. The second thing I want to demonstrate is if I were to navigate back to my Code Star dashboard, you'll notice that within the CD Java serverless project that resides in AWS, if I click on dashboard, I have the option to take a look at the commit history, which is my master brand, and then there's only one initial commit at this. The application activity, pretty neat, because this shows, the graph shows that there's some commit going on, right, which is our main commit for this particular ID. And then on the right side, you'll see the continuous deployment pipeline. We still have our application endpoint. So if I click on this, you'll notice we'll still get the string JSON string output, which is hello world. Let's get back to our Code Star tab. And then of course, our JIRA is still here. We have not yet connected. So I just wanted to give you the idea that this is what our Code Star dashboard looks like. If I click on the IDE from the left navigation pane, other ways to edit project code, we have, of course, our Eclipse environment, which we've already connected to. So we don't need to worry about this anymore. You get a message here somewhere that says connect to your IDE. There should be an option where it says I have already connected. So simply click on the button I've already connected and you should be good. The rest of the options on the left side of the AWS Code Star dashboard, like code, build, deploy, and pipeline, which essentially is our DevOps pipeline that we'll be working with, opens up in new tabs, okay, that I'm going to take a look at later. Of course, also we'll take a look at the team, and then the extensions, and then project. So here's the connect tools, which we already have connected so far. If I were to click on this, notice we already have Command Line tools, or the Eclipse rather, right, that is being currently connected. I can also pick and choose a different IDE, but I'm going to demonstrate that in my next lesson. So quickly, just wanted to cover a overall overview of an important consideration, a few important tips and techniques that I wanted to cover in this particular lecture. So I hope this helps. If you have any questions, post in the discussion area. With this, let's move to the next lesson. Welcome back. I'm going to demonstrate how to connect your Eclipse IDE with the Code Star project that we create. So let's navigate first and take a look at our Code Star project. So from within services, click on Code Star. Going to take us to the Code Star dashboard. And of course, here's our CD Java serverless, right? Running the Java app or Spring Java app. I'm going to go ahead and click on this project. So we'll open up the actual dashboard. And notice we have the project created, which is called CD Java serverless. However, the IDE is not connected, right? So I have two options. I can say I've already done this, or I can use the connect tools and then go through the process of meeting the prerequisites of whichever IDE I wish to use, whether it's Visual Studio, whether it's Eclipse, or Cloud9, which is native cloud-based AWS IDE. Since I've demonstrated how to work with AWS, or rather the IDE, right? The Neon Eclipse IDE running Java Enterprise Edition. So I'm going to go ahead and navigate first to the Eclipse IDE. Currently, there's no project, right? All we did in the previous lesson was to install and connect using the AWS Toolkit, which provided us all of these AWS services. Next, what you want to do is to be able to import the Code Star project within your IDE. And the way to do is as follows. But before I actually start to import, let's verify whether we are connected or not. So if I were to, let's say, pick any of these, maybe you want to see the identity access management, right? So if I expand this, and then let's click on users, and I should be able to see the list of users. Perfect. So this user was created earlier, in one of the earlier lessons, right, as a new user, which has admin rights. So I already have a username, so this implies that the data is pulling from the AWS environment. Great. Next, I'm just going to go ahead and on the menu here, under AWS Toolkit for Eclipse, click on the drop-down arrow, and it allows me several options. I can create new projects. So I can choose from AWS Java project. I can create a new Lambda Java-based project, function. I can do a new serverless project, so forth. So since we're working with the Java app here within the Java Enterprise Edition, right, within Eclipse, it gives me all of these options. I can go to Management Console. I can open up the perspective. I can also set some preferences. So I'll let you have take a look at this and just kind of explore certain other areas. But for our purpose, I'm looking forward to import AWS Code Star project. Go ahead and click on this. This brings up a dialog box, and here's my profile, which is by default, stays default until and unless I configure additional AWS profiles. The region is important because it has to be the same region as your project that exists on AWS, okay? Many times you'll come across errors because you're not in the same region, so that's important to note. And then here's the project name. It pulls from the AWS environment. Here's the repository, which is the same name because we're using code commit, right, in AWS. We're not using GitHub. The Git credentials, you can manually copy and paste the Git credentials for the AWS commit code, or you can enter the username and password, right? If you don't have it, you can click on the link here, create Git credentials for the connections to AWS Code Commit. I believe we created the credentials for the user, right? For this particular user that you see in the background, Syed. This is the username, and we created the Git credentials. We saved the account ID and the secret, right? We know the username, so it's this username, and we created the password. So I'm going to enter the username and password. You can also import the CSV file, or you can create the Git credentials right directly from within the Eclipse environment. So I'm going to go ahead and click next. This is going to fetch the remote branches. All right, so we get this error that says transport error, right? Which means something is wrong with, or some settings are incorrect. So first things first, possible reasons are incorrect URL, which we know is okay, it's not incorrect. No network connections could be. Git is missing, maybe. SSL host, well, it's using the secure. So let's take a look at and try to identify and troubleshoot which one of these two is available. So in order to do this, I'm going to navigate to the AWS console and just verify my Git for this particular user, because that's typical, right? Typical of me. So I'm going to switch to the AWS console. Once I'm on the console, let's navigate to IAM role. So just go to security and then click on users. I'm going to go ahead and click on this particular user. Let's click on security credentials. And we did not, in fact, create the credentials for AWS Code Commit. That's why we don't have the credentials or the Git connection. Perfect. So now we can click on generate right here. Might as well do it. And then it gives me the username and password. And this username and password needs to, or the Eclipse environment, rather. Great. I can also download the credentials. So let me go ahead and download the Git credentials. Brings up the Windows Explorer. I'm going to go ahead and save the credentials.csv file. I could either use the CSV to connect from within my Eclipse, or I can simply use the username and password. Copy this password and the username, or first copy the username back to my environment. Go okay to the error, go back, and here's my username, and then of course password. I need to go back and fetch the password again from the AWS console. So I went ahead and from the AWS console, I obtained the password, right? Here's the password that I just pasted. Let's try it again. And again, before I click next, notice I can import the CSV file that we just downloaded, right? That has our credentials. So either way, a couple of ways you can do it. So I'm going to go ahead and click on next, and this time it should fetch the remote branches if everything goes right. Perfect. Here's our master branch. So we successfully troubleshooted the error right on the fly. We went ahead and we created the Git credentials within AWS for this particular user. And now we're successfully connected to the master branch. So I'm going to go ahead and click next. It asks for the destination directory for where all the data is going to be stored for this particular Code Star project. On my local computer, which is this path, the initial branch is master, and this is the only branch at this point in time because we have not created additional branches. And then the remote name stays origin. Click finish, and this should import your Code Star project or clone the Code Star project into the IDE environment. And this is pretty powerful because now as developers, right, we can work with the Eclipse IDE alone. The secure storage password hint is needed. So a master password was created within the Eclipse secure storage. If you ever need to recover your password, you need a password hint. Do you want to provide a password hint? Sure, why not? So I'm going to go ahead and click yes. And then the question one is, what is my first car? And the answer is second question that I need to create because I'm really high on security, guys, okay? And this just simply is added level of security. you can say no to this. And notice our project has been created on the Project Explorer as it's processing. So it's connecting, it's fetching all of the repositories, cloning, in fact, the repository from code commit from within AWS to your Eclipse environment. Awesome. Congratulations. So we have finally been able to successfully import our Code Star project. It gives you a couple of warnings that you can take a look at. Just overriding managed services, right? For the JUnit Java, right? On the pom.xml file. But we'll take a look at that later. Not to worry. Right now, on the left Project Explorer pane, notice we have our under source, main, Java, and then AWS Code Star. Expanding all of these, right? And we have all of these files that have been successfully cloned. So this kind of gives you an idea of how to integrate Code Star import into your AWS environment. You can also take a look at the artifact, tilt group ID, the artifact ID itself, which is Hello World. This is our sample app, the name of the project itself, and then certain other properties that you can also take a look at. And this is again the pom.xml file, which gives you the additional details. If you were to take a look at the template or other files, you could do so as well. So let's take a look at our application itself and where it resides, right? The Hello World application that we're looking at here within the XML file. So let me go ahead and open up our source.main. Here's our packages. So under the application.java, so here it is. So I'm going to go ahead and click on the application.java, and this is the actual sample app. So now all of this is simply the Hello World application. It's a public class application, which is the standard. If I expand the application, here's our public static void, and then of course our Spring application itself. So this gives you an idea of how to import your actual CodeStar project into AWS. I can also expand the Hello World handler.java file, and I can take a look at that and see the output. So now if you were to change, let's say, the output itself to Hello World to say something like Hello AWS World and run the application. So as we move along, I'll demonstrate how it pushes the code back up to the AWS environment. For now, just understand the concept, the application of bringing a CodeStar project into Eclipse IDE. So I hope this helps. Practice with this. If you have any questions, post it in the discussion area. I'll be glad to help. And with this, let's move to the next lesson. Welcome back. Super excited moving forward. In this lesson, I'm going to demonstrate how to create additional branches within our Eclipse IDE. But first, before I actually begin, let's navigate first to our CodeStar dashboard and just kind of take a look at the existing infrastructure or whatever is available at this point in time as far as the branch is concerned. So let's navigate to our services. Let's click on CodeStar. From the dashboard, I'm going to click on project called CD Java Serverless. This is our Spring Java app running on Lambda. So once I'm on the dashboard, if I scroll down, notice we have the commit history for this project is currently on the master branch. So the master branch has several commits that I've done earlier. And of course, we have our pipeline on the right side. It's deployment pipeline source, build, and then deploy. Notice there's a release change button, which essentially is that if you want to release the changes that developers commit and you want to release them manually, okay? And that's really the difference, so to speak, between CI and CD. So continuous integration involves the actual integration of the pipeline, but continuous delivery is end to end from commit to deploy, okay? So the release is where it happens where you wish to manually release a change, okay? So So I just wanted to clarify that. Coming back to our branch, right now I have a master branch and I also created a test branch. So if I were to click on test branch, notice the commit history would change. In other words, it's just a version, right, of the actual from the master branch. I've just created another version. So the branch is essentially the concept behind, briefly again, probably are already aware, but it's just version control, okay, of your app. So if you have, let's say, tons and tons of developers working on this particular app, you may have, several branches that you're monitoring. As a DevOps engineer, you're taking a look at it. And then, of course, you also have the QA team having their eyes on the particular processes. So they're also taking a look at the code itself. And if there's an error in the code, they're doing some test integration. They're doing the test runs. They're doing the unit testing. They're also doing the load tests and so forth. So I'm going to go ahead now, navigate to the Eclipse IDE. You can create branches directly from the Code Star dashboard, by the way, or you can create it from the IDE as well. Since we are more concerned with developers, I'm going to switch to the IDE and then we'll come back to this. And then I'm also going to demonstrate the code commit, right, from the source to deployment and how that works. Great. So let's navigate to our Eclipse IDE. There we go. So within Eclipse IDE, you will notice that I have an option of the console here called Git Staging, right? So this is the area where we can actually take all of our apps that we actually create, or all of the applications we create, and then we commit to the staged area. So once they're deployed to the staged changes, we can simply provide a commit message, and we can either commit and push or commit. So two options that we have. The difference, of course, between these two, the option to commit only or commit and push, simply implies that if I were to just choose commit for a particular change, it'll only be committed locally, right, within the Eclipse IDE, for instance. Whereas commit and push is actually going to commit and push the code up to the AWS server. So that's the difference between these two. So let's go ahead. Let me demonstrate first. In this lesson, I'm going to demonstrate the actual creation of a new branch. So right now we have a master branch. So if I right click on the project itself and scroll down to team, and notice I'll see a whole list of menu. This is basically a menu that the Git client offers within the IDE itself. So here I can navigate to, let's say, let me find the branch here, switch to, perfect, there it is. So I can either create a new branch, and notice my existing two branches show up here, master and test. Currently master is dimmed out because looking at it, right? So if I were to click on test branch or switch to the test branch, now I've automatically connected or shifted to the test branch. And then also my project displays the branch name as well, which is test. With that, you'll also notice that certain changes are also made, because if I have different version of applications running on the test branch, they will show up here, okay? And then on a master branch, we'll have its own set of applications. So let's navigate back to our master branch. So right click, go to team, switch to and master. Great, so it changes. If I need to create a new branch, and then of course deploy another version of my application, that's fine. So let's go ahead and do that. So I'm going to go ahead, right click one more time. Let's go practice. Let's go to switch to option and then click on new branch. This brings up a dialog box and simply allows me to enter a branch name. So I'm going to call this test2. Could be any name. You could call it as per your own requirement, right? Based on your own project. So I'm going to check out the new branch, which is by default checked out. Then the source remains the master. I'm going to click finish. And this is going to go ahead and create the test2 branch that I can see next to my project itself. And I can also see within the Git staging area. Okay. So now if I were to, let's say, create a new Java app, or new file. Right click on new. I'm going to click on class. So I'm going to give this a name. I'm going to say hello world 2. Click finish. And this creates the hello world 2.java. Okay. So for instance, I'm just going to do a sample app here, the hello world one more time. Okay. And then change the name here so it matches the name of the file. Perfect. And call this 2 as well. Great. So we can identify. Do a Control S to save it. So now I've just created a Java file, and I'd like to commit to this test2 branch, right? Or use this particular branch. So Git staging is found under team, right? The same menu option. So if I right click, for example, team, notice you can use commit option here. So for instance, if you do not have this, by the way, so close this for now, just so that you can see, I can bring this by right clicking the project, go to team, and then click on commit, and this will bring up the console itself. Great. Make this bigger. So now within the project itself and the test2 branch, I'm simply going to drag and drop the new file that I've created into the staged area. Provide and a commit message, that could be anything. So I'm going to send new hello world 2. You can also enter a default change ID, which is something like this, right? Just change ID 1000, or you can provide your own IDs. Similarly, you can also add the signed off by the username itself. Okay, so it's up to you. I'm going to just leave the message here for now. So it's new hello world 2, which is the commit message, and the file is hello world 2 running on the test2 branch that we created. Now notice this is strictly right now in the IDE itself. It's not, nothing is happening on the AWS side at this point in time. Let me go ahead and click on commit and push so you can see the changes being pushed to AWS. So I'm going to go ahead and click on commit and push, and this is going to bring up a dialog box. It says push to branch and remote. That's exactly what I would like to do. Here's the remote, branch is test2, looks everything good. If I need to do a pull request from the actual AWS dashboard, I can do it either merge or I can use the rebase or a couple other options as well. So we're going to leave this as merge and click next. And this is going to go ahead and start the process. Just give me a quick push confirmation that this is the new branch. Let's go ahead and click finish. And at the bottom, you'll see it's actually pushing to AWS. If I were to navigate now to my console, there we go. So you are going to see some changes here being deployed as changes are being pushed to Code Star itself. So we're just going to give this a few seconds. Sometimes it takes a minute or so. Right now, I should see my test2 branch. Perfect. So let's navigate to test2 branch here. Here's my hello world. Awesome. So congratulations, you've successfully created a branch within your Eclipse IDE, and you have created a Java application or Java file, and you've pushed the actual code called hello world 2 to your AWS Code Star. Perfect. So now I can in fact navigate to the actual commit itself and look at the details. As soon as I click on this, this is going to take me to the console page of commits where I can see the actual commit itself. So notice within the source, which is our first phase, right? Besides build, deploy, and code pipeline, the commit is where I can see the actual commit, which is about a couple of minutes ago. I can see the actual code of the Java file. And the neat part here is that I can place comments on this file. So you can click on any of this line that you wish to place comment. So for instance, I can comment here and say the heading, okay, and other comments as well. You can also use the markdown. So markdown works with something like, quickly demonstrate. So if I do this in asterisk, it's going to italicize, right? a couple of things that I remember. So if I click on Preview Markdown, notice now my text is italicized. Great. So once I can place a comment here, I can click on Save. And this is going to go ahead and save. So that way, the commits area within code commit keeps a tab or track of your entire change. Great. Let's go back to our Code Star. There we go. So now you know how to create a branch from within your IDE, right? And then name a branch and then push the code to it. And on the right side, notice the continuous deployment pipeline, by the way, in the meantime has been running. And from source, it's now actually building, which has been succeeded, and finally is going to deploy. Pretty powerful. So once again, congratulations on actually running through the entire piece of code, creating a branch, and then pushing it to the code start through code commit, build, and then deploy. So once this is all deployed, you can click on, for example, on the build option from the left navigation pane and just view the details of the build stage. So here, for instance, I can take a look at the build history, which provides a list of all of the builds that have been conducted. Okay. I can also take a look at the build details, which is the project configuration, the source, the environment, specs, the artifacts, and so forth. Similarly, the account metrics is also part of the build area where I can identify the build metrics. So as DevOps engineer, you need to take a look at what's taking too long. For example, there's certain developers who are committing code and it's taking a long time in build area, right? Or build stage. So you need to go and take a look at these metrics and identify succeeded builds, failed builds, the durations, and so forth. Similarly, you can go to the deploy option or the deploy stage and take a look at your deployments. So each of these stages, right, gives you additional details for your application. So if I click on application under the deployment stage, currently there are none at this point in time. If I click on pipeline and click on pipelines again, you will notice we have our project pipeline here. So if I click on this particular pipeline, this is going to give me the details of this particular pipeline. In other words, it starts with the source, uses AWS code commit, uses AWS code build for the package export, and then for the deployment, it uses Cloud Formation, which is the template that actually runs in the backend. And then finally, it executes the change set. So that way, you can kind of take a look at the entire pipeline. The history under pipeline is also very helpful. This gives you a detailed history of the ID, status, source revisions, the duration, right, for each of these commits and builds. So that way, you have, if you're running an application and you're managing different applications from different developers all across the world working on this application, this is a good way to take a look at it. It also shows you if something failed, right? And it will tell you what failed, and you can kind of take a look at this, what actually failed and what happened. So the entire pipeline is a pretty powerful tool, and it allows you to manage as a DevOps engineer. So I hope this helps. If you have any questions, post in the discussion area. I'll be glad to help. For this, let's move to the next lesson. Welcome back. In this lesson, I'm going to demonstrate how to add additional team members to your CodeStar project. So fairly straightforward, so I'm just going to run this through fairly quickly just so that you have an understanding and also the application area. So from within the CodeStar dashboard, right, in order to get to CodeStar, just go to Services, click on CodeStar, right? So once you select your project, you could have multiple projects. Each project could have different team members working on it. So this CD Java serverless app is running, it's a Spring Java app, which is running serverless Lambda. So I'm going to go ahead and click on dashboard for this project. As soon as I am on the dashboard, on the left navigation pane, notice there's an icon called team. So let's go ahead and click on team, and here I can simply add a team member to this particular project, because as maybe a project manager or DevOps engineer, you're ensuring all of the project team members are working on the project team itself, and all of the code that's being committed to the pipeline is working efficiently. So let's go ahead, click on the add team member. You can simply select the user. Currently, I believe we only had one user, right? So that was myself that we created earlier. So I'm just going to go ahead and select this user. You could create a new IAM user here directly. So let's go ahead and choose one, because I'm just going to demonstrate this. You can type an email address, that's optional for this particular user. The role that you wish to provide this user, whether it's a viewer, contributor, or so for this project, you can identify one of these. You can also specify remote access for this role, for this particular user, if need be. So I'm going to go ahead and give a owner role for this particular user. Click on add, and this will simply add this user. So that's really all to it. As long as you have a bunch of users who are part of this project team, they could be developers, these could be architects, infrastructure, business analysts, QA testers, and so forth, right? So you can manage your team members here as well. While we're at it, if you click on extensions, right, there are a couple of extensions that are available to us. One is GitHub. You could use GitHub issues and track from GitHub, or you can use the Altagian and JIRA that I mentioned earlier as well. So both of these can be used to track issues and also manage your project. Typically, it's the JIRA at the enterprise level you use to do the project management. In fact, do agile project management. And that's pretty helpful if you integrate that tool as well. So just quickly wanted to demonstrate the concept of teams and extensions. If you have any questions, post in the discussion area, practice with this. Let's move to the next lesson. Welcome back. Super excited. In this lesson, I'm going to demonstrate how to switch your Eclipse IDE, the Cloud9 IDE provided by AWS. Cloud9 IDE is a cloud-based IDE offered by AWS as a service. So let's jump right in. Scroll down first. Let me first show you where Cloud9 resides. So right under Developer Tools, we see that there's an option called Cloud9. If I were to click on Cloud9, this will take me to the dashboard. However, since we already have a Code Star project that we started, we need to go to our Code Star console and then connect to this cloud-based IDE. But here, the homepage or the dashboard for the Cloud9 just gives you additional details. So it's a cloud IDE for writing, running, and debugging code, which is pretty neat because you don't need to connect to third-party tools anymore. You can use, it's a fairly new service, so you can use the Cloud9 to directly run code on the cloud, which makes life easier for developers as well. But most developers are used to either Eclipse or other tools for writing code. But here's how it works. The Cloud9 development environment on a new EC2 instance or connect it to your own Linux server through SSH. Once you've created the environment, you can then have immediate access to the code editor that Cloud9 provides, integrated debugger, built-in terminal, and pre-configured AWS CLI, all within your browser. And that's really the power of using the Cloud9 AWS cloud-based IDE. So we're going to take a look at this. We're going to connect to our Cloud9 with our project in CodeStar. And as a homework, just read through some of the benefits and features of Cloud9. Maybe future developers will start using Cloud9, and I'm sure powerful and well integrated with all of the AWS services. Great. So let's navigate to our Code Star project. So within services, I'm going to go ahead and click on Code Star. Here's our project, CD Java Serverless. This is our Spring Java app. Let's navigate to the dashboard. From the left navigation pane, what you need to do is click on IDE. And here's the integrated development environments. We fall under the other ways to edit project code because we have integrated Eclipse so far. And again, we can switch, right? We can switch any point in time. So I'm going to go ahead and click on Create New Environment. And for this, we will need to use the default VPC and the instance, right? So let's go ahead, create a new environment. The recommended instances are provided. I can always choose other types of instances, but I'm going to stick to the recommended instances, and free tier eligible instance is available. So you like to make sure that you don't use up the hours, right, within the day when you're using the T2 micro instance. So make sure this is selected. There are additional settings like network settings, advanced, shows you the default VPC, the subnet, the environment name and description is the same as the project name, description. And then of course, cost saving settings is also available. This is something that you can change, otherwise it's going to shut down after 30 minutes. And this is so that to prevent unnecessary charges, because you're using the cloud-based IDE, and there are certain charges attached to it. So you can say after 30 minutes, 1 hour, week, never, and so on. I'm going to leave it 30 minutes because essentially we're using Eclipse as our IDE. So once you have all of these settings, click Next. And this brings up to our dashboard itself. And then I can click on See My Environments to see how things are connected. Once I click on the environment itself, notice it's still spinning up the new environment. It's going to take a few minutes or so to spin up the environment. Once the environment has spun up, we should be able to open up a tab and then use the editor. Perfect. So if I were to expand all AWS Cloud9 environments in this project, notice I will see the CD Java Serverless project, EC2 type instance, and the description is created from Code Star. If I click on Open IDE, it's going to open up a new tab, show us the actual editor provided by AWS. Gives you some tips and techniques, right? Every time you open a tab, it's going to give you a nice tip. So here's AWS Cloud9. Welcome to your development environment. Congratulations, you are now successfully connected to the cloud-based IDE. Create a new file, open files, upload files, and on the bottom here, notice it gives you the CLI or command line tool where you can run the commands as well. So this is your shell, SSH shell, and here's your bash. So here's our project itself. Notice same files. We still have the pom.xml file, the template.yaml file, and so on. So that way you can use this environment if you need to. If I scroll down, you can configure, you can provide some support, take a look at certain other options such as theme editor, keyboard mode, main theme. Take a look at the Lambda functions. You can create or import functions. On the right navigation pane, you can collaborate, outline, take a look at AWS resources. And of course, the debugger is also part of this. So fairly new environment. You may not be used to this at this point in time, but as DevOps engineers, you kind of need to know exactly that you have options, right, to use any one of these. You can click on the settings option here and explore the other settings or change the settings as well. Close out of here. So I hope you get this idea, right? Using the AWS Cloud9, you can either, if you're comfortable using on the cloud environment, go ahead, use that. It's pretty secure. If not, you can stick to the third-party tools as well. And you will notice on the left, Project Explorer, right, looks pretty similar. If I were to expand the source folder, it opens up all of these folders. It's bigger, and here's our application.java. If I were to double-click on this, it opens up the exact same application that I have within my Eclipse IDE. Hello, here's the application.java file, right? So this entirely same sort of environment is now available to me within the cloud. Pretty powerful. So hope this helps. Practice with this. If you're comfortable using this, more than welcome to. You can use this particular IDE, or you can use Eclipse as well. Of course, the benefit of using the AWS Cloud9 is that it's fully connected, and it's actually a service itself coming directly from the AWS console. So practice with this. I hope this helps. If you have any questions, post it in the discussion area. I'll be glad to answer. For this, let's move to the next lesson. Welcome back. Super excited. Moving forward, in this lesson, I'm going to demonstrate how to configure your Altasian JIRA. So from within the Code Star projects that we've been doing so far, let me first jump right in and navigate to Code Star. This will bring us to the Code Star Management Console page. And you'll be able to navigate and see various projects that are listed at this point in time. So at this point, it seems like I have 3 projects, right? And then I'm going to go ahead and just pick any one of them. So let's go ahead and click the Java Web App Bean project. So once you're on the project page, if you scroll down all the way to the bottom here, you'll notice there's an option for connecting to JIRA, which allows us to track work items and issues for the CodeStar projects. You could also access by navigating to the left side where it says extensions. So either way, you can either go to extensions and navigate to JIRA, or you can connect directly from the project page. So I'm going to go ahead and click on connect, and what this will do, it'll bring up a page, will give me steps, for about essentially 5 steps before I can connect to the Altasian JIRA or integrate this with our CodeStar project. So notice you first have to log into JIRA. If you have an account, that's fine. If not, then you can simply click here to get started, and then it'll walk you through the account creation process with Altasian JIRA. Second step is adding the integration itself. Third is creating the application link in JIRA. And then 4 is configuring incoming authentication. And then, of course, finally, the connection itself. So the first 2 steps are listed here. In order to obtain the JIRA URL, we, of course, first need to create the actual account. So I'm going to walk you through this fairly quickly. So let's go ahead and click on Get Started here. This will navigate us to the sign up page for the Altasian Cloud. I'm going to go ahead and just give this a name. I'm going to call this ClayDesk. And if it's available, it's going to give you the green checkbox or check mark. And then, of course, the name, email address, give it a password. Click on this I'm not a robot box. This is just CAPTCHA. Click on verify. And then finally, click on agree and sign up, right? So this is going to go ahead and give you this particular site or create this site for you. Next step is to check the inbox, right? Because it's going to verify the email address. So I'm going to navigate to the Gmail account here. So what I've done, I went ahead and actually logged on to my Gmail account. And once you're in the inbox, you will get an email that looks something like this. Get started on something amazing. So just scroll down. We'll just say congratulations. ClayDesk.Altasian.net is all set up and ready to go. And then all you have to do is just click on Start Working Smarter. It'll take you back to the Altasian page. And I can continue to log in as the email address here. So I'm going to go ahead and it's going to verify. And of course, once verified, it's going to log me onto the Altasian platform. Great. So notice that I have a URL, right? That's right here, ClayDesk.Altasian.net. Just a welcome page. So I'm going to say I'm experienced with JIRA. My team is experienced with agile methodologies. We spend our time working on, let's say, features. We have a flexible schedule. Go ahead next, just a bunch of questions. And then I can simply select different templates that I need to do so. So the recommended template is the Kanban, which is Japanese word, right? That relates to agile team. So this is your main page. So very briefly, the Kanban allows us to monitor work in a continuous flow for agile teams, whereas Scrum manages stories, tasks, and workflows for Scrum teams. And then bug tracking manages a list of development tasks and bugs. So if your goal is to track bugs for the AWS projects, Code Star projects, you could choose this, or you can choose Kanban as well. So I'm going to go ahead and, in fact, select the Kanban here. And it says enter the project name. And I can specify a new project. So I can say something like CD Java JIRA. And then, of course, click create. And this is simply going to go ahead and create the project for me. This is again based on Kanban, and you can go back and create the bug tracking as well. So the agile board is now going to be displayed within this particular JIRA page. Great. So I have the interface of JIRA itself. What I'm going to do is I'm going to navigate back to AWS and try to connect to my project. Okay. So let's go ahead and navigate to the AWS Code Star tab here, back to the Code Star, and our project is Java Web App Bean. So in step 2 is, of course, paste the URL. So I'm going to go ahead and paste the claydesk.eltagian.net. So once I'm on my AWS Code Star console page, in step 2, I would like to paste the JIRA URL into the box below, which is right here. So you would do the same, click next, and if I scroll down, step number 3 is pretty straightforward process, by the way. You just create the application link in JIRA. So I'm going to go ahead and first copy the Code Star URL because I would be needing this once I'm in the Management Console. So I'm going to go ahead next and click on the JIRA Management Console link. This is going to open up and bring me to the Applications or Configure Application link. Go ahead and paste that URL and click on Create New Link. So essentially what we're doing here is we're connecting our Code Star project to JIRA. So the dialog box appears and says no response was received from the URL you entered. And of course, you will not be able to get response at this point in time because we have to configure certain secret keys and public key and so forth. So I'm going to leave the URL as it is, click on continue. And here you can link the applications, okay? So if I scroll down on this dialog box, you'll notice there are several fields that I can use. So here's my application URL, the application name that I need to input, which is Java Web App Bean. It's the same name as I'm using in Code Star. And we'll leave it as generic application, although if there are other options as well. So we'll leave as generic application. And then scroll all the way down and make sure that you select create incoming link. If you do not check this box, it's not going to work. Okay, and of course we can come back and fill these details later as well. So I'm going to go ahead and click continue. So this is where I would, in the next screen, enter the consumer key, consumer name, and then the pub. So let's navigate to Code Star. Let's bring up the 3 things, consumer key, name, and pub, right? So this is step number 4. Just going to go ahead and copy. Here's my consumer key. And then, of course, do the same with consumer name. And then I'm going to do, finally, the public key as well. Perfect. So let's click on continue. And this is going to process and then let me know once the configuration has been completed. Great. So our application link, Java Web App Bean, has been created successfully. So let's navigate back to Code Star. Let's scroll down all the way to the end. And if I click on connect, this time it's going to bring up the page where it's going to say, welcome to JIRA, the application AWS Code Star would like to have read and write access to your data on the JIRA URL. And the application will be allowed to use the credentials to authenticate ClayDesk as you in the future. So I'm going to go ahead and click on allow, and you should be able to get this page, by the way, and this will link your JIRA to the Code Star project. So it's pretty straightforward, but important, because now if I scroll down, you'll notice that it'll say connected to JIRA, or it'll just say open in JIRA, and I can create issue, right? Perfect. So in this lesson, I just wanted to demonstrate how to integrate the third-party JIRA Altation, which essentially uses the agile methodology practices, and you create issues now and manage them in JIRA. If you have any questions, post in the discussion area. Be happy to answer. With this, let's move to the next lesson. Welcome back. Super excited. Moving forward, in this lesson, I'm going to demonstrate the cloud formation and how to build up a stack, also work with a designer. And I'm going to be using a really simple example. The idea is to give you the flavor, the concept, as well as demonstration of how cloud formation works, right? What templates are. I have been mentioning templates like YAML or JSON written templates that you can use to deploy all kinds of solutions right from a text file, right? Written in YAML or JSON. So I'm just going to talk about the cloud formation, and then we'll jump right in and do a demo. In fact, I'm going to do hands-on, might as well. So let's jump right in. From within the AWS console, what you need to do is find the management and governance section. And within the management and governance section, you will see the cloud formation. Now we have been working with, if I scroll down just a bit here before I begin, the developer tools, right? So we've deployed several applications, so you should be pretty comfortable with the CI/CD pipelines and all of the related concepts, as well as the applications, because we've deployed about 3 different kinds of applications, serverless and with Beanstalk as well. And we've also taken a look at the IDEs as well, such as Cloud9, which is native AWS IDE, and Eclipse as well. Perfect. So let's scroll up. Cloud Formation is just another way of deploying your entire solution, right? So let's click on Cloud Formation. This will take you to the Cloud Formation console page. And notice they have AWS has redesigned the Cloud Formation console. Okay, so if you've been using AWS in the past, you may see this a little differently. This is the newest version that we have at this point in time. Also, drift detection is now available. So what is drift detection? It simply allows you to detect whether the actual configuration of your particular stack has changed outside of CloudFormation or not. So for instance, you created a stack and then some changes were made to that particular stack or the files within the stack. So detect or drift detection will simply allow you to detect this. Now this is not available for all of the resources, okay? For instance, here are our existing stacks available, and notice we have our Elastic Beanstalk Java web app running on Elastic Beanstalk. This is our Spring Java app. We have another Spring Java app, but this is running on the serverless Lambda, and then we also have our PHP project. So all these are web apps that we have created for our code pipeline, and all 3 of these are running a complete fully automated CI/CD pipeline. So within the stack, for instance, you'll notice the drift status here shows whether a stack has been drifted or not checked. So any status message that says not checked is out of scope essentially for drift detection, because it only allows you to detect the resource types that support drift detection. Let's take a look at those. So if I were to just navigate, hover over the status, and then choose or click on resource type, it's going to open up the documentation for us. And AWS provides the resources that support drift detection. And the following do support drift detection. And the reason I'm going through this is, of course, not from the exam perspective, but as DevOps engineer, you kind of need to know where to go and find the services that support. So we have the API gateway and all of the available resources. We have auto scaling that supports Drift. We have Cloud Trail, Cloud Watch supports Drift, DynamoDB, EC2 instance, Amazon ECS, load balancing, IAM, IoT Lambda also supports Drift, and then your S3 buckets and so forth. So these are just a small list of all of the services that actually support the drift detection. So keep this in mind. Great. So let's close this for now. Notice here we have not checked, right? So this means this stack is not detected by drift itself. So even if I were to have it run or detect drift, it's going to give me this warning, right? So it says it's drifted because things have changed, even though it's not supported. Great. So let's get back to our cloud formation. So I just wanted to clarify some of the basics here. Now to create a stack, a couple of ways you can do it. You can create or go to design template directly. In other words, do everything manually. Or under create stack, you can either create a new stack or you can create a change set for the new stack. So a change set is the same stack, but you're going to make some changes and then deploy it again. So let's go ahead and begin by creating a stack. As soon as I click on it, the first option is select a template. I'm going to specify the details next, choose some options, and then review before I actually begin to or actually create the stack. So select the template that describes the stack that you want to create. So what you need to do is two things that you can do. You can design a template. In other words, use AWS Cloud Formation Designer to create or modify an existing template. Or you can choose a template, of course written in JSON or YAML formatted text file, that describes the stack's resources and their properties. In other words, the configurations, right? So I could choose a sample template. If I click on the drop-down arrow, notice I have several options for a sample template. For instance, I could deploy a single instance sample on a WordPress blog that would deploy a WordPress blog for me right from this particular formatted text file written in JSON or YAML. Typically it's JSON, but you could convert it to YAML as well. So before I actually use the design template and we create our own simple custom template, let's go ahead and select WordPress blog just so that you can see the entire blog in Designer. The other options, by the way, before I click on this link to get to the Designer, you will notice that we have upload a template to S3 or specify the Amazon S3 template URL. That is if you have these options. But since we do not, I'm going to go ahead and just first show you the template designer for this WordPress blog. So I'm going to go ahead and click on this. And this is going to take us directly into the designer view where you would actually see all of the icons and the actual picture workflow, so to speak, that will do this for us. So here's the designer. I can, of course, make it bigger or smaller, the wheel on my mouse, or either way. So you'll notice that you see several dots, right? Next to this, we have a web server instance, and then we have a web server security group. And then on the bottom section, you'll see the template, right? Template has two tabs. One is components, for instance, and then the other one is template itself. And then on the resource type, the left navigation pane, we have all of these different resource types that are available that allow us to actually build our template, right? So I can drag and drop any one of these options onto the canvas and then start to link and design my own solution, right? And as soon as I make some changes on the canvas area, you'll notice the template is automatically updated. But before I actually drag and drop and demonstrate, let's take a look at and identify what these circles mean, right? So for instance, if I hover over any one of them, it will tell me the property, which is the security groups ID for this EC2 instance. This one is the property volumes. Then I have the image ID. I have the placement group. I have the EC2 host property, volume attachment, and again, I should be able to see all of these properties on the bottom here as well. Okay. For instance, the instance type here is the web server EC2 instance type, and that's the name of this. If I need to change this, for example, if I need to say web server ClayDesk instance type, the message that I get is designer is out of date, hit refresh, right? So all I do is just go up right, refresh the diagram, and this should change the name. So once I have this, I can, of course, by the way, drag any of these options anywhere on canvas area. And I can also link or unlink. So if I were to remove this link here, simply a dialog box appears. Are you sure you want to delete the link? I'm going to say OK. And if I need to create the link, I can simply go to this purple, right? A little magenta circle, not the blue ones, because blue ones are all properties. So I can simply say the web server depends on the security group. That's one option. I can remove this link again. Similarly, I can drag and say the web server security group depends on the web server. So you get the idea, right? You can design any options that you wish to. Refresh one more time, and we get back to where we were. Great. So once the links are created and based on your own requirement and you're satisfied with the template itself, you're good to go. So here, I can change the name of the web server, for example, for this property. Say ClayDesk web server, hit refresh, and this should, by the way, change the name. Although I get a message, specify a resource name, logical ID that contains only alphanumeric. So go ahead, refresh, and there we go. I just need to remove the spaces. And two formats are available. It's a little bigger so you can see the actual template, JSON or YAML. If I click on YAML, AWS will automatically convert the template to YAML format. Here, I can now scroll up, and it shows me that this is a template for the WordPress single instance blog that is going to be deployed. And it gives me all the parameters, instance type. If I scroll down, I will get the SSH location, DB name, DB user, DB password, DB root password. Once again, everything, all the areas that you need to deploy a WordPress blog are part of this template. You can, of course, write the entire template from scratch. You have certain developers or yourself, you're good at it, then go ahead. You can design the entire template based on your own requirement. Again, this is a template, right? So you need to, of course, make the required changes for you to deploy your own solution based on your own requirements or your company's requirements. Perfect. All right, so this is how you deploy a WordPress blog. So once you're a designer, and if you're satisfied with this particular design, all you would have to do next is to create the stack. So if I were to go ahead and create the stack here, it's going to take me back to Cloud Formation. It's going to begin the stack formation. If the template is not valid, for instance, you will get a message. This is undefined resource web server. So click OK. And then you can correct the required area where it says undefined web server. So let me go ahead and scroll up. In order to fix this, I believe I changed the name, right? So let me go ahead and quickly change it back. So I'm going to go ahead and navigate to the actual change. And since it's looking for the web server, the original name, I'm going to revert back to that. Hit refresh. And then another thing that you can do is validate the template before you can actually start creating the stack. So if I were to now click on validate this particular template, I'm going to go ahead and provide the validation for me. So now our template is valid. I'm going to go ahead and create the stack. So if I click on the create stack button, this is going to go ahead and launch and create the stack. It's also going to redirect us to the same page, right, where we actually selected the template in the first place. And this time it gives me the URL, right, for the fact that I need to specify an Amazon S3 template URL. So I'm just going to copy this for my own records and then click next. And then I can provide a stack name. I can provide the necessary DB name, password, for instance. So I can say WP ClayDesk blog, for instance, and then provide a password. Here's my root password, the DB user, and another name. The instance type is T2 small. I can choose others as well, right? This is our web server EC2 instance type. I can also provide the key name. So this is our key pair, right? So if you don't have it, you can always navigate to the console and create a key pair. So I'm just going to use the PHP web app key pair that I've created. You can also provide the IP address range if you have specific to your own project requirement. So you can SSH into and then use the EC2 instances. So I'm going to go click next for now. You can choose the IAM role that Cloud Formation will use to create or modify or delete resources in the stack. And if you leave this blank or do not choose a role, it's just going to use the default permissions for your account. The rollback triggers enable us, the AWS Cloud Formation, to monitor the state of the app. So if something doesn't go right, it's going to roll back all the changes. You can also choose CloudWatch. I'm going to talk about this a little later as well, where you can set triggers, create rules, and so forth. So I'm going to go ahead and click next. You can review all of these options before you actually begin to create. So I'm going to go ahead and click create, and this is going to create the stack, but of course we get an error. It just says that DB password needs only alphanumeric, right? And I use symbols that were not alphanumeric, so I can go back previous one more time. And then here's my DB password, so I'm just going to use alphanumeric, right? Let's try it again. Next, and then create. So this is going to go ahead and create our spin up our stack for deploying the WordPress blog. So it's really a straightforward process. What you can do is you can kind of take a look at, once your stack is ready, it's going to show up here within this area. And I can refresh just to see that our WP ClayDesk blog, which is right here, has been created and it's in progress. Okay, so Cloud Formation is a pretty powerful area where you can actually spin up your solutions based on your own templates. Now, of course, we use the existing sample template, right? So I quickly demonstrated this. In the next lesson, I'm going to demonstrate the manual way of designing your own template. And I think we're going to do an S3 bucket, just a fairly simple example. But this gives you an idea of a full walkthrough of simple deploying a ClayDesk blog using Cloud Formation. Now, before I end, of course, I can click on this ClayDesk blog and take a look at all of the details, right? The good part that you need to know as DevOps engineers, that you can click on output, you can click on resources, right? And then events is nice because you can see exactly what is happening. If something goes wrong, you will see rollback, right? And it's going to delete all of the steps. Template is what I would like to have you take a look at. This is the template that was actually used to create this entire solution, which is deploying a WordPress blog on an EC2 instance. So if you look at this template, it's still the JSON format that you can take a look at. Here's our DB name, right? Here's our DB user. Here's our DB password. And the reason why it had us change the alphanumeric, because it only allowed this particular pattern, right? For our passwords right here. Sorry, here's the password. So allowed pattern is A through ZA and then Z0 to 9. So it's alphanumeric. Here's our root password, right? Settings. And then of course our mappings. And if I scroll down, you'll see the rest of the settings within this template. Now again, if you were to design this template manually, or just copy this template and throw it manually into the designer and create a stack, you'll get the same thing. Okay. So this is where you can deploy how you would deploy a solution for you. Now, quickly before I end this is change sets, right? You can create a change set. Once again, change sets are if you need to make some changes to this and deploy it again. So for example, if I were to click on create one, or maybe I'll demonstrate this later. For now, just leave it like this. Understand what is happening when you create a stack. Once the status is complete, I can go back to stacks, and then notice it says create completed. And at the bottom, I have all of these different tabs for this particular stack. So here's the overview, then I have the outputs, and here's the website URL. So if I were to click on this, I should be able to get my WordPress welcome blog, right? Perfect. See how easy it is to deploy WordPress on AWS using Cloud Formation? Few steps, guys. That's it. So now I can, of course, continue on from here, and it's going to create my WordPress blog running on Amazon Web Service. Great. Let me close this because we're not going to create the website here. Just wanted to demonstrate. Let's go back to our Cloud Formation. So this is our output, right? And then we have our resources. A web server is being used, and of course the web server security is being deployed with this security group. I have my events, and this is my event log. Make it bigger. So it gives you the time, status, type, logical ID, and then of course the status reasons as well. Here's our template. Once again, I can view and edit the template in Designer. So if I click on this link, it's going to take me back to the Designer, and I can of course change the template, or I can change any of these parameters and redeploy. So I can click on parameters, I can click on tags, stack policy. Here are the change sets, right? So if I need to create a change set for this stack, I could do so. And then my rollback triggers. Great. So congratulations, you've successfully deployed a WordPress blog using Cloud Formation in a matter of minutes. So practice with this. Hope this helps. If you have any questions, post in the discussion area. I'll be glad to answer. And with this, let's move to the next lesson. Welcome back. Super excited. I'm positive you guys are learning and finding this course valuable. Please leave a review. Positive review would be appreciated if you're finding this course engaging and you're learning something out of it, right? Great. In this lesson, moving forward, I'm going to create yet another project. This time, we are going to deploy maybe a PHP application, a web app based on Laravel PHP, using Elastic Beanstalk, and of course, using the entire code pipeline. So let's navigate to our Code Star. So I'm going to go ahead and click on the recently visited services, which is Code Star. Once you're on this dashboard, notice we already have our Lambda serverless Spring Java app running on this project. We are going to go ahead and create a new project because you could have multiple projects within Code Star, and each project could have its own team members, right? Set of developers. So what you want to do is just click on Create a New Project, and then from the left navigation pane, you can select PHP under Programming Languages, and let's go ahead and click on PHP Web App running on Elastic Beanstalk. You could, however, choose Web App running on EC2. In this case, you'll be running on virtual servers that you would manage yourself. So again, these are options that based on your own requirement, your company's requirement, or your project's requirement, you could choose any one of these options. So I'm going to go ahead and select the web app using Elastic Beanstalk. Give it a project name. Let's call it. Scroll down, and which repository do you want to use? We will choose the AWS commit or code commit. We could choose GitHub. GitHub I'm going to demonstrate later on, right? Once I move to the CI pipeline only, running on Jenkins, or using Jenkins and building a Jenkins server. So I'm going to demonstrate this later as well. So for this purpose, for our PHP web app, we are going to select AWS code commit. Click Next, and we get the same pipeline. Notice in this instance, since we're using the beanstalk, right? So the build and test is not listed as part of the pipeline. So we are going to use code commit, and everything is going to be managed using the Elastic Beanstalk. And of course, we can monitor with the CloudWatch. We can, however, directly edit the Amazon EC2 configuration. So if I were to click on this, I just want to show you, we have the instance type T2 micro, our default VPC here, and a subnet. If you already have an EC2 already configured and created, you could use that as well. Let's cancel out of here and simply click on Create Project. The dialog box appears and asks for EC2 key pair because we did not create an EC2 instance, we did not create the keys, the security keys, so it asked us to create or pick a key. And we do not have a key yet, so we need to go to the EC2 Management Console and choose a key pair. So let's do that right on the fly here. So instead of going back to EC2, let's move forward and click on EC2 Management Console. This will navigate you to the EC2 page where we can generate a set of key pairs. Once again, if you already have all of this created, then it's just a matter of going through the process within Code Star. But this is good because as DevOps engineers, you could be, facing several challenging scenarios, right? So you don't have to have created the instances first because all of a sudden you're jumping in, you're diving into it directly, and you're creating it. So I'm going to go ahead and on my EC2 dashboard or within this page, click on Create Key Pair. I'm going to give it a name, call it PHP Web App, and click Create. So this is going to go ahead and create the key. I'm going to download the PEM file. This is the private key file that is going to be downloaded, and you can download it wherever you want. Go ahead and click on Save. So here's the key pair name, and of course we get the fingerprint. So once we have the key pair, let's navigate back to Code Star, cancel. Then let's go ahead and click on Create Project, and this time, once you refresh, it should pick up the, so this is the key pair that we just created called PHP Web App, and simply check the box, I acknowledge that I have access to the private key file. And once again, this private key file is the file that is just downloaded, okay? Because without this file, I won't be able to log on to my instance. So once I have this, and just a note here, just so you know, that EC2 uses public key cryptography, right, to encrypt and decrypt log. And that's what sets AWS apart because it's highly secure. Every communication is encrypted, okay? So go ahead, create project. And this is going to spin up our project as we move along. So if I scroll down, notice it's creating the repository for us. In the meantime, we can select which IDE we want to use. In the previous project, we used Eclipse, and I demonstrated how to configure the AWS toolkit, and we ran our Java Spring application. Here, I'm going to demonstrate using the AWS Cloud9, which is native cloud-based IDE that AWS offers as a service. So let's go ahead and select AWS Cloud9 and click Next. We are going to stick to our T2 micro, which is for each here. That's good. Let's expand the network settings just to verify that we have our default VPC and subnet. Of course, if you do not have a virtual private cloud created yet, you can always create one as well, because you may have certain projects that are running on different regions where team members are spread out in different regions, maybe one in Europe, one in the United States, Australia, and so forth. The environment name and description is provided. So I'm just going to add to this description. I'm going to call it PHP Web App. So once I'm satisfied with the settings here, just click Next. And this is going to set up our project. And at the same time, it's going to spin up the IDE for us. Since we're using the AWS Cloud9, this time we don't have to do additional settings because we're not using a third-party IDE. We're using the AWS itself, Cloud9. So it's going to spin up both of these things for us. As soon as it's done, we should be able to take a look at this. Perfect. So our project has been successfully created. We're still waiting for the AWS Cloud9 for this to be configured. Great. So congratulations, your project and the IDE are set up and ready to use. So of course it gives us a nice blue button that says start coding. Before we actually navigate to our IDE, I'm going to scroll down and notice that we have the same exact Code Star dashboard. So we have our master branch here. The initial commit has been done for us. Our continuous deployment pipeline starts with the source, build, and deployment is still in progress, along with the Amazon Cloud. I can also connect to Altasia JIRA right from here, Agile project management methodology, if I need to use JIRA as well. So let's scroll up here. The application endpoint is still being processed and configured, so we'll just wait for this to configure. In the meantime, I'm going to go ahead and click on Start Coding. This navigates to a new tab and will open up the Cloud9 IDE for us. So in the meantime, I'm going to go ahead and close this particular private key here. So notice as soon as the IDE is launching itself, it gives you some tips and techniques. So welcome to the development environment. AWS Cloud9 looks fairly similar to the Eclipse IDE, right? It has the project explorer pane, it has the canvas area here, or the middle part, and of course some tools on the right. For example, we have the debugger, AWS resources, collaborate, and outline. So just so you know, this is what the IDE looks like. You can scroll down and read about it. AWS Cloud9 would allow you to write, run, and debug code within the browser. So this is pretty powerful because if you have developers across the world, right, they can simply log into the cloud and use this, which is in turn connected to the entire DevOps pipeline running on AWS Code Star, code commit, for example, code build, staging environment, and the deployment. You could also have QA testers running the same IDE and testing the entire application on the AWS environment. So it really brings up the entire DevOps infrastructure, both operations and development, into one area. And that was initially the challenge, has been the challenge for DevOps. I think AWS has done a great job in bringing both of these environments on a single page. I'm going to end this lesson here. In the next lesson, I'm going to talk about the browser and the code itself a little bit further. So I hope this helps. In this lesson, we just spun up a PHP web app. We also configured the IDE, which is Cloud9 AWS. So practice with this, fairly straightforward process. If you have any questions, post in the discussion area. I'll be glad to answer. For this, let's move to the next lesson. Welcome back. Super excited. In the previous lesson, I demonstrated how to spin up your Laravel PHP web app running on Elastic Beanstalk. So within CodeStar, we can now take a look at our projects. So let's jump right in. Click on the CodeStar for AWS services, and this will bring you to the CodeStar dashboard. And you should be able to see two. Great. So we have our PHP project as well as our CD Java serverless Spring Java app as well. So two apps or two projects that we actually configured. So I'm going to go ahead and click on dashboard for the PHP because we like to see the actual endpoints, whether they were configured or not. So I'm going to go ahead and click on dashboard. This brings up the PHP project dashboard. We have our project successfully created. It's spinning up the IDE since we're using the AWS Cloud9 cloud-based IDE. So just take a minute or so. There we go. So once you have this, you scroll down, notice we have our application endpoints and we have the master branch. Great. Let's scroll up. If I were to view the app itself, this is going to open up. Congratulations, you just created a PHP Laravel web-based application. Let's navigate back to Code Star. And if I click on Start Coding, this will open up the Cloud9 IDE, where my developers can now start to code pages within the PHP Laravel web application. So as soon as the Cloud9 opens up, brings up the Project Explorer on the left side, and notice I can expand PHP project, and I should be able to see all of the folders, whether it's the PHP, Bootstrap files, the public folder, even the database. So we can configure our database environment based on our own requirements. So console and so forth. So if I were to click on the index.php, for instance, notice it's the Laravel PHP framework for web. Great. So this way you can now let your developers edit, and then they can start to work with the particular application. The Cloud9 interface is pretty powerful in a sense that it allows you to use the menu. You can create new files. You can choose a file from a template, for instance, right? Whether it's a text file, HTML file, so forth. You can also upload the files and use other tools as well. So it pretty much comes with all of the standard functionality. On the bottom is the terminal. You can run commands based on the terminal itself. On the right side, you have the debugger. For instance, for your app, you have the AWS resources. Take a look at the remote functions. You have the outline, and you have the collaborate, so you can do a group chat with other developers as well. So it's a pretty robust IDE. You can also share. There's a share option. You can share the entire environment by clicking on share, and then this brings up or pulls up the URL for you, and then you can invite. And these are again AWS users, right? So all you have to do is just type the IAM name. For example, I believe I have a user already made, but I'm not sure. If not, you can always create a. Click on done here. Great. So just to give you a high-level overview at this point, because we're not going to get into the development of the application, because we're DevOps engineers, right? So we want to make sure that we are able to support our developers, our QA testers, and other solution architects so that everyone is working on the same page. And if something happens, then you can provide the necessary guidance and assistance to them. All right, let's switch back to our Code Star. And if I scroll down, notice I'll see my DevOps pipeline as well. And my CloudWatch also is now active. On the left navigation pane, if I click on Code, for example, this will open up a new tab. And here I can create additional branches. For instance, I'm working on the master branch. If I need to create more branches, I could do so by clicking on the branch option from the left navigation pane. And I can click on Create Branch, just give it a branch name. I'm going to call this PHP New Branch. And this is going to be from the master as default, and simply click on Create Branch. So now you have a couple of branches. Well, the one that we just created is the PHP New Branch. So if I click on this particular branch, this is going to open up this particular branch as well. And I can create a pull request, or I can clone the URL. I can add additional files as well, just like before that we've been doing. Similarly, my code build, same things. I can build projects. I can take a look at the build history, deployment deployments, applications, and pipeline. I can see the entire pipeline as well. So for instance, the project PHP, the one that we're actually working with here, if I click on the PHP project pipeline, this will show me the entire pipeline from source, which is the AWS commit, build, AWS code build is being used, and then deploy is the cloud formation. What I want to show you different here is the cloud formation. I want to show you the stack of how it's built. So if I were to navigate to cloud formation or just simply click here to cloud formation, this opens up a new tab and will take me to the Cloud Formation Management Console page. And I should be able to see what is happening with this particular stack. And just so you know that the redesigned AWS Cloud Formation Console is available now, okay? So AWS is constantly redesigning and making the environment robust for users. So this is a new environment. So if you're comfortable or you've seen the previous AWS services or console pages, this may look different, okay? Because this is state of the art as we move forward in time. All right, so if I scroll down, you'll notice that there are several stack names that are available to me, and the status are also provided. For instance, first it deployed the Beanstalk environment, and then of course our PHP application was also deployed. And here's our Code Star project name. If I click on this, it's going to give me the details for this particular project. So stack name, the ID, whether it's checked or not checked, and then on the bottom, it's a nice log. Okay, so for DevOps engineers, it's nice to see the events that take place because you want to make sure that you keep track of, let's say, time, the status, the type, logical IDs, and status reasons as well. So you can scroll down and kind of identify and take a look at what is actually happening throughout the process. If I expand the template, you can see the original template. You can also see the processed. And this is the cloud formation template, guys. This is where you would actually use a YAML file or a JSON format, and then you can spin up the entire AWS environment just from that text file, just from that template. Very powerful. But of course, you need a little bit of experience and practice with creating these files. I might do a lesson later on spinning up an EC2 instance using the cloud formation. But if you notice carefully, if you look carefully, provides a description, which is the PHP Laravel web application deployed to AWS Beanstalk, right? That's exactly what we did. Here are the parameters. So it uses the key pair, right, that we also created. The name of the key pair used to make the SSH connection to the EC2 instance. It creates the EC2 instance for us. Also uses the VPC ID here, provides the description. The project ID is provided. The repository name, which is AWS Code Commit repository, has a description. The solution stack name, subnet ID. Then we have our instance type, app name, metadata. If I scroll down, you'll see resources. The code build policy is also made part of this project. And it also uses the S3 buckets and places objects in there. So if I scroll further down, it defines the roles. Here are the roles. Code build role is the role picked up by this template. The artifact bucket policies are made part of this template. Again, this is a pretty complex and elaborate template because we're actually deploying a PHP application using Beanstalk, right? Versus just creating a template and deploying an EC2 instance. So just bear with me here. The idea is for you to understand what the template is and how does it work, what does it do. So similarly, you can define policy name or additional policies within the policies tab. And let me scroll down. It will include the code build project, code commit, repository, source events, And then of course the worker role, the profiles, Cloud Formation trust role. You navigate all the way down to the very end of this template. So at the very end, it just says transform conditions, and then it basically finishes up by the name of the project, which is the PHP project, right? So under repositories, this is our repository URL, our ARN number, or our subnet instance, and the name. Okay, so all of this is in fact coming from this particular file. So if you were to create this file and run it, it's going to spin up the Laravel PHP application, it's going to spin up the Elastic Beanstalk, the roles, and everything that's part of this file. Parameters gives you detail about the key and their values. Tags, of course, we have the key and the value for this particular tag. And we have rollback triggers, we have policy, and change sets, if any. So the stack, or the Cloud Formation, is a pretty powerful tool, scroll up, that allows you to give, or that provides you details about the project itself, right? And that's Cloud Formation. You can create or update stacks. So if you need to create or change sets, maybe detect the drift, change termination protection, you can delete the stack if you like, or you can view it in the designer. So I'm going to go ahead and quickly show you how it looks like once you're working with the designer. So let's click on designer for this PHP project. And this is pretty neat. You will like this because the designer will show you the actual details, right? So if I expand this a little bit so you can see, there we go. So this is your entire template in a visual format, okay? But at first it may look like, wow, so many things, right? But the reds basically are, first one is the bucket, S3 bucket, which is, by the way, created, and then you have the artifact. This is the same Cloud Formation template that we actually ran through, but now you can see it visually and how all of these services are connected and created for you and managed by AWS. So pretty powerful. You can navigate to each one of these, take a look at what these services are and what they do. So for example, we have the Code Star project. Great. So I hope this helps. I just wanted to demonstrate the Cloud Formation, the template, so that you understand visually what's happening at the back end, right? Because as DevOps engineers, really the important role for a DevOps is not to manage the entire pipeline. And if something goes wrong or something happens, how to go about identifying, troubleshooting, and then finally fixing the issue itself, if any. So I hope this helped practice with some of these areas. I know there'll be lots of questions, which is awesome. Best way to learn is to engage among each other. That's how we actually learn. So I welcome your feedback, and then post your questions in the discussion area. With this, let's move to the next lesson.
So in this lesson, we will learn how to create a new free web host. So let's move forward. I would recommend you to go to claydesk.runhosting.com, and on this site you can easily make a new and free web host. So to make a free web host, you'll scroll down and choose the free hosting plan. Click sign up, and it will redirect you to the page where you could fill in your login details and make your free account. So we'll choose ClayDesk free hosting plan, scroll down and click continue. Now it will take you to the page where you have to fill in your login details. So you'll write in your first name, mine is Saeed, and last name Ali, and your company, I'll write in ClayDesk, and then your email address, I'll type in my email address, and then password. After typing in our password, we have to write our address. I'll write my address, and then my city, which is Piscataway, and then my state. And then we need to write our zip code as well. And after that, we need to choose our country. So after choosing a country, it's an optional field if you need to write your phone number. If you don't have a phone, you can leave this field blank. So then we'll agree with the following agreement. Then we'll check this box which says yes, I agree with the following agreements, and write in the CAPTCHA, and then click continue. And it will process our request and send a confirmation email to our email address. So basically it says, congratulations, your web hosting account has been created successfully. Click here to log in. It is ready for you to explore it. So we'll click here and it will take us to the login page. But first we need to verify our email. So we will open up our email address and then we'll verify our account. So this is the confirmation email and this is the login details. So we'll click on email confirmation, and to activate our account we'll click this link. Now as you can see, our account has been verified. Now we need to enter our email address and then our password and hit login, and it will take you to your main dashboard. So in this lesson we learned how to make a new free web host. Now it's your turn to sign up for your free hosting plan, or you could also take your personal plan if you want to create multiple databases.